Alan, are you there? Please unmute your microphone.
I don't think it's here.
There?
Yeah. Can you hear me? Can you see me?
Please unmute your microphone. Yes, I can hear you and see you.
I don't think it's here.
We can hear.
Yeah. Can you hear me? Can you see me?
Please unmute your microphone.
Yes,
Yeah.
we can
Yes, I
see
can hear you and see you.
I don't think it's
Yes,
here.
we can hear.
Yeah. Now we will start the
Unmute your microphone.
recording.
Yes.
Yeah. Please, guys, don't open the live streaming while we are here. Okay?
Yes, that was me. Sorry.
No problem.
Alan, one sent a message on our chat, our on live chat. He said the LinkedIn link for the stream is wrong. Can you fix it? Because I don't have the NuttX channel account on the LinkedIn. I will fix it on our NuttX event site. Okay?
Okay. Just a second. But I think in the LinkedIn, I use the NuttX.event. I don't know. There are many comments here in the LinkedIn.
Okay, no problem. So I'm gonna fix the link in the NuttX events page.
Okay. Yeah. Okay, guys. I think I've just looked in the LinkedIn. I think many people already comment about the link, and now it is fixed. Sara just confirmed that the number of people in the live streaming is okay. Then we can start.
Okay, let me fix it.
I already put the link in the LinkedIn, but I don't know. Maybe when you start a new live streaming, it could have changed, but I don't think it is supposed to happen. Someone put the wrong link, the old link in the LinkedIn, and I cannot ask. Yeah.
Maybe you can comment.
Yeah, I will ask the guy to remove.
Alan, my audio is backing to me.
Yeah, it's fine here. Okay. Okay, guys, let's start the event. I will stop the. Alin, could you please stop the this not the live streaming, but the stop the video.
I cannot stop the video.
Yeah, it was me. Sorry, I was able to stop it. Okay, guys, let's start this. Hey,
so Alan, could you send the YouTube link to the chat? Because when we look at the YouTube link, it doesn't seem right.
Yes, I will send it. Sara is fixing it in our NuttX.event. Sara, the link is already correct in the NuttX.event. No, I think it's the same link.
Not yet. Just a minute.
Okay, no problem. Yes, thank you, Yaoyao. We are fixing it. Okay. So, guys,
I just fixed it. Could you please check if it's correct for you in the NuttX event?
it's updating. Yes, but is the same link now? Let's open view page source.
Now it opened correct. I can see the YouTube video in the NuttX events.
Yeah, perfect. It's embedded now in the event. Okay. So guys, let's start this great event. It's a pleasure to be here. I am really glad to have contributed to make our small community increasing and getting better year and years. And this year, instead of asking the name of the people, I will say the name of the country and people here, the speakers. Please turn the camera on and say hello. Okay, hello from China. Hello, hello Yaoyao.
Hi, hello.
Hello from Japan. Who is in Japan? Please turn on the camera and say hello. Yes, Yuichi. Okay, nice.
Hello.
Okay. Hello from France. Phil, where is you, Phil?
He just joined.
Okay. Hello from Sweden. Sweden.
Wait a second.
Yeah.
Yeah,
Hello from
it's me.
Sweden.
Hello.
Nice. Okay. Hello from Brazil. Sara, Gustavo, where are you guys? Flavio. Oh, nice. Okay. Too many countries I can remember. Swiss is Robert, correct? Roberto?
Yes.
Yes, Swiss.
Yes, Romania.
Romania. He's from Romania. Say hello.
Hello.
Hello. What other country I forgot?
Czech Republic, hello.
Czech Republic. Hello, Michael. Okay, I think now we have everybody here. Maybe Phil. Hello from France. Say hello, Phil. Okay, great. As you can see, guys, we have people from many countries work on this project. So our community is increasing year by year, and we are small, but we believe together we are bigger. And I want to thank all participants, all the speakers, to do this great event. I know it's not easy to do these presentations and spend time to do it, time that you could be with your family, with your wife and husband, and you decide to drop it to be here and to create this event. So thank you very much. From now on, I just want to thank you everybody to be here. But from now on, I will send the my word to Alin. I will pass the baton to Alin, so he present about a little bit about how NuttX is evolving, and he talk a little bit about our contributors who donate some hardware, some boards to make some prize for the participants. So Alin, go ahead, and thank you everybody to be here. I am really glad to help a little bit to make it happen. Okay.
Thank you, Alan. Hi, everybody. First of all, I want to thank all of you for joining the community and being part of the community, because in the past 2 years, we did great work and the number of contributions in software has increased. Also, the contribution quality has increased. I will not spoil the numbers. I will have a presentation in the second day with the numbers and the contributions by individuals and by companies for the next 2 days. So this is just a small teaser. So I want to thank you, both the individual contributors and also the companies that helped us develop both code, and they also helped us by donating different hardware pieces that we will distribute after each session. We will have a small raffle, and each one of you has the chance to win some development boards from different companies that helped us organize this event by donating the hardware. Without further going into the details, I invite Yaoyao to host the first presentation. Yaoyao, are you with us?
Yes, I'm here. Let me share my slides. Yeah. By the way, the NuttX event, the streaming there is kind of stucky. Okay. All right. Can you see my slides?
Yes, we can.
Yes.
All right. Okay. Perfect. Okay. All right. So I'll start. So hello, everybody. This is Yaoyao from Xiaomi.
Your slide is not displayed.
Oh, it is not. How about now?
It's appear here for me.
Now it appeared. Thank you.
Okay. I guess
But now I can't see her.
Like before, can you see both my slides and myself?
Yeah, you need to go back to your camera. You need to click in your camera button again to appear.
Yes, now we can see you. Thank you.
Okay, great. All right. So today I would like to introduce a project we have been working on. It's called Xiaomi Vela. It's an IoT operating system built upon NuttX. Just briefly by myself, my background is mostly in embedded system design, especially in the wireless and IoT domain. I joined Xiaomi about a year ago, and before that, I was with Texas Instruments and Google for several years, and both working on IoT-related technologies. In Xiaomi, I'm responsible for leading the Vela project, as well as a bigger effort for building Xiaomi's consumer IoT platform. So my talk today consists of 4 parts. First, I want to introduce Xiaomi and Vela. I will talk about who Xiaomi is and why we have to develop Vela. And after that, the organizer of this event asked me to give a quick intro about NuttX for people who are not familiar with. So for the second part, I will give a brief introduction about NuttX and why we decided to use it as a foundation of our system. And third, I want to talk about the approach we're taking while building Vela. I will also present the latest status of the project, including what products have we launched with Vela inside, as well as our future plans. Last but not least, we have made lots of important enhancements to NuttX along the way, and I want to talk about those enhancements and introduce the team who have been working on it. So let's dive in. First, I want to take a few minutes to introduce who Xiaomi is. Xiaomi is a Chinese company founded in 2010. We started as an Android phone maker and later became one of the leading smartphone provider worldwide. Just recently, in the past quarter, we became world #2 smartphone brand in terms of global market share. Besides the smartphone business, we have been quite lucky in the consumer IoT space as well. We're one of the largest consumer IoT platform worldwide with 351 million connected IoT devices. And this number does not include smartphones and laptops. Our users are also very devoted to our ecosystem. We have 6.8 million users with 5 or more devices connected to our platform. We also have an app called Mi Home app, which serves as a main interface for user to configure and control the devices. We just reached 49 million MAU in March this year. So this next slide is just another marketing material, which I will go over quickly. Xiaomi maintains AIoT leadership across lots of key product categories in mainland China, and we have #1 market share for smart TV. We are #2 for smart band and #3 for TWS earbuds. We're also very strong for smart appliances and home security. Our air purifier and smart door locks are selling very well, both #1 market share. We're also a major smart speaker provider in China, and we rank #2 with about 30% market share. So that leads to our next question. Why do we need to develop Vela? This picture shows a tip of the iceberg of the problems we're dealing with on a daily basis, a huge but deeply fragmented consumer IoT market. We have over 2,000 SKUs, ranging from very simple devices to much more complex applications. Our cheapest BLE home temp sensor costs less than $5, but even our low-end smart speaker runs on an SoC with 4 heterogeneous cores. So we desperately need to build a common software foundation to unify all these. So since late 2019, we have been developing an IoT OS that serves as a common software across all IoT applications, and we named it Vela. Vela is built upon NuttX, kind of similar to how Android is built upon Linux kernel. For the initial phase, we will focus on 2 major subdomains of the consumer IoT space, the smart home and the wearables. We will first enable smart home, smart speaker, and smart sensor devices, as well as smart band, smart watches, and earbuds. These applications requires lightweight and scalable operating systems with good low power support. And Vela and NuttX are perfect to serve those needs. So that is a brief intro for Xiaomi and Vela. And next, I will give a quick introduction to NuttX for people who are not familiar with. Okay, so let's talk about what is NuttX first. NuttX is a real-time operating system developed by Gregory Nutt. As its name indicates, NuttX is a Unix-like operating system. And we like to think it is more like a tiny Linux. The APIs and the development environments are very similar to the Linux system, but it was completely written from scratch and optimized to be much more lightweight. It was first open sourced in 2007 under BSD license, and later undergo incubation by Apache Foundation in 2019. So where is NuttX used? NuttX has been used in lots of areas. Sony has used it in their digital audio recorder, and Fitbit has used it in their fitness trackers. Both PS4 and MicroROS are 2 open source communities for drones and robots, and they both heavily use NuttX. NuttX was also forked by Samsung's Tizen RT and Google Aero projects. And we, as in Xiaomi, are also using it in many consumer devices. And I'll talk about those in later slides. Okay. So next, let's talk about why we choose NuttX. We actually did a little shopping and compared all the popular RTOS. And the #1 reason we chose NuttX is because it is a standard compliant. Here, the standard is mostly referred to POSIX compliance. In this regard, NuttX is quite unique, as a lot of the RTOS claim to be POSIX compliant, but most of them just wrote a wrapper layer for the pthread APIs. NuttX is the only one that is designed from scratch as POSIX compliant. This is quite important for a modern RTOS, as porting effort for existing Linux programs and the libraries can be minimum. This also makes it very easy for Linux developers to adopt NuttX as a cost-down and real-time alternative for a Linux-based system. The second reason for our decision is NuttX is designed as extremely modular and scalable. With kconfig getting integrated into the entire system, NuttX can be very elastic and perfectly meet our needs to scale from low-end simple device to high-end complex systems. And third, NuttX supports very rich kernel features and support lots of advanced OS functionalities. And reason number 4, as I mentioned in the previous slide, NuttX is a mature system and it's been used in many products. And it's also available on almost all the major embedded platforms, such as ARM-A and ARM series, the Atmel AVR, the microchip MIPS, as well as RISC-V and Espressif ESP series. You can get a full list of supported model and boards from the NuttX Apache website. The maturity and availability of an RTOS is definitely essential. Reason number 5, symmetric and asymmetric multiprocessing are big trends for modern embedded systems. NuttX is unique as it has good support for both. And in fact, our team contributed in the NuttX AMP framework, and I'll talk more about it later. Reason number 6, NuttX is currently under Apache 2.0 license. It's a very open license. It's easy to contribute and redistribute. So the last reason is NuttX has a very active developer community, and people are doing great work together to make NuttX great. So that's a quick intro into NuttX. Next, I want to talk about the Vela approach, progress, and plans. Okay. So this picture shows the overall system diagram of Vela. The bottom yellow part is NuttX kernel. It provides the basic OS functionalities such as the scheduler, the IPC, the file system, the networking stack, and device drivers, and the project management. And for this part, our development guideline is we will stay in sync with NuttX mainline as close as possible. We will do a sync with the mainline about every 2 months, and we upstream our changes back to the mainline as much as possible. The green section above the NuttX kernel is the Vela application framework. The way we plan to tackle the fragmented IoT space is by making Vela also modular and scalable. And we see this application framework as a middleware. It's a collection of libraries, utilities, and frameworks that enable various IoT applications. For example, we designed multimedia framework to support audio playback and record functions with flexible filter graphs so that application developers can quickly spin off a speaker or earbud applications. We also developed a sensor framework which decoupled data source and data algorithms with special low power considerations to enable wearable applications. We also support various SDKs. For example, IDM is short for Intelligent Device Mesh, and it's a Xiaomi interconnect protocol for discovering and communicating over local Wi-Fi and Bluetooth connections. Cloud SDK is used when communicating with Xiaomi Cloud, and AI SDK brings Xiaomi ASR and NLP capabilities to embedded devices. The lower row of the application framework are some common utilities and libraries, such as Bluetooth stack, which includes BLEDR, BLE, and BLE mesh stack. In the near future, we'll also support BLE audio. We provide various OTA options, key value database, RPC framework, GUI library, and GS engine and security engine. So we will continue to extend the capability of Vela application frameworks as we serve more and more IoT applications. And the green section on the right covers the tools, including IDE, the GUI designer, the PC emulator, an auto test framework, and the usual log and debugger tools. Since we have limited time today, I won't go into details, but these are actually quite essential for developing on an RTOS system. So they probably deserve a dedicated session next time. Okay. So that explains the approach we're taking for developing Vela. Next, I want to talk about the progress we made so far. Last year, we launched the first VelaLT module. It's a Wi-Fi and BLE dual mode module. Manufacturers can embed this module into their devices, and they will automatically acquire capabilities to provision their device onto a Wi-Fi network, connect to a Mi Cloud, as well as interact with other devices from the same ecosystem. And since then, we have empowered 12 different IoT devices. Some of them are quite interesting. Even I didn't expect them to exist, like a knife sanitizer. But just want to give you a general idea. I listed some of them here. So these are the IoT devices where some of the IoT devices we're making. Okay. And this year we have been focused on this new application, and we just launched our first Vela smart speaker on August 3rd. It's not just a smart speaker, it's also a universal IR remote. You can use it for voice control your TV and air conditioner. It also acts as a smart home mesh gateway, so you can voice control your smart lighting system to set up a movie mode, or your vacuum robot to start cleaning the house. It's quite sleek. Okay, and talking about future plans, next year we will extend the capability from smart home application to wearables. We kind of see Vela as a little girl, so I put a little girl's picture up there. So as we extend to new application areas, this girl just really grows with more capability and accomplishes more. Okay, so that closes the third part of my presentation. And last, I want to talk about some of the key enhancements we made to NuttX. Okay. So we have been contributing to NuttX open source project since year 2017. Along our journey, we have made some important enhancement to NuttX. So we summarize them in 7 categories. We contributed the NuttX AMP framework. We are also key maintainer for the simulator and other ARC support. We enhanced the file system and drivers. We also optimized the system performance and improved the debugging experience and developed some new tools. And I'll talk about each one in just a little more details. Let's talk about AMP first. AMP is short for asymmetric multiprocessing, and in the current IoT world, the heterogeneous multi-core architecture is becoming more and more popular. It has significant advantage in achieving a good trade-off among performance, cost, and power consumption. An OpenAMP is an open source implementation and commonly used on non-Linux systems. We are a key contributor to the OpenAMP, and we developed zero copy and two-phase handshake, etc. features on OpenAMP. We also ported OpenAMP to NuttX and actively maintain it. OpenAMP establishes a low-level messaging channel between multiple cores via shared memory, and it's called RP message. We implemented upper-level services on top of OpenAMP RP message to provide syslog, TTY, hostfs, network, user stock, and so many other capabilities so that it can be more useful for application developers. Okay. And the second enhancement I want to talk about is the debugging capability, which is normally a weakness for RTOS versus other systems. And 2 parts of our work are worth to mention. One is the NuttX simulator. We developed a lot of key sim drivers such as the SMP, audio, frame buffer, network, Bluetooth, and so on. And with this enhancement, developers can run their application code along with the NuttX system to emulate a complete multi-core devices device on the host machine. And with some advanced debugging tools on the host, developing on a simulator can greatly speed up application development. We also enhanced NuttX debugging tools. We ported ASUN and UBSUN to NuttX, so memory corruptions and stack, Yeah, we have an intelligent lighting system, so it turns off lights when you're not moving. With some advanced debugging tools on the host, memory corruptions and stack problems can be debugged more easily. And we also implemented backtrace and dump functionalities. And the debugging experience is a lot better now, but it is still not fully catch up with the Linux system yet. So we actually want to shout out to the community and let's be creative and work on it together. Okay, so since we have limited time, I won't go into each one in details. And for people who are interested, here is a non-complete list of the major features we contributed to NuttX. And I'll just pick a few major points and talk about those. So I already talked about AMP and the same platforms, and I'll next talk about the file system enhancement we made. So one thing we did, which is quite unique, is we unified the socket and file interactions so that socket also use standard FD handles underneath, and now you can do a dupe on the socket more conveniently. And number 4 is we enhanced NuttX driver system and unified the sensor driver model and developed some more test tools. And number 5, we did lots of subsystem optimizations. We boosted ELF loading speed by 100 times. We also enhanced the NuttX TCP/IP stack and improved lots of key networking performance for actual user scenarios. And number 7, application-wise, we are a Little VGL committer, and we're actively maintaining Little VGL in NuttX. We're also a member of the Walmart Technical Steering Group, and we ported and maintained Walmart and Watson 3 WebAssembly engines. Okay, so that's a quick recap. And for people who are interested, feel free to reach out to us for more information. Okay, so last I want to introduce the Vela team. This is our team. We have about 20 people now. Some other teams in Xiaomi also support us, so it's a very collaborative effort. Xiaoxiang, whose picture is on the bottom left, is our chief architect and leads the overall technical work. He is also very talented and has committed over 1,200 patches to NuttX. So that is our team. And the last thing I want to say is we greatly appreciate the opportunity to work with the NuttX community. And we appreciate all the open discussions and great advices from the people in the community. It's definitely very open and collaborative, and hope we can continue to work closely together and let more people to know about NuttX and adopt NuttX to benefit their lives. Okay, so thank you for staying till this part, and this is the Easter egg part of this talk. And in this part, I want to briefly explain why we take the name Vela. So we always envision the IT space to be a big ocean of devices, and there are so many of them. So we wanted to find a name that is associated with the meaning of ocean. So Vela in Latin means sails of a ship, and it is also a name of a constellation in the southern sky that is in the shape of sail. It also sounded nice, so we pick it as a name, and now we can see ourselves as a sail in the sea of IoT devices, I guess. So one last quick story I want to share with you. When we first talked to Mr. Gregory Nutt about the Vela, he actually gave us another interesting point about the name. It turned out Vela also means candle in Spanish, and there is a famous saying in Spanish which is very interesting. I think for people who know Spanish, you don't have to Google, but I put it on the slides. For people who are interested, feel free to Google it. Okay, so wisdom from our man, Greg. Okay, so finally, that closes my talk today. Thank you very much for your time. I put an email up there, and please feel free to shoot me any questions you have. Okay, thank you.
Thank you, Yaoyao, for the nice presentation regarding Xiaomi Vela and the history of NuttX. Now that the first presentation is over, I would like to invite you to a small raffle, because as I said, we have hardware from different companies which donated the hardware. And for the raffle, I will use the random number generator. Let me get it online.
Alin, also, maybe we can have some questions.
还没选好，但是应该我们会给 speaker 礼物，我们不给那个。
Yaoyao, please mute yourself.
Yeah.
Sorry.
No problem. Let's see if we have the first question from Marcelo Barros. Could you give more details about your Bluetooth implementation integration, Yaoyao?
Yes. We actually. Okay. We didn't want to reinvent a lot of wheels. So for this initial version, we actually started the work based on lots of open source implementations. So for the BR-EDR, we integrated Fluoride, which is the biggest Fluoride stack used on Android. And then for the BLE mesh, we adopted the implementation from Zephyr community.
Yes, I remember this discussion. The idea was to use the external Bluetooth support from Zephyr. We also support the Bluetooth from Nimbus. There's some people working on it. That's nice because we can have the better of both worlds. It means we can use all the features from NuttX, but we can have the Bluetooth from Nimbus or Zephyr that is more evolved than the original Bluetooth from NuttX, right? That's correct, right?
Yeah.
Yeah, I think the one from NuttX actually is a very old version from Zephyr, right? Yeah, so we basically took the latest version from Zephyr and work based on that.
Yeah. In fact, the original stack, Bluetooth stack used on NuttX came from Intel. Before creating Zephyr, they released that Bluetooth stack, and it became the Zephyr Bluetooth stack, and also Greg used it on NuttX. So both stacks have the same ancestor, the same original code, initial code, I mean. Yeah. Okay, thank you, Yaoyao. Let's see, we have more questions. No, I think that was only it until now. So let's move, Alin, to the raffle.
Yeah. Yes, for the first raffle, we have 7 participants. As a reminder, you can enter in the raffle by clicking the link in the YouTube channel during each of the presentations, and after each presentation there will be a raffle, so you have more chances to win some hardware from our dear companies that donated hardware for us. So I will just go to the random.org. I will generate a number between 1 and 7, because 1 and 8, apparently we have another participant. And the first number is 2. In my list, that corresponds to Marcello Barros, I think it's the name. We will announce later what hardware Marcelo won. So the hardware assignation will be done in the last day of the last raffle, and we will announce which hardware people won. Apparently now we have 10 people that entered the raffle. The next one is number 5. Number 5 is just 3 question marks. Can you please write your name somewhere? Okay.
Alin, maybe Sara have this, or you having the names. We can write it on the YouTube channel to people know.
So, some people, unfortunately, instead of writing their names, have just put a number, or they put 3 question marks. So it's really hard for me.
But we have the email. It seems the name is Ismael.
Okay.
I guess so. That is why I mark them, and then we will decide. And the third person, the third winner, is called Abi. He has number 8 in the list. Okay. 1. Okay.
Yeah,
so
Ismael Luceno. He just dropped a message in the YouTube channel.
Okay, so we have 3 winners for this raffle, and we will continue with another raffle after the next session. In the meantime, I invite you to take a short break and see you in 5 minutes or so for the next session.
Okay, we have another question in the YouTube. I don't know, maybe others here can give more information. Hotis Land is asking, is there any plan to support memory paging algorithm in NuttX? Sorry, the external noise. I live in a tourist city here in Brazil, so it's very noisy all the time. Can you hear me, guys?
Yes, I can hear you and see you.
Yeah, I think about memory paging. If I'm not wrong, Gregor Nutt implemented it some years ago to RPC 31 family. So memory paging is already supported on NuttX, but is not commonly used. But yes, it's already there. So there is no reason to not use, but probably you need to test it on your hardware, or maybe you need to do some modification to get it working. If one others here have more information about it and want to share it, please. We want to hear from you guys. Philippe Koval has some comments. What? Okay, he's talking about the project he implemented for his presentation. He did using the board he got from the last year. I think Philippe is here, right? In the participant already.
Yeah. I was just suggesting to the winners to try to make it run on, try to run NuttX on their board, and if they need some support, feel free to create a issue on the GitHub or find the different channels, because I was in similar situation last year. I won a board and I wanted to make it to use it and to improve the support. So I was suggesting to the winners to try the same.
Yeah, if you want to, because we have a little bit more time, if you want to give just an overview about what you did with this board.
Okay.
And I got many ideas from you, because I never used the FIFO the way you use on NuttX. it was very powerful feature because we can get the output. It's like Unix. You can get the output from one command, pass to other command, and send it through the TCP or UDP. It's a very clever idea.
Thanks. So yeah, I received a board with a sensor, and during we had a lockdown in France, and we were supposed to work with some friends at university around an open source vehicle. And since there was this restriction, we were not granted to work on this device. So I try to imagine some things that can be done remotely. So for this, I use this NXP Freedom board I received from last year, last workshop, and I managed to make it run, and then I wanted to upstream all the needed change into the project, and so it can be interesting for newcomers to NuttX to see how can they improve support on whichever board. It doesn't really matters, but I explain my journey into doing this. So that's not something maybe useful for hardcore developers, but for new joiners, this is made for you.
Yes, and it is very nice because you use the Mozilla web things, right?
Yeah, but I don't want to speak too much. Let's listen to others.
Yeah. Otherwise, we are doing spoiler on your presentation. Yeah. I agree. Yeah, but it was a Kinetics board, Kinetics microcontroller, right? If I'm not wrong.
Yeah. It's I use this the NXP Freedom 64F.
Oh, it's the Kinetics K64, right?
64, yeah.
Yeah, great. Okay, I want now to ask people to talk a little bit how they discover NuttX, how was the first contact, okay? Alin, can you start with you? How you get involved with NuttX?
Yes, unfortunately my camera stopped working, and since I'm streaming, I'm unable to restart the session. So please bear me just with voice. So we started working on the NuttX SDK for the Spresense board. The Spresense board has been presented in the last two workshops, so I will not go into the details. And the SDK was using an old version of NuttX. So I got acquainted with it, and then we decided that we should upstream support for the board. And during last year, we did the majority of the upstreaming, and this year my colleague will present all that road and the fact that the SDK now uses the mainline NuttX. Another spoiler for his talk. I think that this kind of journey is really interesting, and others should also participate and see that you can develop something on mainline and have it properly maintained. So I basically fall in love with NuttX, feeling at home since I'm a Linux user and developer on embedded Linux systems. And from there, I just started looking at the niche aspects of the operating system, since there are things that usually get overlooked by the community because community doesn't need them, but they are quite critical for companies. So I just put the company shoes and looked at what would a company want from an open source project. And I will present tomorrow some of my findings and some of the work that I did in the past year to improve NuttX, not only for Sony, but to improve NuttX as a project, as community, and as a base for other companies that want to use NuttX in their own projects.
Oh, nice. Thank you. I think Michael wants to talk a little bit. Michael?
No. I just connected myself once again. I disconnected myself for a while.
Okay. But by the way, Alin just finished. Could you please talk a little bit how you get in contact with NuttX? How you discovered NuttX? How was your involvement with the project? Just a little bit, 1 or 2 minutes, just to talk a little bit how you discover it and how you get working with NuttX.
Yeah. Okay. Just a second. I will turn on my camera.
Go ahead.
Yeah. Okay. You should see my camera now. Well, so basically, I started working with NuttX a year ago at my university. It was when I was trying to find someone at university to work under, and I found Dr. Pavel Pisha, and he introduced me to Czech company Electroline. They were looking for someone who would port FlexScan driver to IMX RT MCU and also create a board support package for Teensy 41 board. So it was basically my school summer project a year ago. That's where I discovered NuttX, and I started working with NuttX.
Okay. And before working with NuttX, did you already work with pysimCoder, or it was after NuttX? How you get involved with both projects?
It was after NuttX. I first discovered pysimCoder, I think in January or February this year. So I started with NuttX, and then I discovered pysimCoder.
Oh, nice. So in few months, you master both projects and get they working together.
Well, I wouldn't say I mastered it, but yeah, I experimented with it.
Yeah, I think you are doing a very good work, and I am looking forward to watch your presentation, and I am sure it will be very good to see the power of pysimCoder running over NuttX. Yaoyao, okay, thank you. Yaoyao, could you please talk a little bit? By the way, I forgot to thank you for your answer, your response for the questions. Sorry. Thank you for helping us. How you and Xiang Shao get involved with NuttX and how you discover it? I think Xiao was before you, right?
Yeah. I have Xiang here, so I think maybe
Hello.
you want to share.
Yeah, please.
Nice to meet you.
Nice to meet you, Xiao. Don't be shy. Go ahead.
Okay. Yeah. Yes, I think the NuttX is a great project because from my background, I'm work for Linux for more than maybe 10 years. So I need a environment which is very familiar with the Linux and the process. So after I search the available choice from the more than 10 others, and finally I found the NuttX is the best choice at that time because the NuttX design is very similar with the Linux kernel, and also is process compliant. So it's very useful for the developer come from the Linux world. I think it's very because in recent 10 years, many Android development very the Android development ecosystem is very good, very fast, and so we can get many people which is very familiar with the Linux and Android environment. So the NuttX is a very good choice for this kind of guy. Yes.
Yeah. And because it's very similar to Linux, it makes it easy to port, right?
Yeah. Okay, that's my thinking. Thank you.
Okay, thank you, Xiang. Okay. We have more people here. Gustavo, want to talk a little bit? How you discover NuttX and how you get involved with it? Gustavo, can you hear us? Okay.
Yes, I can hear.
Nice.
Right now,
I think
my baby, it's right beside me.
Yeah, I think your daughter wants to talk a little bit.
Yes, she wants to participate in the live streaming.
Sure.
Say hello to everybody. So my journey with NuttX started, I think, some 3 years ago. During when I worked for Fundação Search. It's a research and development company here in Brazil. And we started evaluating NuttX for our projects. Usually, Search's projects are Search develops projects for some customers. So it delivers a complete solution, either sometimes as a complete hardware solution or just the firmware. So we at that time we evaluated NuttX for the solution. We began training and participating also in the community. And if I'm not mistaken, in the last 2 years we started. We anymore because I'm not at site anymore. But I took part on that decision making.
Yeah.
So at that time, we could add NuttX in some projects, and it was quite a good decision. Like Alan said before, the NuttX POSIX compatibility makes everything, let's say, easier for supporting libraries that previously worked for Linux. At that time, we developed our applications using C++, relying on the libc++ support for the standard library. So, and using NuttX, yes, it was simplified the development of the final application. And now we're working for Espressif. I am here and now have the opportunity for contributing even more for the development, both for the OS and also for the Espressif chips. So expanding even more the user base for the RTOS.
Yeah, and I know we cannot say the name, but I know you work in Fundação Search for projects like for a big electric motor company here in Brazil that we cannot say the name, but some people will realize. Though it's nice to see NuttX used in many companies and many projects. Yeah.
Yeah, in several areas also, just both for IoT gateways we've worked on before, also in some other devices, controllers. So NuttX is really versatile regarding this aspect.
Yeah, I agree. Thank you, Gustavo.
For nothing.
Okay. Talking about the industrial IoT, Flavio, do you want to talk a little bit about your start with NuttX, how you discover it, how you use it?
Yes, sure. My journey, let's say, with NuttX started not so much time ago. It was 1 year and a half, where I was working on the evolution of the firmware for my IoT gateway for industrial applications. And I have a previous firmware running on bare metal, FreeRTOS architecture. And then I was looking for an operating system that was more, let's say, it seemed to be less like a bare metal solution. where I could expand it to you to provide APIs for customers to something like that. And then I started to search on the market for solutions for this, and then when I found NuttX and I tested it, then I figured out that that's the way to go, because mostly because of its similarity with Linux software development and the flexibility to for different kind of setups. It was pretty nice. And then when I started the project, I contracted a person to help me, Oliver. I don't know if he's around.
Yeah.
And he did most of the difficult part of board support. And I started just after on the application. And when I started the application, I got involved on the support, on the mailing list, on the community, and then I'm there since. But it is amazing the similarity with Linux and the POSIX standard and the aims to implement to develop software in NuttX for microcontrollers if you are already a desktop software developer.
Yeah. It makes our life easy. Okay, guys.
Yeah.
Okay, Flavio. Thank you very much.
Thank you.
Okay, guys. We are on time to the next presentation. Alin, do you want to introduce the next participant? Can you?
Yes, I was typing to Ricardo so that he prepares sharing the screen, but I will do that. So the next presentation is about NuttX support on ESP32 and will be presented by Ricardo Tafas. Sorry if I misspelled your name. Ricardo, can you please share the presentation?
Yes, just question. Are we going for the PowerPoint or the video that I submitted?
If you want to play the video, you can play the video from your own computer.
Okay.
Or if you want to do it live and keep that one only as a backup, the video as a backup, then we can do it like that.
Yeah.
Okay, I think we can go live, and if we need, we can use the backup video.
Super. Please start your camera and presentation.
Okay.
Yeah.
Sorry.
Ricardo, just a comment. You need to start your presentation, go back to JIT and clicking on the camera. Then it will put you in presentation mode. So your face will appear over the camera, like Yaoyao did. Okay.
Okay. So just a second. Let me get the steps here. I think this is not the presentation. Is it okay now?
We cannot see your face yet over the camera. You need to return to JIT, click on the camera button. It will enable the camera over the presentation. Yes, now it's working.
Yes.
Okay. Well, I just did that, and for some reason it didn't work. Okay. Okay, so let us start. So I'm Ricardo. I work as a software manager for Espressif. I take care of a few projects, and one of these projects is Just a second, I have an issue here. I think we can go with the video because my presentation here is auto-changing again, and this already happened. I don't know what configuration I did wrong here on the slideshow. Can we just go with the video?
Yes, Alan, can you play the video since I'm broadcasting, or should I do it?
I think, Ali, it's better you do it because
I can play the video here, I think.
Okay, then press the three dots near the close call icon,
Yeah, okay.
and then you have share video.
Yeah.
Oh, it should.
Yeah.
It should be on YouTube.
Yes.
Alan, can you? I don't have uploaded it to YouTube. Just send you the link.
Yeah, we have it on our Dropbox. Sorry, in our Google Drive, and I will put it just a second.
Okay. Thank you.
No problem. Let's find it here. Share with me. Maybe Alin, I will give it the link to you because I don't know if it will fail if I try it.
Sure.
Sure.
Let's see.
Yeah, I can try. If we realize it's not working, I share it with you.
Okay.
Share. I think I need to go share and change restriction. Change to everyone. Okay. Yeah. Copy link. Go on.
No, I think I figured here the configuration. I think we can go live again. Sorry.
No problem. It's better.
Yeah. No problem. I just figured here. For some reason, the manual slide change was not set. So let me go again. Okay, so as I was saying, this is a little quote from one interview on EE Times that Tio Silviu, our CEO, gave regarding his feeling on Espressif and regarding his feeling on open source. And this is a little bit another quote. This one is on our website, on the People at Espressif page, regarding the feeling that what brought Ivan, our VP of Software Platforms, to NuttX. Just question, can you see me, because I shared the video last time, it didn't work. Is it working?
No, unfortunately not.
Is it okay now?
I can see you, yes.
Yes, I can see it here.
Okay, now we're good to go. So, so speaking a little bit about, to put some context, ESP-IDF is the flagship tool that we offer to customers. It's based on FreeRTOS. It's an open source project. It's not a regular IDE experience. But it's where we built all our software and what we suggest customers to use. Currently, it's on version 4. I think the stable version is 4.3. But although it's an open source project, it's a little bit different in a few senses because it's not the regular community open source project experience. We do share the code on GitHub, but we kind of kind of no, we own that GitHub. It's on Espressif's account. It's not on the community, on the main project, upstream project community. Due to those two point of views that I just presented, Espressif started to get into the idea of not only using open source projects and kind of side contributing to it, because it's open, but it's not on a direct contribution. Someone from the main project would have to go to our project and pick the change and eventually just...
Sorry for the interruption. Your slide has disappeared. Can you please reshare your slide? Because in this moment we can just see, hear you. We can't see the slide.
Okay. And now I have to enable the camera.
Ricardo, are you using Firefox or Chrome?
Firefox.
Do you have Chrome browser?
Yes, I do.
Is it possible for you to move to Chrome browser? Because yesterday on the warm-up, we had some issues with speakers who were using Firefox.
Now it works. I could see the presentation on YouTube.
Yeah. I think we are returning to the era where this feature or this website only works on Internet Explorer. Now it only works on Chrome.
But is it okay now, or should I go forward with Chrome?
Now it is okay. I'm looking at your slide and your camera on YouTube.
Okay, so let's keep it and not touch it. Okay, so is it still okay?
Yes.
Okay, good. So as I was saying, we decided that the company decided that it should be contributing more to open source projects, not side contributing, kind of providing code that people can look into, but also forward those changes to the main projects. So in April 2020, a little bit more than a year ago, the company started third-party frameworks or third-party platforms team. Currently, we work with NuttX, Zephyr, and MC Boot. Of course, we do have some other ideas, but they are still too preliminary to. Location for this team is mostly in Campinas, but as would be expected, we do collaborate with several people within the company on the main offices, which is we do also have a few remotes that are currently on a full remote position, or eventually we will relocate to one of our offices. So this team is a little bit different from the current work on ESP-IDF, as our goal was to contribute and forward this contribution to the main project. This is important because it sets a lot of strategies that we have adopted for the supporting of our devices. Also important to note during this presentation that although Espressif has either announced officially or someone has found through some obscure commit on our GitHub a new device, but currently available for purchasing to put into products and to build systems with, we have ESP32, ESP32S2, and ESP32C3. So everything that we are going to talk is going to be on top of those devices. And like I said in a few posts around, there will be spoilers on our more general strategy for what's coming. So just as also a general, how can I say that, a general strategy, how we would approach our devices. Of course, the first things should come first. We have to support the CPU to have it running, to see some shell on it. For that sense, there are a few peripherals that are mandatory. Without the CPU, there is nothing, so it's quite obvious that this one would be the first thing to look into. Second, it's a Wi-Fi MCU after all. If we don't do Wi-Fi on our MCUs, it's going to be just look like a regular MCU. So Wi-Fi and Bluetooth when available. Second things to support. And after that, some basic peripherals. If we look into a device that has a GPIO and some Wi-Fi, we already have something for IoT. You can control the light bulb and you can do some basic, very basic IoT applications. So this is the order we have adopted. Of course, after that comes SPI, I2C, and all other peripherals. Some of them, due to ESP32 architecture, they are mandatory. But some of them, we can just do them later as we progress with the port. And just like I said, this team is different. It's not our goal to fork projects. The idea is that we contribute directly to the community. To do that, we have to comply to standards and community rules, and also to help this community to thrive, and eventually hope that our contribution will allow the community to grow. So that said, let's dive into the support itself. So this is a small list of the what we think it's the more important features on ESP32. It's a full feature device. It has a lot more than this. But on what we think it's important, this is our current status. To note, some points to note on this list is Wi-Fi. Since Wi-Fi is really important to us, it's work in progress for forever. So we will always be doing something Wi-Fi related. So even when we are done, there's always a way to make it faster, reduce memory footprints and stuff like that. Second, there's some features on ESP32 that we think are really important for the IoT space, which is the low power and especially the dynamic frequency scaling, which we're thinking and seeing how we can support that. And also to notice, we have the ULP, the ultra low power processor, coprocessor. It's already not, it's supported through IDF, but not supported on the regular project flow on NuttX. So this is another thing we're thinking how we're going to add support for that. So as you can see, it's a pretty decent support. It's pretty sufficient for most of IoT applications. And there are some peripherals here we are still on planning stage to support them. The ESP32S2, on the other hand, our support has just started about 1 month, I think, something like that. So it's quite recent. We already have the CPU supported, and most of our peripherals are not supported here yet. One important point to notice here, ESP32S2 does not feature Bluetooth, but it features USB on the go. So most importantly, I think for these devices, USB on the go currently released is the only device that we have that has USB on the go capacity. It's most likely that we're going for Wi-Fi, and right after Wi-Fi, the USB on this device. And also the ULP here, it was our first RISC-V device. People don't know it, but the ULP for ESP32S2 is a RISC-V core. So yeah, once again, we have to figure a way to support it on the project flow. For the ESP32C3, which most people think of it as a replacement for ESP8266, also the support is quite broad. Also to notice, it doesn't feature an Ethernet MAC, and it also doesn't feature an USB. The USB that it has, it's more of a console. It's a USB to serial in chip, so it's not a USB that you can quite use for very general purposes. And it also features a ULP that we also have to handle. So this is the scenario for a little bit more advanced than the ESP32S2, but not as complete as the ESP32, regular ESP32. So Then this is our current picture. This is what we have been working on. This is what we currently have been doing. So what's next on development? What we're thinking and what we are doing currently. So this is where the spoiler starts to come in. So our current efforts is regarding getting ESP32S2 to the same level, at least almost the same level of support as ESP32 and ESP32C3. And also we think it's really important to add some boot and update features. As we know, IoT applications are plagued by the lack of updates, the lack of secure updates, safe updates. We feel that every platform we put ourselves into, we must have this feature before we can say it is in production status. Also not only for security, but also I don't like that feeling that when I'm updating my device, if I have a power shortage and it's not battery backed, I'm going to have just a brick. So the idea is that not only we should have secure boot, flash encryption, all that security features, but also safety features like can my device resume its update if something bad happens, if something goes wrong? Can it be back come back alive? So this is, we think that's important, and that this is actually what we call image safety and image recovery. And secure update is, I don't want some hacker in the middle of my communication to the cloud, getting into and sneaking a firmware, replacing my my standard firmware or my application. So I don't want to run these risks. So this puts us into this list of general activities. So we are starting to work on flash encryption. ESP32 is architecture is a little bit different. All of its flash memory it's not in die, it's an external chip that does it. So we do have a flash communication through SPI that could be sneaked upon to prevent that there is flash encryption. That it's as we use the term layer 2 cryptography because it happens on the layer 2. If we think on OSI OSI layers, we're planning secure boot. We also, of course, are working on ESP32S2 peripherals. And one thing that I put it first, but I let it for the last, but not least, is something that I'm really proud that we have been doing, is porting MCU boot and having MCU boot to work with NuttX. For those who are not aware of this project, it comes with a lot of those features that I've just mentioned regarding image safety, image backup, and things like that. It also comes with a full set of APIs that on MCU boot point of view is what it calls application. To understand a little bit of this, we can say that the host OS is going to use to access all the functionality that MCU boot offers. So it's a pretty interesting project that we started to contribute, and we are porting to NuttX. We already have some experiments. We also already have published on Embarcados, a Brazilian website of technical content, a tutorial on how to build MCU boot. And also on that tutorial, we offer a precompiled image of NuttX proving it can work with MCU boot. And of course, our goal is to bring that to all our devices. Now diving a little bit into ESP32S2, what we have planned is what is marked on blue. So like I said, Wi-Fi is really important, USB is also really important, and of course, all other peripherals, they're important, but we think that these two, since they are the biggest differentiators for this device, is the Wi-Fi and USB, so they have to come first. And of course, all the rest of the peripherals for a full IoT experience, as to say. Regarding MCU boot, we have some PRs in place for ESP32 and ESP32S2. But by the time I did this presentation, they were pending. ESP32C3 is MCU boot port is in development. It's understood the MCU boot port itself, so it's on development. After the MCU boot port is ready, then we get to make it work with NuttX. And like I said, besides that article on how to use it, we don't plan to stop there, because we think it's something new. It's something we devoted a lot of time and effort to understand how to make it work. So it's more than important and obvious, even on our point of view, to share that knowledge through some tutorials, some articles, sometimes on Embarcado's website, sometimes on Espressif Medium, wikis and stuff like that, to share what we have learned and how to make MCU boot work with NuttX. As happened recently, an update, our PR, when I kept things just to show that things are moving, and they're not moving slowly, they are moving on a very decent pace. Our PR for ESP32 was approved. Now we have the second part of this work, which is make the NuttX side of the tasks. And then we can say that we have MCU boot properly working on NuttX. Currently, we have on not on production state. It's quite it's on what I used to say, it's on hacker level for users. Of course, we want to make it more on a more better user experience, but it starts with our PRs getting accepted, and we just head for the ESP32. Now the rest of the family comes one after the other. So that said, for what we have, what we are currently doing, what we will be doing, and what's the future of this project within Espressif. Well, I get this question all the time. Every time I talk to people, they start asking me, Ricardo, is Espressif going to keep supporting newer devices? Is this something that we're just doing for the current ones and then we are moving to another project? Well, I like to say that first, I like to start that because people start to see things being supported on ESP IDF. I said, well, why aren't you starting on support for other stuff? I said, well, our support actually starts with ESP IDF. So every operating system that we currently use, our support starts with the ESP IDF, because it's the tool we use to test the chips, to evaluate them, to see if they're working properly. So our support starts there. Also, we enjoy the work of our other Espressifers, so we can just take the code they created and we can get inspired by it and do our porting. So our support starts with ESP IDF. It's part of the process. And second, what I reply to that question is, well, we created a team, the third-party platforms team for that. So yeah, most likely we're going to stay. So yes, we're going to keep supporting your devices. So just also to take that out of our to take that from the front of us. Yes, we plan to support ESP32S3. We plan to support C6. We plan to support the recently discovered H2. So support is going to start. I would expect that support for those chips, once you see them supported and released on IDF, then our job starts. In the meantime, if you might think what we will be doing, well, that's what I'm going to talk next. So while we wait for these devices, there is still a lot of stuff that we have to do for the currently released ones. So talking about that, then we start talking about our future goals. So yes, we just to reinforce the message and set it on a single sentence, it's our plan to keep supporting ESP32 family device, not only ESP32 regular and those currently on the market, but the future that are to come, and those that were not announced yet. But as you can and you might imagine, our R&D is working on. Second to that, we want to get these, not only, it's not something we want people just to try and say, oh, nice, that's cool. That's not the idea. The idea is that people actually put that into products. So for that sense, reliability for our devices is a must. So how we're going to approach that? Whenever we find something that's a bug, or we find some opportunity window to improve something, we go and do that. So we go for ESP32, and eventually we can move to C3, then to S2, and eventually when we have it as C6. So working on the reliability of our devices is going to be part of our goals always. So the idea is not to just let a bug sit in there like forever. The moment we figure that and we understand how to fix it, it's our goal to go and fix it. And finally, it's important for us to keep collaborating to the community. So now that's more on long-term strategies. Now a little bit more on what we are currently planning, and on planning stage that we think into start the work as soon as we finish what we're currently doing. Is there is some Wi-Fi drivers improvements that we are still pending to deliver to ESP32. Also support a few protocols that we are currently not supporting yet. So yes, Wi-Fi is going to be something we will, like I said, I don't think we are going ever to stop working on Wi-Fi, but this is, I think it's it's not going to be a fine tune, it's going to be a major update that we're planning. Also, this idea of dynamic frequency scaling, it's important for our devices. It lowers the power consumption by a lot, so it's important for battery-powered applications. Also, CAN bus, it's something that people we're seeing some movement and some people in the community asking for that. SDIO, SD card, really important for data logging and stuff like that. So yes, it's something we plan to work on our next feature loop, let's say. And also again, it's currently someone can just do something on IDF and then take that and try to those ULP binaries and put to work on NuttX. But we feel that okay, it's doable, but it's not a better way to do it. So yes, a proper ULP support is something we have to figure how to work with that as asymmetric. We can consider this as more of an asymmetric multiprocessing of sorts. So how to handle that. And finally, there is MCU boot. We enjoy joining this project. We think that it adds a lot in terms of features. Having it to work with NuttX, we already have some push requests regarding the NuttX port itself, not only the Espressif ports, but the NuttX port itself on the MCU boot. As far as an important thing also, as far as I know, we are the first ones to be doing that, to have that working. I can be wrong, but so far from what we have researched, only ESP32 is working with MCU boot and NuttX together. So we do plan to keep contributing, we do plan to keep improving, and also we understand that we open the path for other players in the NuttX space, in the community, to start adding the airport as well. They can take a look on what we did. Of course, they can improve it, and we would be glad that they do. So, but we think it's nice that we kind of open that door for everyone. And as such, we don't plan to stop it. We have dedicated people working on MCU boot, and we also have part of our NuttX team working on this integration. So it's a work in progress, and of course, there is always a lot of room to improve. Well, that said, thank you all for this presentation, for joining me here. I hope to, most likely I didn't give all the spoilers you would like to, but you can ask now. Also, take in mind that we have been a lot of busy, and we will keep busy on these activities. And just one last comment. Sorry for the early bug, but luckily it's fixed and we could enjoy this presentation. Thank you all.
Thank you for the nice presentation. I suggest that now we continue with the raffle, and since we didn't have any questions and answers, let's see if we have some. Well, I will do the raffle drawing in background while we fill the questions, and I will announce the winners after. Okay?
Okay.
Alan, can you check if we have some questions for our speaker?
Yes. Until now, we don't have questions. Thank you, Ricardo, again for this presentation. It's really nice. I am suspect to say because I am with you. You are our manager, so I am busy to say something. But yes, we are doing a very great work with NuttX. Not only NuttX, but Zephyr, and now with the MCU boot. And I think we need more companies doing it, what Espressif, what Xiaomi, Sony, and others companies are doing. That was the way that Linux became what Linux is today. We have the community, we have to have people work on NuttX, but more than that, we need to have companies using and work on it and contributing with it. This way, our community will increase even more, because when we are working with some technology that are companies using it, you realize you have a job to work on it, and then you'll be paid to do it. So I want to thank you. I want to thank you, the Espressif, for allow us to work on what we really love, what we really like to work. Okay? Thank you, Ricardo.
Thank you, guys. In the meantime, I managed to finish the raffle. We had 15 people that participated in the raffle, and to save time, I did it in the background. The first winner is Maicon. The second winner is Maxine B. John. And the third winner is Bruce. And since the next presentation is longer, I would like to thank the companies that submitted the hardware for this raffle. I would like to thank the speakers, and I will pass the stream to Alan so that he can play the next presentation. Mm-hmm. We are ahead of schedule because the presentation is longer.
Yeah. Okay, Alin, thank you very much. I will put it. In fact, it's not a big presentation. It's a live demo. Not a live demo, but it's a demo from a guy here in Brazil called Pedro Bertoleti. Pedro is a very clever and very smart guy. He developed many projects with ESP32, with the Raspberry Pi Pico, and many others technology like LoRa, Sigfox, and others. So I will start it here, and after this, I don't know if Pedro will be available here for questions, but let's put it to here to present. Just a second. It's starting. Oh, it's not accepting my link. I think it's because it's shared on YouTube. Just a second. I need to upload it again. Phil, yes, the link is already public. I will post it here. Try to open it. At least it is supposed to be.
Okay, I can open your video, but maybe it's not a YouTube video, it's Google Drive, so maybe...
Yeah, but it can open the Google Drive. We tested it yesterday, but I think because it's I don't know, it's not in my. I think that's the issue.
Do you want me to try?
Yeah, if you can try to play it. Okay. Otherwise, you need to download and upload it to our own driver.
No, it's same for me, but I can host it elsewhere.
Okay, if you can do it. But I am afraid we will have not too much time to play it. Let me open it here to confirm.
What you can try to do is to share your screen and somebody do voiceover.
Yeah, but when share screen, I suppose the audio will not work.
No, that's why I wanted someone to speak over it, or something you can do is recording your speaker and with a microphone, and then you get the audio shared to us. Got the idea?
Oh. Okay, I will play it and share my screen, right?
You want me to play? No. You play your video your side. You're sharing your screen, and you put your microphone near to your speaker. Then this way you can record the video output, and it will go through your microphone.
Okay, let's try to do this way.
Yeah, this is not the best solution, but if we want to be quick, there is no choice.
Yeah.
Guys, we have 18 minutes.
Hi there.
Okay. I think it's enough. 18 minutes.
I was able to hear something, so it should be okay.
Alan, okay. We also have an option to share audio.
Okay,
so you don't need to place your microphone in the speaker.
Okay. Maybe it's if you are using a fake.
Can you see the screen?
Yeah, it's fine.
Let's play it. And the audio?
My name is Pedro Bertoleti.
Yeah, it's okay. A bit low, but it's working.
Electrical energy generated by mini solar panels.
It's okay.
First of all, let's consider the following problem to solve. In a certain place on Earth, there is an electronic device powered by one battery, and it uses solar energy to recharge it. This electronic device is located in a place where there aren't no internet connectivity. I mean, no Wi-Fi, no Ethernet, no such a thing. So another way to upload data to the cloud must be used to get this monitoring data to the clouds for further analysis. Okay. As solar panels operation are crucial for the correct operation of these electronic devices, as it is one of the only power sources available to recharge this battery, it should be checked if the solar panels are working properly and generate enough electrical energy to recharge the battery. Use some kind of remote monitoring, as we can see, can see in the further slides. To solve this problem, this demo proposes a solution using NuttX OS and Sigfox LP1 connectivity. The solution consists of a Raspberry Pi Pico board running NuttX RTOS and a custom application, allowing periodic INA 219 chip reading to get and also accumulate the useful electrical energy generated exclusively for recharging the battery. Plus, from time to time, this application sends the total amount of electrical energy generated for battery recharge to a cloud system, to a cloud platform, making usage of Sigfox connectivity or Sigfox LP1 for this. The Sigfox transceiver used for this solution is a HT32SX, from AT Micro manufacturer. It's a Brazilian manufacturer. ONS data, I mean total electrical energy measured so far, is received by Sigfox base stations. This data is forwarded to a Sigfox backend and finally forwarded through HTTPS through Toggle IoT platform, allowing data storage, visualization through dashboards, and also data processing as analytics and stuff like that. Note that Sigfox is a good LP1 connectivity for this. Once Sigfox transceiver power consumption is very low. It can run with only single battery, I mean an 18650 battery for years. And Sigfox transceiver can be miles away from a Sigfox base station. Getting deeper into solution schematics, as you can see in your screen right now, it contains three 12 volts mini solar panels in parallel. All the power generated by these mini solar panels are redirected through an LM2596 voltage regulator module, as you can see in the center of the screen, which dropped the voltage level from 12 volts to 5 volts. This is done because the TP4056 battery recharge module, as you can see right to the LM2596, accepts 5 volts as input voltage to recharge battery. Finally, TP4056 takes action by safely recharging the battery. Okay. Note that only the useful energy generated for battery recharge stat is monitored. I mean, only the useful energy is measured, what excludes power loss in voltage regulator and makes these measurements more accurate for its purposes. Now, let's take a look at this demo assembly, okay? First of all, there is 3 mini solar panels, 12 volts, as you can see in the top of the image. So there's a development kit with an 8T32SX, a Sigfox transceiver, and I used this development kit just to get direct access to this Sigfox transceiver through words and using AT commands, as we will see further in this presentation. Also, we used the Raspberry Pi bytecode INA209 and mini solar panels circuitry, okay, to send the power generated by all these 3 mini solar panels to one single output. Also, we have a lithium battery. This battery model is 18650, 3.7 volts nominal, and single cell battery. Also, we have a voltage regulator LN2596 and a battery recharge module TP4056. Well, in embedded software point of view, the solution comprises NuttX OS plus the application used for this monitoring. I mean, all this software is comprised or is present in just one binary, okay? Where the application takes the advantage from POSIX system calls and NuttX WART and INA209 drivers, standard drivers, to accomplish its goal. So this project, this solution takes advantage from what NuttX has to offer for a solution like that, and make the code more simple, more readable, and also more with a better quality, final quality, okay? Therefore, NuttX is a great OS for this. Once it reduces software complexity, it makes everything POSIX standard. Also, the application runs in background through init script executed after the NuttX OS boots. This approach is way more interesting than use application as an entry point for NuttX, as this is a very common solution for a project using NuttX OS. This is better because it runs in background and it clears the way to another applications, to another projects running in the same OS. So this approach allows future expansions for this project. Now it's coding time. I'm going to show you the application source code and detail how it works. Well, as you can see, the application code is located into NuttX workspace, examples, and this Energia Solar INA 219 folder. Okay, so it's built like an example, and it is not added as an external app. So the code is put into X NuttX folder, examples, Energia Solar INA 219. Here is the source code. Okay, it's very similar to the examples present in the apps NuttX repository, but I'm gonna show you how I got to this solution. Okay. So just to clarify, I'm using the INA 219 chip. I'm getting these measurements, these readings through this device located at /dev/voltamp null, volt at 0. Okay, so the INA 219 is mapped into this virtual device. Also, I'm using the WART to communicate to 8G32SX through /dev/ttyx0, okay, device. And I'm using GPIO22 from Raspberry Pico board to reset the 8G32XS module, okay? And also, I'm sending the data from half an hour to half an hour, okay? What means 1,800 seconds. This application makes use from these two configs, okay? So it must be enabled into NuttX menu config. First is the floating point values can be written into a printf message, and the last one refers to WART 0 defined used in the codes, okay? These two are required to the application work. I'm gonna go to the main function, so I'm gonna detail each one as demanded. The first thing this application does is open communication with INA 219 device, okay, by opening it using read-write access, okay. So if it fails, it goes to error handle routine and terminate this program. Getting further, I'm opening connection to WART1 to communicate to Sigfox transceiver, and here I'm using no block access, okay? So if transceiver doesn't respond or doesn't say nothing to the NuttX OS or to the Raspberry Pico board, nothing happens, nothing is blocked, okay? So if it opens successfully, okay. If not, handle the error and terminate this program. Very similar things is done here with GPIO22, open as read and write access. The first thing after open communication to all peripherals is to read, to make an initial read of voltage and current by INA 219. This is used because I need a reference, I need a starting value to the max voltage and max current thresholds, okay, the limits getting so far. Well, first thing to do with Sigfox transceiver is running hardware resetting it, okay. What is done with this routine? Wait for any data reception, any data incoming from HT32SX, and send AT command to put this Sigfox transceiver into sleep mode. Okay, the working in sleep mode is very useful here once it is powered by a battery. So the more we can save battery, the better it is. Here I'm getting the timestamp or the time of the day in milliseconds, in seconds, sorry, and saving it into this variable. And we're gonna use it, this variable, to control when I will send Sigfox data to guarantee it will send from 30 to 30 minutes. Into the main loop, it reads the INA 219, get the voltage and current values, okay, voltage in volt unit, in current in the ampere unit, compares it to the previous max values, okay, and also calculates the instant power from this measurement, and also accumulates the total energy in watt hour for this program. It prints these calculated and measured values and checks if it's time to send AT commands through Sigfox transceiver with this accumulated energy, electrical energy in watt hour. If it satisfies this condition, I mean, if it has it is half an hour after the last data sent, it sends data to the cloud. So as you can remember, we have put this HT32SX into deep sleep mode. Now it's time to wake it up and wait for some data to come from it. Okay, so we have to wait to the HT32SX send some data, reset this module, and here starts the Sigfox transceiver. How can I say, specific command for data transmission. First thing to do in this topic is send the Sigfox zone, Sigfox communication zone. I'm in Brazil, so the communication zone for Sigfox here is RCZ2. Okay, so I send a IT comment for this zone. Waits for some data that comes from HT32SX Sigfox transceiver, and finally send the data, compose the AT command to send the data through serial forward interface. Okay. Once this data is sent, Sigfox transceiver is put into deep sleep mode again to save power. I update the timestamp or time the temporization value in order to send the next package, Sigfox package, half an hour after this data set, and also wait for 100 milliseconds to restart this whole cycle. Okay. As we can see here in the beginning, when some communication open fails, it goes through this label, erro execução. This label is here. It closes all the opened communications and return as -1, what indicates an error, execution error. Okay, so the program is very, very simple. It just measures the voltage current. It make a backup from max current value in max voltage value. It measures the instant power. It also calculates or accumulates the energy in watt hour, and from half hour to half an hour, send it through Sigfox connectivity. Okay. This software also makes use from this header file, which contains all the AT commands from this 8T32SX Sigfox transceiver. Okay, so the code can be very clean, and the commands are defined here in this header file. Here's the cloud side of the solution. The cloud side of the solution is made by Yaoyao IoT platform. The first thing when data comes from Sigfox backend to Yaoyao platform is to be parsed. And this data comes through this payload parser. Payload parser is a piece of software that parser or extracts some information from the raw data, from the raw bytes sent by Sigfox backend here. All I do here is to parse the data in form that I want that int 32 bits with big endianness starting at byte 0 divided by 10,000, as I multiplied by 10,000 when I send it. So I get this value, store it into this temporary variable called energia watt hour, and finally I stored this value into a Yaoyao variable, also called energia watt hour. Okay. Once I get this variable stored here in Yaoyao bucket into Yaoyao database, I can do whatever I want. Here I show a dashboard where we can see the total amount of electrical energy generated, the approximated localization of my device based on Sigfox signal, and also a chart showing the energy, the electrical energy generated in watt hour over time. Well, thank you very much for watching my presentation. Please feel free to contact me over LinkedIn and Instagram or my personal website if you want to discuss a little more about embedded systems, IoT, and technology. Bye.
Okay.
Thank you.
Thank you, guys. Go ahead, Alin.
Thank you for playing the video, Alan. It was a really nice presentation. And now we will continue with Nakamura-san from Sony, which will present the task trace for NuttX. Nakamura-san, please introduce yourself.
Oh, thank you. Yes, my name is Yuichi Nakamura from Sony Group Corporation. I'm in charge of system software development for embedded systems. And so at first, I was surprised, and I'm glad that the Raspberry Pi Pico is used in the previous video. The Pico for NuttX is for coding is my private individual activity, and I'd like to talk about it tomorrow. So today, I'd like to talk about the task trace for NuttX, and I will show the pre-recorded video for the presentation. In the video, I will explain, introduce briefly how to use the task trace, and I will show some demo to getting the task trace of some working applications and show the result in graphically. So let's get started. So Alan, please start my pre-recorded presentation.
Okay, Nakamura-san, thank you very much. And in name of many other people that are using NuttX with the Raspberry Pi Pico, I want to thank you for this great work. You really
Thank you.
did a great part. Thank you.
Yeah.
Okay, I will try to share your video now. Let's see if it works. If not works, maybe Sara will try to share it from her computer. Yeah, it's strange. The link is not working, but yesterday we tested using from Google Drive and it worked. Strange. Sara, could you please try to share the Nakamura-san video?
Yes, just give me a minute, please.
Mm-hmm. If you feel your connection is not working well, I can try from here as well because I have the video too, but it's up to you. Let's see. Sara, just let me try another thing here. Maybe, okay, she already. Yeah. Sara, it's not displaying in the okay, now it come back to
It updated on both.
yeah. Now it return. Sara, I will try to send from here, okay? Just a second. Presentations.
Okay, Alan.
Hello, everyone. My name is Yuichi Nakamura from Sony Group Corporation R&D Center. Thank you for watching my presentation.
Alan, please share the window.
Yeah, just a second. I'm starting the... Just a second. I need to leave and enter again. Sorry, guys.
We are missing the audio.
Yeah, I will play now.
Hello, everyone.
Is okay?
My name
Yes,
is
thank you.
Nakamura from Sony Group Corporation R&D Center. Thank you for watching my presentation. Today, I'd like to explain about task trace for NuttX. This is the agenda of this presentation. At first, I'd like to explain the task trace briefly, and I'd like to try by some configuration to use the task trace. And at last, I'd like to explain about the internals of the task trace. First, I'd like to explain about what is task trace. The task trace is a tool to collect the various events in the NuttX kernel and display the result graphically. The task trace can collect the three major events in the NuttX kernel, such as task execution, termination and switching, and the system call enter and leave, and interrupt handler enter and leave. And this feature is already introduced into the latest NuttX. So if you check out the NuttX latest kernel, you can use it immediately. And also, the document of the task trace is already merged into the latest repository, and you can see the document in the following URL. So if you want to know the detail of the task trace, please refer to this link. This is the NuttX task trace overview. The task trace collects the various events such as task switching, system call, and interrupts in the NuttX kernel, and it stores the record into the trace buffer in memory. And after getting the trace, the task trace feature can export the buffer's data as a trace log in the text format. And when the trace log moved into the host PC environment, it can be displayed by using the trace compass. This is the trace data viewer used by the Linux. I utilized this tool to display the trace log. By using this tool, we can see the trace results graphically. This is the overview of the task trace. And the task trace supports currently ARM and RISC-V, but it is just I tested this platform, but basically the feature is independent to the specific architecture, so I think it is not so difficult to support another architecture. The only point is only one point we need to notify that to support the system call trace, the wrapper function option wrap of the GNU linker is required to support system call trace. So if your architecture uses the GNU linker, it is not so difficult to support the task trace. I have tested some platforms such as Spresense and Raspberry Pi Pico, and some platforms using QM. Next, let's try to use the task trace. The latest NuttX repository provides the predefined configurations of the task trace. The name is Spresense initial trace. So if you have a Spresense, you can try test the task trace immediately by using the configuration and building. And after crashing and boot, you can confirm that the trace command is added. And by invoking the trace command without the option, we can get the current trace status. As a default, the trace is already enabled, so we can show the current trace data by the command. By using the trace dump command, we can see the latest trace records. The trace record is a text format, and it is the similar format to NuttX kernel's ftrace. The trace dump is constructed by a few columns. The first column is the task name and its PID, and the next column is the CPU number. In this sample, the only one CPU is working, but if the SMP configurations are used, the number of CPUs can be observed in this column. And the next column is the timestamp of each line. And the last column is the activity of the task. This sample, the first two lines shows the task init PID1 issues the system call IO control by using the following arguments, and the IO control system call returns this result. And next two line shows that init issues the system call wait PID, and by calling this system calls, the kernel switch the running task from PID1 init to the PID7 trace. And after that, the two lines, we can observe these two lines. It shows the IRQ11 interrupt occurs, and it is handled. It is because the task switch is handled by supervisor core for Cortex-M. So after the task switching, this interrupt Cortex-M SVC core is called, and the task is switched. As I showed, we can observe the task activities. Next, let's try to get the task trace of the existing applications. As a sample, I'd like to use the configuration Spresense audio. It enables the audio driver, and also I enabled the config system NX player to use NX player as the sample. It plays audio files, so I'd like to get the task trace while playing the audio. To get the task trace using the existing configurations, we needed to enable some configurations of the NuttX kernel. To enable the task trace, some configuration has to be enabled, and the NuttX kernel task trace is constructed by three major functions as instrumentation APIs and physical logic, and node RAM and node control device driver, and trace command. So to use the task trace, we need to enable these options. So I'd like to enable these options step by step by using menu config. At first, enable instrumentation APIs and filter logic. First, select Altos features block, and then select performance monitoring. Next, check the system performance monitor hooks. Then we can get some additional configurations. In this configuration, check these options. The first one is the system call monitor hooks, and interrupt handler monitor hooks, and instrumentation filter. And if your architecture supports high resolution RTC, I recommend to enable this option. Use high-res RTC for instrumentation because it improves the accuracy of the timestamp. Next, enable node RAM and node control device driver. To enable it, first select the device driver block. Next, node driver support. Check. Then we can go into the additional menus. In this menu, check the scheduler instrumentation filter control driver. And optionally, we can choose the buffer size of the node RAM. If you extend the node RAM buffer, we can hold more node records, but it consumes the kernel memory. So it is a trade-off. So if you have enough memory, this value should be extended. Next, at last, enable trace command. To enable it, select the application configuration block. And in this menu, select the system libraries and NShell add-ons. And in this menu, select enable system command and trace command. Those two commands are required to use the task trace. And optionally, if you use the high resolution RTC, you need to the high resolution RTC architecture support. Timer driver support and RTC driver support, and you need to set the high resolution RTC frequency. In the case of Spresense, 32 kHz is used for high resolution RTC, so you need to set this value to this menu. By configuring this, we can get the NuttX kernel, which is enabled the NX player and task trace. So after the building and flashing and boot, we can get a console which can use the task trace. So to get the task trace while running an NX player, you invoke the command trace command NX player. Then the task trace executes the NX player and gets the task trace. And start the playback by play command of the next player and quit the playback. Then we can get the task trace while playing the audio. And after that, by using the trace dump command, we can get the trace result, and by using the log function of the terminal software, we can store the trace result into the log file in the host environment, and it can be used for the graphical view. To show the trace result graphically, I use the trace compass, which is developed by Eclipse Foundation. So we can get the trace compass from this URL. So at first, we need to download and install the tool into your host environment in this URL. And only at first time, we need to install the add-on. It is named Trace Compass F-Trace Incubation Extension. Only the first time we needed to choose tool add-ons and this extension. Then we can show the trace result graphically. By using a trace compass, we can show the task transition, task control flow, as you see. So each line shows the status of the tasks. And in this area, you can see the trace log corresponding to this timing. So I'd like to show the demo video to get the task trace. So let's try to get the task trace of NX player. Now, trace commands and NX players are already available. So by default, trace is enabled. So at first, stop the tracing. Then go to the folders which contain the audio data, and by invoking the trace command NX player, we can get the trace while executing the NX player command. Then start playback of the sample audio data and quit the NX player. Then the trace data is already stored in the buffer. Next, we store the buffer data into the host PC's file. So by using the log feature of the terminal software, we can store the log data as a file in the host PC. Now we can store the log data into the buffer or the host PC. Next, let's try to see the log data by using the trace compass. In this area, we can see the control flow by graphically, and in this area, we can see the log data. Each line means the task name and the task ID. And the green line means executing, the task is running. This means the idle task is running, so this is the idle time of the CPU. And yellow line means the task is waiting something. We can zoom up the control flow. And red line means the interrupt handler is executing. And the brown line means the task is ready to run. In this sample, in the interrupt handler decided to wake up this thread. Then this thread changes the state from waiting to the ready to run. And blue line means the task is executing the system call. We can see what system call is called by the task. We can see in this moment the thread calls the get unlock API and the thread gets the code 0. In the inexperienced sample, there are two P-threads. One is the thread created by the NX player, and one is the audio driver's worker thread. The NX player thread reads the audio data from the file and send it to the audio driver by calling the IO control. So we can observe the NX player thread runs periodically to send the audio data to the audio device driver. And after that, I invoke the quit command to the NX player. So NX player's task runs and start to the termination process. We can see the termination of these pthreads by calling NX pthread exit API. And NX player task waits the termination of the pthread by calling the pthread join, and after that, it calls the exit system call to terminate itself. This is the trace result of the NX player. Okay, next, we'd like to try to get the task trace of the SMP test. The task trace is already support the next SMP configuration, so we can use we can get the task trace of the SMP test by using the configuration Spresense SMP. So let's try to enable the task trace based on this configuration and try to get the SMP test, the task trace. When we see the task trace by the trace compass, we can observe the task is switched heavily as a test, and so multiple tasks are executed simultaneously because it is SMP configuration. I'd like to show the demo video to getting the SMP task trace. Let's try to get the task trace of SMP test. By invoking trace command SMP, then we can get the task trace while executing the SMP test. Then let's get the log file like NX player. And let's see the trace result by trace compass. The SMP test executed the multiple threads, and all threads switch into context heavily for the test. We can observe the task switching among these 8 threads. We can see that the thread stops the execution by calling the get_ear API. And we can see that one moment the 2 threads are running because this is 2 CPUs SMP. And after the execution of the test, all threads terminate with the pthread exit system calls, and the main SMP process with the termination of all threads and then exit. This is a task trace of SMP test. I have shown some samples to execute, getting the task trace, but there are many options of the trace command and there are many functions of the trace compass, but I have enough time to explain them. So if you have interest in these features, please see the documents of these tools. At last, I'd like to explain the internals of the task trace. As I already shown, the task trace is constructed with 3 major features. First one is the instrumentation APIs and filter logic. The state node APIs, which collect the NuttX kernel events, are implemented here, and in this block, filter the nodes and pass the node data to the node lam driver by using getNodeAdd API. The next block is node lam and node control driver. The node lam device driver accumulates the incoming node record into the buffer in memory. And when the application requests to read the node data, it passes the node buffer to the application by using the file I/O.
In this time, the node data is passed as a binary format. It is defined as a struct node structure. And this is a node control driver to control the filter logic. This feature is controlled by the IO control to the dev node control node. And the last block is a trace command. It is implemented here. This is a built-in application to control and show the trace function interactively. This command reads the binary records, node records from dev node, and this converts the binary format into the ftrace text format, which is acceptable by trace compass. So we can see the trace log as a text. The conversion is done in this function. This is the internals of the task trace. And last, I'd like to explain how to get the system call events. Almost every user use the flat build configuration. So in flat build, a system call which is used to call the kernel function from application code. This is realized by as just a function call from application code to the system call implementation in the NuttX kernel. To get the system call events, I use the wrapper function. This is automatically generated by the MK syscall tool, which is already provided to implement the protected and kernel build, but I utilized it to generate the wrapper. And by using the GUI linker's wrapper function option, the linker changes the symbol name to wrap the function. In this case, the read code from application code is replaced into the wrap read. The wrap is preceded by the linker. And the system code implementation is preceded real. So this function is implemented as a real read. So we can get wrap the calling system call by implementation of wrap read, and in this function we call the system call enter and leave event to the task tracer. This is how to get the system call event in the case of flat build. And in the case of protected and kernel build, in the ordinary case, the system call proxy and the system call stub are generated automatically by the build system. And when getting the task trace of the system call, like the flat build, MKSyscall tool generates the additional system call wrapper, and it gets the system call issue from the system call stub, and it intercepts the system call into the task tracer. This is how to get the system call by the task trace. That's all of my presentation. Thank you for watching my presentation.
Thank you, Nakamura-san, and thank you, Alan, for sharing the video. If you have questions for Nakamura-san, now we will take questions, and after that, we will do another raffle.
Thank you, Alin. Alin, maybe Sara can try to do the raffle because you cannot share the screen, correct?
Yes, if I share the screen, we will have again freeze on my screen.
Okay. Sara, can you?
Yes.
Okay.
I'm
Thank
opening
you.
here the random.org. Let me share here my screen. Can you see it?
Mm-hmm.
Yes.
Okay, let me see how many people we have on our sheet. We have 24 participants. So 2 to 20. Let me just close because it is still accepting answers and the sheet is increased. Okay,
Yeah.
now we have from number 2 to number 26. Okay, 2, 26. Okay, number 13 is Murat Tologlu.
Mm-hmm.
Once
Sara,
more. 14. Go
maybe,
ahead.
yeah. I was thinking maybe we can just create how to say a column only with the first name, because otherwise it seems completely blind.
Actually, the sheet only has the name and the no, it has also the email.
Have the email, yeah. We cannot share the. Maybe if you hide the email.
Okay, let me see if I can hide the column.
Yeah, I think it's a good idea too.
Let me see if I have this option to hide the column. I think.
Or maybe you can just adjust the column to make it disappear as well. I think it will work as well.
Sorry, I didn't get the idea.
You have the adjustment of the column size. So you decrease it like this. The column has.
Yes, I tried this, but it continues to.
It didn't work.
The email on the another cell. It didn't work.
Oh, let's try here. I will go in the Google Drive to see if it has some.
Oh, okay. I found a fast solution.
Oh, great.
But I don't know if I will be able to share both tabs, the random site tab and the sheet tab.
No, you can just move from one to other just to see the numbers. For example,
yeah. So I will need to share my whole window instead of
okay.
tab. Okay.
Sara, generate 3 numbers here, and then we go on the sheet and we check which numbers are there.
Yeah, good idea.
Like that.
Better than switch between tabs.
Actually, I think I can share my window and then I can move from tab to tab. Are you seeing my whole window?
Yeah.
Yes.
Okay, so I'm going to generate. I generate the next number, which is 14. Let's see who is 14 here. Ajif PV, number 14. Okay. Let's draw the next number. 9. Stuart Charnel. Okay, so we have the 3 winners from this session.
Yeah, great. Very good.
Thank you.
Thank you, Sara. Okay. I think we still have 10 minutes, so we can follow if other people didn't talk from at the end of the previous presentation. So.
Oh, sorry. Let me answer the question on
sorry.
the YouTube chat.
Yeah, I didn't. I'm sorry, my fault. Okay. I didn't look the YouTube for questions.
I see. Is it planned any real-time support for NuttX traces? Basically, to show the result in graphically, the trace data must be moved from target to host environment, so it cannot get the trace in real time. So to realize the real time trace, we have to implement some method to transport the trace data from target to host environment. But at this moment, I decided to provide this feature independent to specific architecture. So I choose the non-real-time trace. This is the answer from about the questions in the chat.
Okay. And thank you, Nakamura-san. And just a comment, Mr. Dave Marcos also implemented a support to real-time tracing. He'll talk about it later. And also, it's not secret anymore. Sager J-Link also will have this feature. In fact, they already implemented, and I talked with them, I and people from NXP, because NXP paid them to implement it. So they agreed to release it on the GitHub, and we will include it on NuttX. So people will have many options now to debug, to do real-time tracing on NuttX. Yeah. So
I see.
Yeah, it's very nice because we can use now system view to see the tasks that are running, and at each moment each thread was executed and how many microseconds or so each function's delay and so on. It's very nice. Okay, Nakamura-san, Yuichi. Could you please, how you get involved with NuttX, how you start, or how many years ago you started?
Okay. So, as you may know, the Takayoshi Koizumi-san is working on the Spresense, and so in past I worked with Koizumi-san on the prototype of the Spresense. At that moment, the target is not using NuttX but FreeRTOS. And after that, I leave the project and I switched to another project. And while I'm working another project, and the Spresense team choose the NuttX for its OS. So after that, I found the NuttX. Spresense is using NuttX, and it is very good OS. So I started to study it. It is my first contact with the NuttX.
Oh, very nice. And before that, are you planning to use the FreeRTOS on Spresense? Oh, so they discover NuttX on time to change the mind.
So I didn't related to the choice of the OS of Spresense team, so I don't know why they choose the NuttX, but after the OS was switched, I found it is a very nice choice. And so.
Yeah.
Previously, please go ahead.
Okay, I think your camera was turned off, but okay, if you don't want to enable it, no problem. Alin,
thank you, Nakamura-san, for having this presentation. And thank you for the raffle. I would like to congratulate the winners. The next presentation is from Roberto Bucher, but we still have 5 more minutes for Alin or for somebody that didn't speak previously, so that they can share their experience with NuttX.
Okay, Roberto, do you want to talk?
Yes.
About yourself, or how you get involved with NuttX, how your previous experience with Realtime.
Okay, I come from a different real-time version of Linux. I worked since 2000 on Linux Time, the version of real-time Linux in Milano. And in the last few years, I moved to Linux with RT preemption. In particular, I'm still involved in code generation from MATLAB Simulink and in the past from Cycloslab and Scilab. And in the next few years, I began to work with Python. And I tried to find out something that allowed me to integrate Python with real-time systems. And thus I developed pysimCoder that I will present later. I came in connection with NuttX in March. I was together with other people at the Linux Real-Time Foundation presentation of the last patch in the kernel, in the main line of Linux. And I had the possibility to speak with Pavel Pisa. And Pavel presented me the NuttX project, and it asked me if it was possible to integrate pysimCoder with NuttX. And we tried. We speak about a couple of weeks, and after a week, we had the first version of a working system which used pysimCoder and generated simple code for NuttX. And then we continued to implement, to integrate some devices and so on. And in May, we had the possibility to have a student for the Google Summer of Code, Michal Lenc. And it worked more on the integration of pysimCoder with NuttX. This is my experience. It's not so a great experience with NuttX itself, but I was involved in order to try to have a rapid control prototyping system to generate code for the NuttX OS.
Very nice.
I think that now it's time to start the next presentation from Roberto Bucher. And the presentation is called Rapid Control Prototyping with Pysim and NuttX.
Ali, let me try again to share the video from my computer, okay?
Yes, thank you.
I present myself.
Do you want to present on live?
Yes.
Oh, great. Okay. Way
My
better.
idea is to present directly here. Okay.
Okay.
That's perfect. Okay.
Okay, thank you, Alan. Thank you, Alin. Thank you, all people, to give me the possibility to speak about pysimCoder. My name is Roberto Bucher. I'm professor at the University of Applied Science and Art of Southern Switzerland, where I'm responsible of the courses on dynamic systems and control systems.
Roberto,
yes.
Just to interrupt you, now you need to return to Jitsi and click on the camera, so your face.
Okay, sorry.
No problem. No problem.
Yes, of course. Here. It's okay now. Just a minute. I have to.
Yes.
I have to reshare my screen. Okay, now I have to reshare my screen. Share.
Yes, you share. You put in presentation mode. Share your screen. Return to Jitsi and click on your camera. It's a little bit tricky. I hope the Jitsi improve it to become more similar to Zoom, but unfortunately, that's the way.
I can't. When I start my presentation, I can't more return in the NuttX in the workshop windows.
Maybe if you try tab and just return to alt tab and just return to.
Okay, I tried. Okay. Okay, open, and then NuttX online. It's okay? No, it's not okay.
Yeah, now you need to return to Jitsi and click on camera, and the camera button.
But I can't enter in NuttX because I have all my screen
blocked already. Alin, do you know how to can solve it from?
No, unfortunately, no. Actually, yes, you have to start the presentation. Go in presenter mode, like you would present on projector.
È così? Now?
No. Open your presentation in a separate window, not in the same window as the Jitsi. A separate window, not a separate.
But my presentation is on the screen.
Okay, now go in your presentation in presenter mode.
Yes. Okay.
And now from Jitsi, do share.
But I can't share. I can't re-enter in Jitsi. This is the problem.
You have to do Alt-Tab.
Yeah, maybe we can present without his image in the camera, and later we share the video with.
Okay.
I think it's no problem. We can do this way.
Okay. Yeah. Thanks.
Sorry, Roberto, too much for this inconvenience. I really sorry, but this is the technology limitation at this moment. Sorry.
Okay, that's not a problem. Okay, I I was presenting myself. I'm professor at the University of Applied Science and Art of Southern Switzerland. And I'm responsible of the courses on the dynamic systems and control system. And I'm responsible of the related laboratories too. I will present the tool pysimCoder. pysimCoder is a rapid control prototyping software that in the last couple of months, we integrated with NuttX in order to automatically generate real-time code for control application. My presentation is more related to pysimCoder and not to NuttX, because it's an introduction to the next presentation from Michal Lenc. Okay, if we look at the method related to the rapid control prototyping, we have a loop usually. We start from the specification, we go to the modeling and the identification of our plant. Then we proceed to the control design, and we try to simulate our controller on a mathematical description of our plant. And if it correctly works, then we go to the implementation and the verification on the real target. And this loop continues until we reach the given specifications. This is the method that we used in our laboratories with our students. We start with the so-called model-based design, and the idea is to do all the tasks related to the controller design, from modeling to implementation in the same environment. And the idea is to have the possibility to easily test different control algorithms with the student, PID, lead, lag, state feedback, LQR, implements observer, full or reduced observer, and so on, simulate the system, and proceed to the code generation for a given real-time target. And the idea is to do all these tasks in the same environment. Usually, a lot of universities work in this, with this method. They use a traditional computer-aided control system design environment. And the idea is to have a block diagram with the system where our plant is described using mathematical formal mathematical system, and then simply substitute the mathematical system with blocks that give access to the real plant in order to control the real system. This is the idea that we try to give to our students, but with the common computer-aided control system design environment, there are a lot of such environments. It is possible to perform all these tasks, but most of these software are quite expensive. And the idea is to find out another method that allows to perform the same tasks, but with the open source system and free software. In this way, we tried to continue our researches in laboratories using the Python language. Python is widely used in universities and industries, and in the last year, Python has become the most used programming language in industry. There are a lot of scientific packages in all domains, and it is possible for our students to use Python to model the system, in particular using the symbolic package, Python package, which implement, for example, the Lagrange's and Keynes method to find out the differential equation of heart plans. And there is a Python control package that allows to implement the usual methods to design controllers and to test controllers. The Python control package was developed since 2010 by Richard Murray at Caltech, and this package tries to reproduce most of the function of the macro control system toolbox. Bode diagram, step response, Nyquist diagram, and so on. But there are some problems related to this package. First of all, the Python control package is yet more a didactic system, and there are not many people that use this package to control real system and to generate real application. And the second problem is related to the hybrid simulation, because usually we want to implement discrete time controllers, but we want to test these discrete time controllers with plans that are modeled in continuous time. And for this task, we need to have the possibility to perform hybrid simulation. Thus the idea to develop pysimCoder to fulfill or to solve the problems related with this Python control package. What is pysimCoder? Well, pysimCoder completes the Python control package with some methods which are very useful to implement real controllers. For example, we have functions that can implement very easily full or reduced order observer. They can introduce anti-wind-up mechanism. For example, in the Python control package doesn't exist a discrete linear quadratic regulator. Thus, there are some additional functions to complete the Python control package. And in addition, pysimCoder offers a simple graphical editor which allows to create block diagrams and perform hybrid simulation. And in addition, it is able to generate real-time code. The graphical editor is based on drag and drop. There is some selected blocks specific for real-time application, for example, analog, digital and digital analog converter, PWM blocks, digital I/O, canvas, network. It is possible to perform simulation. The system generates code for simulation, or we can generate code real-time for different targets. For example, one of them is Linux with RT preemption on PC or Raspberry Pi, and we have other little embedded system that allow to integrate the generated software. For example, the Bricky card, and we did some code generation for a Nucleo H7 card. But in particular, in the last month, we generated code for NuttX. A little demonstration of pysimCoder. We can get some blocks, for example, a step. We can put a linear system and a real-time block. We can connect half blocks. We can, for example, change our plant description. In this case, we get a transfer function of 1 divided by s squared plus s plus 1. And then simply we have to choose what we want to do. For example, we choose to do a simulation. We choose a template makefile. And we can say we simulate 15 seconds. I can start my simulation. And I have my response usual as a normal simulation software. But what is interesting is that I can choose different template makefile. For example, I can choose a real-time Linux system, or I can choose, for example, system in simulation or in real time which implement functional mockup unit, or I can choose as target a Raspberry Pi or NuttX. For example, if I choose real time, this is a template to generate code for Linux in real time. The difference is that when I start my system, the simulation is performed in the real time. My 15 seconds are exactly 15 seconds. Okay. What we did for NuttX, we tested the system, the code generation, the real-time code generation on these 3 cards, 2 Nucleo cards with STM32 systems, F746 card and an F446 card. And in particular, this is the project of Michal Lenc on the INX RT system. Now I want to go a little more into details of code generation. If we look in school, we learn that all the function of a system or of a block can be described in continuous time as first derivative of x equal f, function f of x, input u and time, and the output y as function g of x, u, and time. Or in discrete time, we have that x at the discrete time k plus 1 is function of the x at the time key, the input at the time key, and the discrete time key. And the output at the time key are function g of x, u, and key. But actually, the right execution is inverted. First of all block, we have to update the output in discrete and in continuous time. And then a second operation, we have, if required, we have to update internal states of our system, of our blocks. This is the right execution that we have to implement when we want to generate real-time code for the different targets. Each block that we have in our block diagram must have a corresponding C function which implement the F and the G function. F only if there are internal states, but the function G is usually required. In addition, each block should have an initialization and a termination function. The termination functions are not so important for embedded systems, but the initialization function is very important. And then we can simply call all the functions related to a block by simply pass a flag that say we are in the initialization phase, or a flag that say we are in the phase to update the output, or we are in the phase to update the internal state, or we are in the termination phase. This is only what we have to implement at the end for each block that you want to use in our code generation. For the code generation, we have a Python script which contains the design of our controller, the modeling, the design of the controller. We have the block diagram, and then we generate a code generation script which contains the script with all the calculation of our controller and a description of our block diagram. From this code generation script, we can generate C code that implement the function related to this block diagram. And then, using an external main with a real-time thread, the block library, which contains all the functions related to the blocks, the template makefile, which is specific for each target that we want to use, we can generate the executable. This is the main idea, and this is what is implemented at the end in pysimCoder. First of all, we have to enumerate the nodes of our block diagram. Each node is simply the output of a block at the end. One time we have described or enumerate the nodes, we can generate a topology of our block diagram. In particular, we have, for example, the block sum, which has as input node 2 and node 3, as output node 4, and the last information are the parameters specific to this block. For example, if we get the square block here, we have an amplitude of 1, a period of 10 seconds, a width of 5 seconds, 0 bias, 0 delay. And all these parameters are passed here. People who have about my age can perhaps remember the old method to implement circuits with PSpice and software like PSpice. The idea is about the same. The second step is to find the right execution sequence, because there are blocks that depend in the output from the inputs. For example, the sum block can calculate the output only if it knows the two values at the input. This leads to reorder the execution sequence of the blocks to avoid these problems. For example, we can here we can perform the reference at the beginning. There are no input signals. All the dynamic system is a GZ, which is a discrete time linear system, and the plant, which is a continuous time linear system, have at the end no relation between input and output. This means that the D matrix is empty, for example, and or zero. They can be performed before, for example, sum or saturation, and so on. The second step is to reorder the block sequence in order to have all the input and output in the right form. Then each block is copied or is ported into a specific class, which contains important information. For example, the function of the library to be called to perform the activity of this block, the input and output ports, for example, the parameters of these blocks. There are, in this case, all real parameters, so double and not integer parameter. The number of states, for example, the block to generate a square signal doesn't have any internal state. And then this relation between input and output, which is very important to find out the right sequence of operation. This class will be simply translated into C code to fill a structure which contains all the important information related to a specific block. And from this RCP class, we can generate a call to the different functions that are required to perform the real-time execution. Here's the initialization with the CG init flag. Here, the periodic task, the ESR is the task which will be called at each timestamp with the, in this case, only the CG out flag because we don't have internal state, and the termination function in the termination in the task termination function. Here, the ESR function will contain the call to all the blocks. You see, for example, the output of all the blocks in the block diagram, the plant here, the square signal, the two discrete systems, the scope, the sum, and the saturation, and the internal state update, which is performed only on the three discrete time, on the three dynamic systems, the two discrete dynamic systems, and here with a very simple Runge-Kutta method to the continuous time system. Now, in SUPSI, we tried to implement or to use pysimCoder to a lot of systems. For example, a balloon plate plant, here a balloon wheel system, here a disc and spring system. We have two rotating discs which are connected together through a spring. And for example, the usual inverted pendulum. I want to show some little details related with the implementation of the inverted pendulum. Here's the Python script. In the Python script, we have the modeling with the Lagrange method using symbolic Python. For example, we had to define some signal and constants. And here, simply, we can define a reference system related to the car. And to this reference system, you can connect a rotating system which implements the pendulum. The car is a simple point, is a particle. The pendulum is a rigid body, which has inertia. We have to define the potential energy of the system, the forces, and then we can define the Lagrangian related to the system and find out with very simple method the Lagrange equations. And at the end, after linearization on the equilibrium point, we can find out the A and B matrices. We have only now to put the identified parameters into the A and B matrices, and we can find the continuous matrices A and B, which described our inverted pendulum. It's quite simple to find out complex models using, in particular, Lagrange methods. For the control design, we use the method from the Python control package and some additional function provided by pysimCoder. And we implement two controllers, a discrete EQR controller to control the pendulum in the unstable equilibrium point, and a state feedback controller with integrator and anti-wind up for the swing up phase of our control. Here, for example, for the EQR controller plus observer, we can at the end generate a single discrete time block which implements the controller plus observer. It's quite simple. We have here the system in continuous time. We find out the system in discrete time, and we can implement the EQR controller. And after fixing the poles for the observer, we can find out the reduced order observer and put controller and observer into a single block. The same can happen with a state controller, which is implemented using pole placement and the place function for the swing up controller. Our control board with NuttX RTOS for this inverted pendulum is a Nucleo F746ZG card. This card with a simple CAN transceiver. And this is the block diagram with the full controller. We have the controller for the swing up here. Here we have the controller for the unstable inverted position of the pendulum. Here we have a little safety part which blocks the controller if there are some problems. And the last part is the swing up, or is the switch between the swing up controller and the inverted equilibrium point controller. Here we have the two blocks that read the card position and the pendulum angle from our system. And here we have the block which performs the actuation of the motor current to move the car and control the pendulum in the right position. Just a minute here. I have here you can see the block diagram. We have only to choose here NuttX as template makefile as a target. We have to choose the Python script which implements all the calculation or all the design of our controller. And then we can simply say generate real-time code. Okay. After generating the code, in a couple of seconds, we have here how impend and independ elf generated for the NuttX operating system, and in particular for the chosen target that we have exported from the NuttX project. More details about this, I think, will be explained by Michal in the next presentation. Okay, here a little movie with the control of this pendulum that we did in our laboratory, the swing up phase. The pendulum is now in the inverted position, and we switched from the swing up controller now to L-square, to the discrete L-square controller. It's quite stable on the system. And then we can look at the control board that we see already previously, the STM, the Nucleo F7 card. Okay. By considering that pysimCoder is a tool that I developed in my spare time at the end, I think it can be quite useful. The system is used in my course on control and dynamic systems, in particular the student from the computer science curriculum. They don't work with traditional mathematical environments. They are more used to work with Python, and in my laboratory they are used. They will use pysimCoder as a tool to perform simulation and real-time code generation. It is quite easy to set new targets, in particular for the integration of NuttX in pysimCoder. We had less than a week of work to reach the first simple application. In particular, the main task was to generate the template makefile for NuttX. And here I have to thank Pavel Pisa, who wrote these template makefiles. The real-time main is the same that we use in Linux real-time system. And then we implemented the blocks for the peripherals, for example, analog to digital converter, digital analog converter, the PWM blocks, the encoder, and for my test in laboratory, the CAN bus and the network to exchange data from the NuttX platform with my Linux platform and city data in real time. There are, of course, a lot of improvements that are possible in pysimCoder. For example, each connection has one signal, only one signal, and not vector of signals, as for example in Simulink. There are not MUX and demux blocks yet. And another problem that we have to solve in the next month, we have at present only double types in all blocks, and not the possibility to have signal of, for example, integer type at the input of a block. Okay, thank you for your attention. If there are some questions, I'm here.
Okay, thank you, Roberto. This is a very nice presentation and a very good, a very powerful tool. So I am very happy that that you and Michael and others work on it to get it integrated on NuttX. It's very nice to have these powerful tools. And you mentioned in the beginning of your, before you start your presentation, that you work with other real-time systems, not only real-time operating system, but real-time system using Linux. Yeah, like RT AI.
Yeah, the real-time application interface. It was developed at the Dipartimento Aerospaziale of the Politecnico di Milano.
Yeah.
And then there is the other version of Linux, which is yet more used. This is the RT preemption patch for Linux, and I worked on the system too.
Yeah, and it is now integrated on NuttX in Linux mainline, I think.
And now I think the RT preemption is going more and more in the mainline, and there are only very few patches that are required yet to work with real time. But most of the things are already in the mainline.
Yeah, and this a nice coincidence because I used RTI in my master degree dissertation, and it worked very nice. I use it with UC Linux, micro-C Linux, using the CodeFire board, the Freescale CodeFire at that time. Some guy from German, if I'm not wrong, it was Bernard Kuhn, something like that, his name, and he ported RTI to CodeFire, and it was very, very, very powerful as well, like NuttX, and we could use it for application where we need very low jitter real-time solutions. And
exactly. But one of the problems is that it was very difficult to port RTI to all the different kind of ARM embedded system. It was quite difficult. On PC, on traditional processor, it was quite simple to port RTI on AMD, and so on. But the problem was that too many versions of ARM were provided. It was quite difficult. This is why NuttX seems to be a very good solution, because in NuttX we can, in pysimCoder we can work on the POSIX level, and we don't have to think about the target where we want to put our code. The only problem is what is implemented as device on this specific target. We tested on STM32 processor because they are very good coverage with a lot of devices available. For the F7 card, I have only to implement something for the CAN, for the encoder, which is not present directly in the for the Nucleo 144 board. But it was quite simple to get other STM processor and implement these devices on for this card. And as I said, in very few weeks we reached to port very nice things on NuttX to do real controllers.
Yeah.
Clearly, it's not an optimized code, but what for me is interesting and important is that all the code is quite good readable and can be optimized by hand in a second time if required.
Yeah, I completely agree with it, and I face many issues with RTI. we under microcylinder at that time to get it ported and working correctly. And on NuttX, it is way more easy to do, and we don't need to use some how to say alien API. You can use POSIX, and you can share it with other real-time systems that are also POSIX, like Linux, like QNX, and many others. So it's a really nice feature of NuttX to follow the POSIX standard. Yeah.
Yes, of course. And as I said, it was quite simply to port at the end pysimCoder to NuttX. The great problem was to implement the template makefile specific to generate the embedded project. But it was very good solved by Paul Pisa.
Yeah, I agree. Okay, Alin.
So let's get started with the raffle.
Yeah. Alin, your microphone was mute. Sorry. Okay, Sara, please.
I'm gonna share here my window. I already finished the sheet, so the form. So here we have all the participants for this raffle. We have number 2 up to 26. Not the same, the same as the last one. Let's generate the first. The first is number 12. 12 is Lorival José Passos Moreira. Okay, let's go to the next one. Number 15. 15, Wesley Torres. Next one, 22. Adriano Henrique Rezende. Congratulations, guys.
Congratulations, guys. Now we are back and we have a few more minutes for casual discussion. So if we have people that have not presented yet why they choose NuttX, they are invited to speak up.
Okay, who will start?
I don't know. It looks like everybody's shy.
Come on, guys. Let's talk a little bit about your background, how you get involved with NuttX.
Silviu, are you there?
Yes, hello. So I'm Silviu Grigore and I'm a software engineer at Fitbit, which is part of Google. And I started with NuttX 2.5 years ago when I joined Fitbit. At that point in time, the team was already using NuttX for their Fitbit tracker line. And yeah, I loved it because it's POSIX compliant and I can use the same code on both the host and on the device. And in time, so newer products were launched at Fitbit with NuttX, and I developed multiple features on NuttX, mostly on firmware update, which is the topic of my presentation today, on comms and on the sensor device drivers.
Is it possible to replace the firmware on this one? So can we build NuttX?
Yeah.
Is it signed?
Yeah, it's signed.
Okay. So the answer is no, you can't replace it.
Yeah, I thought that you were asking if Fitbit can replace it.
No, if we can, as a community.
No.
Unfortunately.
It's not rackable. Right?
Thank you, Silviu.
Thank you very much, Silviu.
Welcome.
Sara, can you tell us how did you get in contact with NuttX?
Yes, of course. Can you see me? So actually, my contact with NuttX started in a few months. It will complete 1 year in September 1 when I joined Espressif. Before joining Espressif, I didn't know NuttX. I used it to use other OSs like FreeRTOS, and since then, because of our demand to port Espressif chips, I started to contribute to NuttX. One of the things that mostly called my attention was the possibility to have a NuttX shell very similar to Linux with some Linux commands, mainly because I already enjoyed to use MicroPython because of the same approach. I mean, to have a terminal, an interactive terminal, and NuttX seemed too much better. And basically, that's it.
Now you're working with NuttX on a daily basis.
Yes, it's the only RTOS that I have been using since 1 year.
Nice, congratulations.
Yeah. And now Sara not only work with NuttX in the job, but she also in the NuttX Brazil YouTube channel. If the guys don't know yet, Sara, you can talk a little bit about your project, what you already did. I think it's a nice contribution to people in Brazil to.
So me and Alan, we realized that we don't have too much Portuguese content regarding NuttX. We do have in the NuttX channel, which is the channel that is being used for this stream. We have many tutorials that Alan provided during many years. Then we decided to create the NuttX Brazil, which is a Brazilian YouTube channel where we provide some tutorials in Portuguese, and we are we're missing some months, some weeks there, but we're going to back. We got a little bit busy in the last weeks, but we are providing NuttX tutorials there. We started with the very basic, simple step, which is to build NuttX, and then we move on showing how to use some basic peripherals like the WART, I2C, timers, and so on. And we expect to have also the feedback from Brazilians on our channel, so we can create more suitable videos for you.
Nice to hear that you're also doing PR activities and training. Also, I saw that you have quite some patches submitted in the NuttX mainline. I saw your name when I was doing the statistics for tomorrow.
Yes, most of them, as I already said, they are related to drivers for ESP32, ESP32C3, and ESP32S2. But sometimes I already contribute to the apps repository. Like, for example, it was, I think some months ago, I contributed with an example where we could use the pulse view to get a status from the GPIO and see the timer accuracy. Sorry, I need to go there because my
Yeah,
bell is.
your intercom is.
Yeah, just a
ringing.
minute.
No problem.
Thank you very much, Sara.
Alin, good point. Sara was a little bit humble, a little bit discreet about her participation on NuttX. She's a very smart girl. I was surprised when she started on Espressif and started to contribute, and she learned things very fast, even compared to more experienced guys that already work on NuttX. She gets things very fast. She mastered the things she are learning very, very fast. For example, she started working with watchdogs and timer, and now she knows timers and how timers and watchdogs work on NuttX better than most
of us. Yeah,
true. And and she found many issues in the NuttX timer in the drive, not mainly issues, but conceptual issues, but issues in the code itself, missing some things or some things not consistent, and she go on and fixed it. So she deserve our recognition, and I am glad she go out to attend the intercom, because it's not good to say face-to-face things. It's better to say good things for the people when people are not in front of you, and bad things when the people is in front of you. And normally we do it the opposite. Normally.
Yes, I agree. Unfortunately, this small conversation raises another issue, and that is diversity. In the NuttX community, unfortunately, we are mostly males.
Yeah.
So we should try through this kind of meetings, we should try through education to invite a more diverse type of people. Yeah. And if we manage to lower the barrier so that people can easily get into the project and be interested by the project, then we will probably get a more diverse, even speakers population for the next event. Because in this moment, we have very few women or other types of people in the NuttX community.
Yeah, I totally agree. And also, I did some kind of joke, some kind of meme here in Brazil in the LinkedIn, because I don't know if you pay attention, but for this event we have 3 women doing presentation: Yaoyao, Sara, and Irina. And here in Brazil has how to say a program like a news program, like a BBC or other famous program, but it's on an open TV, in the free TV in Brazil, and the program is called Fantástico, like fantastic, and when some football player, soccer player, do three goals, they can ask a music in the fantastic. And because we get three women here, I make a meme. So now we can ask a music in fantastic as well, because we have 3 women working here, presenting here on NuttX online workshop. It's a good complement, good achievement.
Yes, I agree. But if you look at the numbers compared with last year or the year before, it's an achievement. If you look at the overall picture, we have 20 presentations and only 3 are from women. So we should probably improve and encourage them to come and present the great stuff that they are doing, because I bet that there are women out there that actually work with embedded, but they are simply either not acquainted with NuttX or they are shy.
Yeah, I completely agree, and we have women, sorry, in the audience. So, girls, if you are listening here, please get involved with NuttX and start to contributing with the project, because as Alin said, we need to get more diversity, more women working on NuttX as well.
Alan, I would like to add one observation regarding this. For those who don't know, one of the things that made me join Espressif was the fact that I was contributing to, not contributing directly to the mainline MicroPython, but I kind of had my final project on the college requiring for me to implement the support for SPI slave on ESP32 on MicroPython. And so it didn't have in the mainline, in the MicroPython mainline, and I developed that and I presented this on a Brazilian YouTube channel, and then through this presentation and through this activity, I called Espressif attention. So I think the same way that I did that, people like me, juniors, that has just left the university, mainly if we are talking about women, mainly women, they can also start contributing to NuttX, as it is also an open source project, and maybe contribute to one specific company ships or something like that, and also take some advantage of this also.
Yeah. Anyway, guys, I'm sorry to interrupt you, but it is late and we have to start the next session. We can continue the diversity discussion after, if there is time and if there is interest. You can also post on YouTube your ideas for the ones that are not part of this center group. And we will go through them. Maybe we get some good ideas. So for the next presentation, I want to invite Michal Lenc. Lenc. I don't know how to pronounce it.
Lenc, but never mind. Whatever.
Okay. Yeah. So he will present the NuttX support for rapid control application development with pysimCoder.
Okay, so just to be sure, are you seeing my sharing screen and camera?
Yes, we can see you.
Yes.
Yeah. Okay. Cool.
I can't see.
I can only see. Yeah. No.
It's perfect.
Yeah, is it okay?
Yes.
Now it's okay.
Okay. Cool. So hello, my name is Michal Lenc. I'm a student of Czech Technical University in Prague, and during this summer I've been participating on a Google Summer of Code project, NuttX integration with pysimCoder. This presentation is basically a follow-up to the previous Professor Bucher's presentation. And here I would like to talk about my Google Summer of Code project and a little bit more about how to configure and compile NuttX to be used with pysimCoder. So pysimCoder, as was said before, is an open source rapid control application development tool, which was designed and developed by Professor Roberto Bucher. It transfers block diagrams into the C code, which basically means that you can design your control application in a graphical environment and then automatically generate that C code, which can be next run on multiple platforms and systems, including NuttX. The advantage of having NuttX support is that all the pysimCoder block files are NuttX generic, which means that if pysimCoder supports PWM driver, it will support all of the boards and architectures that are supported by NuttX. And it should be just a question of NuttX configuration to be run on with pysimCoder. So in combination with NuttX and pysimCoder, it can be a great alternative to an expensive license programs and prototyping platforms, and can be run on smaller, cheaper microcontrollers. Here in the table on the right side of the page, you can see the currently supported peripherals. So we have ADC support, we have CAN bus support, including socket CAN, we have digital analog converter, and we have also incremental encoder, general pin input-output. There is a PWM support, with also multiple channel support. There is support for sending data over serial port. There is basic support for DHT-XX sensor, and also some support for TCP and UDP. So now a little bit about my Google Summer of Code project. The official name of the project was NuttX Support for Rapid Control Application Development with pysimCoder. This project was selected by the Apache Foundation, which I'm very grateful they gave me this opportunity. The mentors of the project were Pavel Pisha, Roberto Bucher, and Bryan Ashton. The official main goal was to integrate and test pysimCoder support for various drivers supported by NuttX. The more concrete list about my contributions to NuttX and pysimCoder will be on next slides. Main target platform was i.MX-RT 1060 MCU. I also used some STM32, especially Nucleo, and we also planned some demonstrations on RISC-V ESP board, but unfortunately there wasn't enough time to do that. But as I mentioned before, all the stuffs we do for i.MX-RT and STM should also work on ESP. So the i.MX-RT MCU, I've used TeamSip41 board, which is a small and cheap board designed by PGRC company. For the project, I used TeamSip41 baseboard, which is a baseboard for TeamSip41 designed by Czech company Picron. It's an open source hardware, and it has support for various peripherals that are provided in TeamSip41. So there are connectors for serial port, CAN buses, including CAN-FD, Ethernet. There are chips for PWM outputs for DC motor and PMSM control. There's also an encoder input and then ADC support. To be more precise, there is a current sensing support from the PWMs, which is routed to ADC peripherals. The other target was a Nucleo F446RE board. It's a classical Nucleo, supports serial port, SPI, CAN, PWM, encoder, ADC. So what actually have we done during Google Summer of Code project? The implemented support to NuttX was chickless mode support for i.MX-RT MCU, which was a crucial thing to run real-time applications on a higher frequencies. There are some new IOCTL commands for ADC that were merged to mainline. This includes NEOC samples on command, which returns the number of ADC samples which is stored in the FIFO queue. There is NEOC reset FIFO command, which resets the FIFO, and that allows that if I want to make sure that the data that I read from the FIFO are new, I can reset the FIFO before reading data. And then there is NEOC get number of channels command, which was crucial for pysimCoder block application or ADC block to be more generic, because currently the only state where the number of channels in NuttX is defined is in the board sections in the C code. So there was no other chance than IOCTL command how to get the number of configured channels. The other contribution was the option to terminate loop in PWM drivers by number of channel minus one. That's because currently PWM drivers that has multiple channel support runs a for loop through all of the channels and selects only those channels that are configured. So if we want to save some computing time, we can add -1 at the end of the channel list and we can terminate the loop. Then for TeamSip4X boards, I added some encoder and general open input-output support, which was necessary for DC motor control example, which I will present later. Implemented support to pysimCoder during summer of code was socket can support, digital analog converter, multiple channel PWM support, TCP socket block to send data over TCP to real-time plotter, and then some smaller implementations like DHT sensor, PID, discrete PID controller, and so on. There were also some stuffs. Unfortunately, I didn't merge to mainline. One of them is a synchronizations of different PWMs and also triggering of ADC from PWM, which is something that IMX-RT MCU can do. I have a working example in my branch, in my fork repo, but it's currently not in the state that it can be merged to the mainline. There is still some work to do to be able to merge it into the mainline. So we have pysimCoder and we have NuttX. So what now? There is necessary to do several NuttX configuration options. One of the crucial one is, for example, block monotonic, and those configuration options are required to successfully compile pysimCoder with NuttX. For the complete list, please see the NuttX documentation. There is a complete list of configuration that have to be selected in order to run NuttX and pysimCoder. Then after NuttX is configured and compiled, it can be exported to zip file by executing command make export. This file then has to be moved to pysimCoder subdirectory, unzip there, and remain to NuttX export. Then if you enter subdirectory device in pysimCoder and execute make, it will compile the C files for the blocks in pysimCoder. Then pysimCoder can be run either installed on the system or run by executing pysimrun script, and you can design your control application you can design the control application there. I will show the whole process during the example. The complete documentation can be found on NuttX documentation, as I mentioned before. So just some little bit about pysimCoder directory system in case someone would want to create own blocks in pysimCoder or just take a look. Basically, each block in pysimCoder have files in 3 subdirectories. One of them is CodeGen NuttX devices, which contains source codes for blocks from NuttX library. In resources blocks NuttX can be found XBLK files. Those files contain definitions for blocks parameters. So, for example, information how many inputs and outputs blocks have, how many user parameters, and what's the default setting of user parameters. And then there are in resources blocks RCP, BLK, NuttX are Python files. An example of Python files can be seen here. This is a Python file for PWM block. So here we can take the advantage of Python and use functions like sizeof and append. So there can be done things that are a little bit harder in C than in Python. And then all those parameters are passed to NuttX PWM function, which is defined here in CodeGen NuttX devices. The example of NuttX PWM function can be seen here. So we have an input flag, which selects which function is called. So if input flag is initialized, then a function init is called, which initializes the PWM driver. Then in out, compute and set PWM duty cycle and send it through IOCTL command, and then function end, close the device. So that's the way how pysimCoder subdirectories work. So back to the presentation and to my DC motor control example. For this example, I used Maxon motor and with heads rotary encoder. Here you can see the PWM inputs for the motor, and here you can see the connector for the encoder. So what blocks do we need to control DC motor? We definitely need PWM, we need encoder, For our Teensy baseboard, we also need general pin input-output driver because the PWM chips on Teensy baseboard have two inputs. One is for PWM, and the other one has to be selected high all the time in order to allow the PWM output. Then we need discrete PID controller and some blocks like absolute value, subtraction, and math operation. So now I will move to the command line. I have a configuration here. So if I run make menu config, I will go through the configuration. It's basically Teensy 4.1 Python BB configuration with added support for needed peripherals. So if we go to system type, there you can see the support for Ethernet. There is support for 2 flex PWMs and also support for incremental encoder. For Teensy 4.1, it's encoder 1. The Ethernet support is necessary if we want to send data over TCP to the real-time plotter. So there's also necessary to select the drivers. So for PWM, it's in timer driver support where PWM is selected. Then in input-output expander, there is general pin input-output driver, and in sensors device support, there is support for incremental encoder. So that's basically it. Well, there's one other thing. There is TCP IP networking if we want to send data over TCP. So that's the configuration. Because it's quite a big configuration, I took the liberty of compiling it before the presentation, so we just do not spend some time looking at the command line and compiling. So now we can run make export, which creates the zip file as I mentioned in the presentation. This zip file then can be copied to pysimCoder subdirectory into pysimCoder, CodeGen, and NuttX. It can be extracted here and renamed to just NuttX export. So now if we take a look into pysimCoder, CodeGen, NuttX devices, I can run make clean, make sure all is clean, and then make. So this will compile all the files necessary for the blocks in NuttX library. And now I can run pysimrun script, which will turn on the pysimCoder. So here I have prepared the DC motor control example. And as Professor Bucher mentioned in the presentation before, in the left corner you can see the library with all the blocks. There you can see the library with blocks for NuttX. So as I mentioned before, there is ADC, DAC, and so on. But back to DC motor control example. Here you can see the PWM outputs. Each block has some user peripherals where usually you define something like port, which is a route to the characteristic device. There is channel selection, or for this example, it's just one channel, frequency of PWM, and saturation. The similar thing can be found in the encoder block. There is again a route to the device and resolution of the encoder. I have here some steps for the reference signal. The encoder is the feedback, and then there is a discrete PID controller with set proportional, integral, and derivative gain. There is output switch because you can control the direction of the DC motor either by using H-bridge or either by using some software code like I did here with output switch, which select which PWM is used. So when I do have this, we need to set NuttX template makefile. So that is selected, and now I can generate the C code. Okay, so I can turn off the pysimCoder, and this generated my TinyCDC Xcode, which is a loadable application to NuttX, which I can flash to Tinsy board by using Tinsy Loader client. So now we just have to wait a little bit because it took some time for the network to be set. So now we are in NuttX. If we take a look into devices, we can see we have the PWMs, there are general input outputs, and there's also the incremental encoder. I will now just switch the camera to the hardware so you can see the actual Tinsy and DC motor. Okay, so here we can also run Python.
Unfortunately, we can't see anything. Now it appeared.
Yeah, okay, cool. So you should see my command line, and you should also see the hardware, DC motor and DC baseboard.
Yes, now it's okay.
Okay, so I can set TCP. I have two signals, the actual position of the motor and the reference signal. I'll just send some scale. And now I can start the server. So here, if we take a look into built-in applications, we can see that there's application main, which is the application designed in pysimCoder. And I can now run this application, and in the real-time scope, you can see the data sent from the Tinsy board to the scope. I can add some distortion to the regulator. So this is basically the example of the DC motor control. So I think that's all from my presentation. Thank you for your attention, and I'm looking forward for some questions if there are some.
Thank you, Michael, for your presentation. Let's see if we have any questions. No questions for this moment. So let's proceed to the Raffle. And if we have any questions, then we move back.
Yeah, there's a question from Luis. Maybe if I can answer it now, or if you want to wait.
Go ahead, please.
Yeah.
Hi. I have another question, but I'm Masayuki.
So what support is there to... Yeah,
and
sorry,
I remember, I'm Masayuki from Japan, and I remember that you sent a pull request to support maybe Dcache in your Ethernet driver for IMXRT. Yeah, and I commented before. Yeah. But anyway, thank you for your presentation. I'm very happy to see you online.
Yeah, me too. Oh. Yeah. Okay, so to that Luis question, what support is there to change the set point reference live? I don't think there's currently any support. It's something we talked about during the Google Summer of Code project. Maybe Professor Bucher, if he's still here, can follow up. But I don't think there's currently any support. I mean, you can send the reference by something like TCP, but I think that's all that is currently there.
Perhaps Michal.
Yeah.
I did some experience by sending via serial or via TCP/IP the data. We can, for example, build a very simple application in Python and send via TCP/IP the data, and then receiving a TCP/IP block or UDP/IP block that receive this data and use this data to, for example, to multiply or to change some input values. This is possible in this way yet. Okay,
Yeah,
on other
okay.
system is more simple, perhaps on Linux directly with Linux RT is more simple. But on NuttX we have to build some communication channels between the host and the embedded system to change the data. Otherwise, there is the possibility to have, when supported, to have files, but they have been supported by the NuttX system.
Yeah, I don't want to spoil anything, but we are talking at the university about the possibility to implement Silicon Heaven, which is a communication protocol designed by Czech company Electroline, into NuttX and pysimCoder. So that would be an option to read and set the data live. But as I said, it's just in early thought stage.
Okay, let's move to the Raffle. So here we have 16 participants in this last sheet, in this last form. Have just an information. Since we have more people than what we can than prizes, we're not going to give a prize for repeated participants. Okay, repeated winners. So let's do the raffle. First number 2, Luis Linares. Congratulations. Number 15, Felipe Erazo. Number 17, Ismael Luceno. I need to check if this last
Ismael, yeah, he's already won in the first presentation.
Okay,
he won. Yeah, he won one of the first to win.
Okay, let's generate one more. 16, Eric Masquegani Ferdinando. Okay, here we have our 3 contemplated.
Okay, thank you, Sara. I will put on a new demo here. This demo maybe we'll put again tomorrow because it is related to Spresense and the edge impulse. It is about artificial intelligence in the edge. So it will be nice to have it tomorrow after the Spresense talk. But let's see here. Yeah, okay. I will try to. Sara, can you hear me? Hello, Sara.
Yes.
You suggest we can use the share the audio.
Yes, yes. You need to click first on the three dots by the side of the close icon. Did you find it?
I try to find it here.
We have the leave icon, the icon that we use to leave the Jitsi meeting, right?
After clicking 3 points, I can see this three the close button. What is the name of the feature? Maybe I can just
share audio.
I found it. Share audio. Okay, just below share video.
Yes, and when you click on it, it will ask you which tab or window you want to share the audio. So you open the video, you play the video, and then you come to Jitsi, share audio, and select the tab.
So I need to do twice. I need to share the window for the image and share the audio, right?
No, don't click on the share the screen. Click only on the share audio, and then it will automatically share the screen.
They do both.
Yes.
Okay. Let's try it.
Actually, it was supposed to do both. I didn't get to do my laptop.
Yeah, it is strange. But by the way, let's see. Window. Okay, I got the window. Share. Yeah, it seems to work here. Let's play it.
My name is Moreau, and I'm a user.
Yes, it's working. Perfect.
The goal of Edge Impulse is to empower embedded developers to build applications.
Actually, Alan, stop the video. I can't see the video. I'm just listening to the audio of the video. Now I can't see you. I can't listen to you. You are mute. Unmute yourself.
Yeah, I think we need to do both. He just sent an error here. Couldn't share system audio when I click in the window with the playing video. I'll do the other way because this way the other way is supposed to work. I will select the window with the presentation. Can you see the window?
Yes.
And then?
My name is Louis Moreau, and I'm a user success engineer with Edge Impulse. The goal of Edge Impulse is to empower developers to solve a real problem.
Thank you.
What was the sequence of commands did you use?
A PhD machine
just share the...
During the small workshop, you will learn how to build a movement classification
I will start again because we are talking over the video. Sorry.
My name is Louis Moreau, and I'm a user success engineer with Edge Impulse. The goal of Edge Impulse is to empower embedded developers to build applications and solve.
Alan, we can't hear the audio of the presentation.
Okay, here we go again. I need to keep my audio. I keep my audio on. Otherwise, if I close my microphone, it will stop to work. Okay.
So the audio is coming. The audio is coming from your speaker.
Yeah. Unfortunately. Yeah.
Okay.
Okay. Please mute yourself as well, and I will start it again. Sorry, guys.
My name is Louis Moreau, and I'm a user success engineer with Edge Impulse. The goal of Edge Impulse is to empower embedded developers to build applications and solve a real problem using machine learning on edge devices without having a PhD in machine learning. During the small workshop, you will learn how to build a movement classification model that runs on the Sony Spresense board, where we will compile the inference model so that it can run with a NuttX real-time operating system. Just as a reminder, Sony Spresense is a small but powerful development board with a 6 Cortex M4 microcontroller, integrated GPS, and a wide variety of add-on modules, including a camera module, a microphone, an accelerometer, and we are going to use the accelerometer on this workshop. This board is fully supported by Edge Impulse, and you will be able to sample raw data, build models, and deploy your trained machine learning model directly from the Edge Impulse Studio. So yeah, we can get started. So the first thing you need to do is to flash the board with the default Edge Impulse firmware. To do so, you can go to doc.edgeimpulse.com/docs/Sony Spresense. You will find a small tutorial on how to do that, including a video from Jenny. This is pretty easy. I've already done that. You just need to download the latest Edge Impulse firmware. Make sure you have Python 3.7 or higher installed locally on your laptop, and then you just need to run the script, which is here on my laptop. Which is here. So you just double click on the flash here, Mac for me, but we have a Windows or Linux script as well. Once your device is flashed, you will see something similar to this, and you can directly log to the studio and get started. So if you do not have an account on Edge Impulse Studio already, you can create an account. Here I'm just going to log in, and I will create a new project. So Sony Spresense tutorial. Create a new project, and you will arrive on this nice dashboard. First thing I usually do is to just make sure I selected the right board so that the latency and performance calculation will be calculated according to your board. Here, this one. And then you can navigate to the data acquisition tab. We have a useful tool to connect using web USB. If you do not want to use that, you can use Edge Impulse Daemon to connect to your project. Here I'm going to use this one. Make sure you use Chrome. I think it's also supported on other browsers. Yeah, I know Chrome, it does work. Let's wait for a few seconds. So now you can see your board. You have several sensors on the board. Let me show you. Here I've got the camera module. This is the main board, and then this is the extension board. So we're going to use the accelerometer, and I will try to just collect some data that we will use after to train our model, and we'll try to classify those movements. First sample would be up down, for example. Let's do 10 milliseconds, and then I will start sampling. So the up down movement will look like that. Up down. Here, you can see the visualization of your accelerometer data. I will try to collect some more. Maybe another one. So 30 seconds is probably not enough. So I will pause the video. I will try to collect as well other kind of movements. You do that. I'll try to collect right now another movement so they can see the difference. So circle, for example. So we'll just draw circles in the air. I'll do another one. Well, I'll actually do 2 more. Another one. And usually it's also a good idea to have a unknown movement kind, so I will just move randomly the board. Here, another one. So I have 30 seconds in each class. Well, I will have 30 seconds in each class. I recommend to add much more data, just as a demonstrating purpose. This should be enough. So this unknown seems to have like a regular pattern, so I will just delete this one because I'm not satisfied with it. It might look too close to the other up down or circle kind of movements. Okay, this looks more random. So now that you have your data, you can navigate to your to create an impulse. An impulse is a mix of digital signal processing and learning block, digital signal processing blocks and learning block. Here I will leave those default parameters. I will add processing block spectral analysis, which is really usually good. So let me just great for analyzing repetitive motion such as data from accelerometer. So that's more than fine with us. We have several other digital signal processing blocks. If you are using audio, you can use some MFCC or MFE. MFCC is mostly great for recognizing human voice, etc. But here for accelerometer project, we'll keep with the spectral analysis block. And then I'll use some classification, so keras, which is going to be a neural network that we are going to train. So we'll have 3 output features that our neural network is going to try to classify. So circle, unknown, and up-down. I save my impulse, then I can navigate to the spectral feature tab. I'll try to leave the default parameter by now and just I will try to check if I can detect some clusters in my different movements. Usually when you detect different clusters, it's good because it will say that the neural network is likely to be able to classify the movements correctly. So here I've got some nice clusters. You can see the data are well split in this 3D visualization. So I'm kind of happy with that at the moment, and now I will move to the neural network. So what is important to see here is that you can start training your model and build some machine learning project, really without being an expert in machine learning. So we just unlock all the capabilities for you as embedded developers, so that you can use all these advanced techniques. So accuracy here, it seems like I've got some pretty good accuracy. The model seems to be converging, which is good. And this seems fine. Let's check the accuracy in the integer, well, in the quantized model, because it's smaller. Well, for accelerometer data, it doesn't really matter because the difference is not really high, but for audio and for image classification, usually it does matter. The models are way smaller in quantized version. Just wait until the profiling is done. Good, we wait a few more seconds and the accuracy and the confusion metrics should appear. So now it's profiling for the Eon compiler, which is something that Edge Impulse developed so it can compress the model one step further. So it has the same accuracy, but has a lower footprint on the RAM and ROM on the model. So here, yeah, we have a perfect accuracy. Well, those kind of movements are not really hard to classify. So you can have like an overview of the confusion metrics. You can here, let me just check the incorrect ones. Here, this is this movement. So over here, it kind of predicted a circle. Well, we can see a small pattern, but in the overall project, it's not really a big deal. Then you can just try the live classification. So let me connect my board again, and I will try to classify the movements. And then we'll see how to build the device, build the model onto the device. So I'll start assembling right now, and I will start with a up-down movement. I can also like change and do some circle at this point, and it should like on the results just say, okay, the first rows were, well, the first samples were up down, so up down here, and then at some points we will change it to circles. So here that was in between. Huh. So maybe this messed because I changed the thing, but I would try to just do some other circles at some point. Just this again. Start sampling, and I will just draw a circle here. Okay, interesting. So here it just recognized some unknown movements, and then at the end some circles. Well, we don't have much data in this project. If you want a really good accuracy in real life, I suggest you add much more data. This is not a problem. We will go to deployment so that we can deploy the C++ library. One thing that we are going to use here is to use directly the Sony Spresense binary, so we can analyze the optimization. So we can see the footprint. So this comes with so we packaged both the NuttX Realtime OS with the Edge Impulse SDK. So it's going to create a mix of both. So it just brings all the capabilities together. And with this, you have directly a binary ready to go. I'll just build it, and then we will flash it on the device. So here we have several warnings. And you can also check on our GitHub page. Let's check where it is. here while it's compiling. So if you're interested in directly compiling the C++ library, you can go to this web page, standalone example standalone inferencing. So it will just explain to you how to just compile the standalone C++ example using the Spresense exported SDK and the Edge Impulse SDK. It's not really complicated. If you do not have all the dependency installed, you can build the firmware just using Docker. It's way easier. Usually it's what I do. And then you can flash the device, and it should be able to run the inference directly on the board. And obviously you can modify this main.c++ file so that you can create your own application. So here we have the example on how to just flash. It's the same way that to flash the default firmware. And once you have that, you are ready to go. Open the Sony. Here, Sony's Spresense tutorial. Open that. So V1, let me flash it using the flash mac command. Oh, I need to allow developer access. Security and privacy. Open anyway. Yeah, just open the script. Flashing the board. So right now it's flashing the board with the latest, well, with your custom model that you just developed. And once you're done with that, you can run the, we'll open a new terminal here. Maybe let me zoom in a bit for you. It's going to be easier to see. Now the board is being flashed. And once you're happy with this, saving package to NuttX. Okay. Okay, now it is flashed, so you can now run the Edge Impulse run impulse. Remove that. Let me zoom a bit here. And we'll use the Edge Impulse run impulse. So now the board is not moving at all. Let me just do some up-down movements. We'll see how you react. So up-down movements. Here the inference works. Let me try with the circle one, just before it had troubles. Circle. So here we can classify circles correctly. Again. So yeah, we saw together how to build a custom machine learning model that runs on this Sony Spresense board, and how to compile it directly from the studio. It will compile Edge Impulse SDK and a NuttX Realtime SDK on the Realtime operating system. Thank you for watching. If you have any questions, feel free to reach us on the Edge Impulse forum, so forum.edgeimpulse.com. Yeah, have a great day. Bye-bye.
Okay, let's stop here just a second. Okay, we are now going to wait just for the next presentation, only 6 minutes. Let's see if we have questions. Unfortunately, Luis, the guy who presented Luis, he's from French. I don't know the right pronounce. He's not here today to explain. We hope tomorrow they will be here to answer some questions, but today he's not available. Okay. By the way, we don't have any questions about it. Just to talk a little bit about their company, many people here already read about it or saw some project developed by Edge Impulse. They are doing very good in the IoT edge. So they are mostly people come when they create the startup. They are from Army in Cambridge, if I'm not wrong, and then they decide to leave Army to create this startup, and the product is very nice. They have many features, and they can detect many kind of events. So it's really nice project, and a really nice product to use for IoT in the edge. Okay, let's see. Sara, can you hear me?
Yes.
Okay, just to confirm, I don't know if you already have lunch. If you want to do it now, I will follow here, and after that, I'll try to get it as well. And I think now I need to pass the baton to you, but you and Maju. But I realize maybe you not have eat food yet. So
Okay, that sounds good. Me and Maju can have lunch now, and in the next session we change again, and you have lunch, and we take care of the presentation, the live.
Okay, enjoy it, and I will do it later. Okay.
Thank you, Alan.
Okay, so thank you.
I'm here for another session, Alan.
Nice to hear you are still here.
I will be your backup.
Okay, thank you, Ali. So we still have some people that didn't talk a little bit yet. Philip, can you hear us? I think Philip already talked, right?
Yes, I'm here.
Yeah, I confused. Sorry. Yeah, we have Masayuki here yet, but I suppose it's a little bit late in Japan, right, Masayuki?
Yes, it's too late here, but I will. I want to wake up and hear the session as much as possible.
No, nice to have you here. I know it's not easy because it's too late in Japan. I think it's almost 1 a.m., right?
Yes.
Yeah.
1 a.m. Yeah.
Oh my God. Yeah. Okay. So thank you for staying here, and just to let other people know, Masayuki is a great contributor to NuttX. He helped a lot to improve and create new features for SMP, symmetric multiprocessing, right?
Yes.
And
so tomorrow, yeah, I will.
Yeah, tomorrow you talk
yes.
about it, right?
Mm-hmm.
Yeah, and also you present about it in many events, right? In Linux and
yes.
Embedded Linux conference, right?
Mm-hmm.
Yeah.
Yes, we did.
We did. Yeah. For people who don't know, we present in Portland together, right?
Yes.
In 2018. Yeah.
2018. Yeah.
That was 3 years ago, right?
Yes. 3 years.
Yeah. It was really nice, and the event was really great. Unfortunately, Linux Foundation didn't record our event right at that time.
Yeah, unfortunately,
Yeah, they are mostly focused on their own events and also on Zephyr, but it's okay. It's their house. We cannot say anything else. They are right, but it's we are glad they already opened the door for us to present about NuttX, and it's also was good because it sparked the desire to have our own conference, and we did it in the following year, right? In Netherlands, right?
Netherlands as the first NuttX international workshop was great. And actually, perhaps many people saying that it was the first time for almost us to see Greg. So that was very nice.
And I think that was the only live record from Greg we have until now, right? We don't have others, and it's really nice we did it and we met Greg there, and I hope next year with the COVID-19 disappear, you can try to do it live in face-to-face again.
So we were going to have a workshop in Japan, but as you know, there was a COVID-19 problem, so we moved on to an online event. But I think it's very good for us because we have so many listeners. So worldwide, it's if we have a conference only in Japan, maybe only some people can join.
That's true. Thank you very much, Masayuki.
You are welcome.
Okay, now we have a presentation from Fitbit from Silviu. Silviu, can you hear us?
Yes, hello.
Hello. Nice to meet you, Silviu.
Hello, nice to meet you too. I'm Silviu Grigore, and I'm a software engineer at Fitbit, which is now part of Google. I've been working with NuttX for the past 2.5 years as a member of the Fitbit Tracker platform team, and my work revolved around firmware updates, comms, and sensor device drivers. And today I will be talking about firmware updates on Fitbit devices. Alan, could you please play the recording for me?
Okay, I will start it here. Just a second. Thank you very much, Silviu. Just a second. I need to open it here.
Hello, everyone.
Oh, sorry. Need to share it first.
Hello, everyone. My name is Silviu Grigore, and I am a software engineer at Fitbit, which is now part of Google. Today, I will be talking about firmware updates on Fitbit devices. But first, I want to say a few words about myself. So, I am a software engineer, passionate about low-level programming, and I have a background in compilers networking, and embedded systems. As a member of the Fitbit Tracker platform team, I have been working with NuttX for the past 2.5 years. My work revolved around firmware updates, comms, and data acquisition from various sensors that we are using on our devices. So today I will talk about the firmware update process on Fitbit devices that are running NuttX. So we will first describe the flow for our initial implementation of firmware update, which is done in foreground. Then we will discuss about the limitations of this approach and the optimizations that we did to improve the user experience. One of these improvements is trickle update, which is downloading chunks of the update in background. And another improvement is delta update, which is sending binary diffs instead of full update files. In the end, we will draw some conclusions. So we will start the presentation with the foreground firmware update. First of all, what are we updating on our trackers? First, the bootloader and the operating system image. Second, the system assets, which include fonts, translation table, and images that are used by the user interface. The system assets are split into locale independent assets, which are common to all languages, and locale dependent assets, which are used to support a specific language. We are also updating the application code and application apps and the firmware images for those peripheral components that are running their own firmware. Example of such components on Fitbit devices are the NFC, the GPS, and the touch. So how is the update packaged? The update is packaged as a collection of files which are called bundles. The update files are using the ELF format, which acts as a container for the raw image. Besides of the raw image, the bundle includes some metadata, which is used by the firmware update process. So we have one file for the bootloader and the operating system image, one file for the locale independent system assets, and one for the locale dependent system assets, one file for each application, and one file for each peripheral firmware image. The bundle files are generated by the build system, and they are uploaded to the server, which delivers them to their devices. So how is the update delivered? We have a Fitbit application, which is running on a mobile device. This application is used to connect to the Fitbit ecosystem, and it includes device pairing, synchronization, firmware update delivery, and many more features. The users log into this application with their Fitbit account, and they pair the Fitbit device with the application through BLE. When a new firmware update image is available, the user receives a notification in the Fitbit application, and when the user initiates the firmware update from the application, the mobile device connects to the server through either Wi-Fi or mobile data. It requests the update image from the server, and it sends it to the Fitbit device through BLE. For security reasons, the firmware update image is encrypted end-to-end between the server and the Fitbit device, and the mobile device only acts as an intermediary. Also, in case something goes wrong with either of the two connections, a resume mechanism
was implemented to avoid downloading the entire image again. How is the update installed on the device? We are using two special RAM levels to free up some RAM memory and to avoid interfering with other tasks. So these RAM levels are closing all the unnecessary tasks, including the UI. We have only minimal UI while downloading and installing the bundles. And we have an OTA RAM level, which is used for bundle downloading, and a firmware update RAM level, which is used for bundle installation. We have a two-step install process preceded by a preparation step. In this preparation step, the bundles are validated, and the bootloader is configured to install the bootloader and the operating system image, and the system is rebooted. Upon reboot, the bootloader is installing the image and it's rebooting the system again, and then the system is booting up the new OS image and it is installing the system assets, the applications, and the peripheral firmware images. So as we can observe in this diagram, the update is installed to the internal flash, external flash, and the peripheral devices. The bootloader image is installed only in the internal flash. The OS image is split between the internal flash and the external flash, depending on the importance of the code. The system assets and applications have two parts. Metadata part, which is installed on the file system in the external flash, and the ROMFS image, which is installed in a specific application slot partition. The peripheral bundle contains some configurations that are installed in the file system, and the firmware image, which is installed on the peripheral device. Due to space constraints, the update bundles are deleted after the installation. Now that we saw how the bundles are downloaded and installed for the foreground firmware update approach, let's talk a bit about the limitations of this method. So, first of all, because we are using the two special RAM levels that are keeping alive only the tasks that are essential to the firmware update process, the device cannot be used during both download and installation steps. Also, doing large BLE transfers increases the probability of a disconnect, and re-establishing the connection introduces an additional overhead. This disconnect may be caused by incompatibility with the mobile device BLE chip, poor connectivity due to interferences, or user simply not keeping the Fitbit device in the proximity of the mobile device. Also, multiple disconnects may lead to aborting the update and starting it from the beginning, in spite of the resume mechanism that we have implemented. In order to speed up the download, the device is running in a high power mode, which leads to faster battery draining. Now that we discussed the limitations of the foreground update approach, let's see what we look for from potential improvements. First of all, reducing the duration of the BLE transfer, which will lead to a lower probability of seeing disconnects that may trigger restarting the update from zero. Reducing the duration of the BLE transfer will also reduce battery draining during the update. And this is very important because we need the battery to be above a specific threshold at installation time in order to perform the installation in a safe manner and not risk breaking the device. Another improvement point would be to also reduce the overall time during which the device cannot be used, which is directly affecting the user experience. Okay, so let's talk about our first improvement, which is trickle firmware update. In order to be able to explain the trickle update mechanism, we will first introduce the device synchronization process. The device synchronization process is using the same infrastructure as the foreground update, but it differs in the data exchange between the server and the device. The mobile application is still acting as an intermediary, and the data is still encrypted end-to-end between the device and the server. But right now, the device is sending sensor data and logs to the server, and it's receiving configurations and process data from the server. Synchronization can be initiated in the mobile application by the user in foreground, or it can be done in background every 15 minutes if this feature is enabled. The background synchronization requires a BLE bond with the mobile device, and the Fitbit device needs to be in range. So, how is the update delivered? First of all, the update is packaged the same way it's done for the foreground firmware update. The difference is that instead of downloading the full update at once, the update is split in chunks, which are downloaded during background synchronization. The size of the chunks is configurable, and it should be small enough to not introduce a significant overhead in the background synchronization process, leading to problems similar to those encountered during the foreground update. Also, because we don't want to wait forever for an update to be delivered chunk by chunk, we implemented a configurable time window during which the update chunks can be delivered. When this window ends, the rest of the update is downloaded in foreground. Okay, so let's discuss about the advantages of this approach compared to the foreground update. So, packaging and installation is the same as for the foreground update, but the BLE transfer time is reduced because the update is now split into smaller chunks which are delivered during background synchronization. The time while the tracker is unusable is reduced, and in the best case, only the installation is done in foreground. Okay, now regarding the limitation of this method, delivering the update takes longer time, days, maybe weeks from the moment the update was released. Also, it's highly dependent on users' behavior because the device has to be connected all the time for the update to be transferred quickly. And in the worst case, when the device is not connected during the update time window, it will revert to full foreground update. Also, devices using trickle have to reserve in the file system the space needed to store the update bundles. This is not required for the foreground update because device synchronization is forced just before starting the bundle download. And this way, the space that was previously occupied by the sensor data and the logs that were uploaded to the server during device synchronization can be used to store the update bundles. So now that we saw how trickle update is working, we can go to the next improvement that we did, which is Delta firmware update. First of all, how is the update package? It's now a mix between bundles and patches. We are still using bundles for peripheral firmware images and patches for bootloader and operating system image, system assets, and applications. Due to the space constraints that don't allow us to keep the current builds bundles, in order to be able to recompose a bundle corresponding to the new build with the data that we have on the device, the diff is computed between the current build's raw image and the target build's bundle. So we are still using full bundles for the peripheral components because for various reasons they don't allow us to read their firmware image. One example would be the NFC device, whose firmware image can't be read due to security concerns. Let's talk about the format of the patches that we are using. The patch format is binary, and it includes a header and the data. The header part contains a magic value, which is used to identify the file as a patch, and the patch version, which allows extending the format in the future. It also includes the target bundle type and data needed to retrieve the raw image from the flash. For the bootloader and the operating system image, it includes the internal and external flash mapping. And for system assets and applications, it includes a universally unique identifier. The data part contains the diff between the raw image and the bundle. Now let's discuss about the diff format. We are using the BSDiff algorithm for diffing and patching, and the LZG algorithm for compression and decompression. The requirements used during selection of diff and compression algorithms were the following. We search for algorithms that are generating significantly small patches. We are able to generate patches that are between 4 and 50 times smaller than the target bundles. We were also looking for algorithms that were easy to understand and port to an embedded environment. And we were looking for projects with a permissive software license. A few words about BSDiff. BSDiff was developed by Colin Percival, and it's a block move algorithm. It was optimized for executable files, and it's aiming to get the minimum patch size. Since the diff is computed on the server, which has enough resources, in this presentation we will be focusing on patching, which is done on the device running in a constrained environment. BSDiff uses a binary format consisting of a header and a bunch of blocks that include commands and data. So the header contains the magic value, which is used to identify the file as a BSDiff patch, and the size of the target file, and then the string of blocks, and each block has a fixed part which contains the bytes corresponding to the three commands: patch, copy, and skip. and a variable part corresponding to the data associated with the patch and copy commands. And let's see how these commands are working. The patch command is reading the same amount of bytes from the current offset of the patch in the input file. It sums them up and it writes them to the target file. The copy command reads a specific number of bytes from the input file and copies them to the target file. And the skip command updates the offset of the input file to ignore a specific number of bytes from there. Next, we will discuss about the LZG algorithm, which is a variation of the LZ77 lossless data compression algorithm, which was developed by Abraham Lempel and Jacob Ziv. This algorithm is using a sliding window to look back for patterns in the input file. These patterns are encoded as commands in the output file. The compression ratio of the algorithm depends highly on the size of the sliding window, because a larger sliding window allows finding more and longer patterns, resulting in a better compression ratio. The archive format is binary, and it consists of a header and a stream of commands and data. So the header contains a magic value, which is used to identify the file as an LZG archive, the size of the original file, and the size of the target file, and an optional checksum of the original file. It also includes the method used for decompression, which can be either LZG or plain copy. In case of the LZG method, it will also include 4 markers, which are the 4 least frequent byte values in the original file. These markers are used to encode the commands, and they were selected in such way to minimize the number of escape sequences for the marker literals. The rest of the archive is composed of a stream of commands and data. In case of a non-marker or an escape marker, which is basically a marker followed by 0 byte, the value is simply copied from the input file to the output file, and the actual commands are copy commands, and there are 4 of them, and each is preceded by its corresponding marker value. These commands are used to copy to the output file a specific number of bytes from a particular offset in the same output file. The commands are differing in the size of the copied blocks, offset, and length. So now that we know how the patches are generated, let's see how is the update delivered. The patches are computed on the server, and the same foreground update mechanism is used, except that now the server is sending a mix of bundles and patches instead of only bundles. If patching fails for a specific file, we count the number of failures, and when a threshold is exceeded, the device will request a bundle for that file on the next update retry. Also, the device will request bundles for the firmware images corresponding to peripheral components. Upon a retry, so for all the files for which patching worked fine previously, the device will still be receiving patches. So how is the update installed? We added an additional step to the foreground installation process. This new step is iterating through the list of patches and bundles, and is identifying the patches by looking at the manifest received from the server or at the magic value from the file. The list of patches is sorted in descending order by the patch size, and we do this to minimize the total size of the update files while applying the patches, given that each patch is deleted immediately after applying it. And once all the bundles are generated, the installation continues normally. So previously, we said that the patches are applied over the raw images. This diagram is pretty similar to the one from the installation slide, except that the direction of the data is different and the peripheral component is lacking because it's not supported. Also, here we are talking about raw images instead of bundles, and the bootloader and the OS image is retrieved from the internal and external flash using the mapping included in the patch. The application and the system asset images are retrieved from the external flash file system and partition slots using the identifier included in the patch. The identifier is used to determine the slot number, and then based on this slot number, the address of the slot is retrieved from the partition table. All these raw images are loaded with the help of a character device driver that allows reading the contents of both internal and external flash. We will now detail the changes that we have done to BSDiv and BSPatch, which is the patching component of BSDiv, and LZG in order to use as little RAM memory as possible. We didn't have to do too many changes to the diff and compression implementation because they are running on server, which has enough resources. We only did a small change to compression to reduce the sliding window size in order to trade compression ratio for RAM memory consumption at decompression time. First of all, we had to implement support for streams in both BSPatch and LZG because the original implementation was loading the entire input files and generating the entire output file in the RAM memory. This means that both BSPatch and LZG had to be modified to work with fixed size buffers and keep the patching and decompression state. The original BSDiff and BSPatch implementation was using the bzip2 algorithm for compression and decompression, but it wasn't feasible to port BSDiff to our constrained environment, and we had to integrate the BSPatch and BSDiff with LZG, and also we optimized the sliding window buffer of LZG to work as a circular buffer, which is shared read-only with BSPatch. In this diagram, we can observe the entire patching and decompression flow. So the patch file is passed to LZG, which does decompression on demand. The character device driver is configured to retrieve a specific raw image for a specific component, and is passed to bspatch, which is generating the target bundle file as an output. The flow is the following. LZG reads the data from the patch file until it fills its input buffer, or there is no more data in the patch file. And then LZG consumes the input file by doing either literal copies from the input buffer to the work buffer, or by reading commands from the input buffer and do the associated copies from the work buffer to itself. This is done until the work buffer is full, and then bspatch consumes all the data available in the LZG work buffer by executing the bsdiff commands. So the patch command reads the data from the character device driver to the bspatch work buffer, and it sums it up with the data from the LZG work buffer, and the copy command simply reads the data from the character device driver and to the work buffer, and the skip command simply updates the file offset of the character device driver to ignore some data. When the bspatch work buffer is full, it's written to the output file. And when the LZG work buffer is consumed completely, LZG fills it again, and this way bspatch can continue the process, and so on. So what are the advantages of this method? First of all, the duration of the BLE transfer is reduced up to 10 times, which translates to a smaller probability of disconnect and reduced battery draining. Even though the patching step adds to the installation time, the overall update time is significantly smaller than foreground update, half the time in some cases. This means that the device is unusable for a smaller period of time, improving the user experience. And now the limitations of this method. First of all, it will revert to a foreground update if the raw images are corrupted, but this is very rare. The size of the update is variable depending on the differences between the two builds. Also, the additional patching step increases the installation time. Peripheral components are not supported for Delta update because they don't allow reading the firmware image, but this could be done if we save the current image on flash, but we have to reserve the space for it. And another limitation would be that the server has to compute and store the diffs for every combination of released builds. Okay, so we will now draw the conclusions. Foreground firmware update works well, but Trickle and Delta improve the user experience. Trickle is suitable for devices that have the space to store the update files at any time. It requires more time to deliver the update, and it depends on the connectivity of the device, but the device is unusable only during installation. Delta is suitable on any device. It adds some extra time for installation. It needs the raw images to be valid, but the update is delivered quickly. And why not use both of them? It could be possible for devices that allow Trickle because we need to reserve the space for the mix of bundles and patches. Also, in order to not increase the installation time for Trickle, the patching step should be done in background, and this way the build will be delivered faster and the device will be unusable only during bundle installation. That was it. Thank you so much for your time, and I would be happy to answer your questions.
Okay, thank you very much, Silviu. Really nice presentation. And let's see, I think we don't have any questions about the firmware update in NuttX. Sorry, the external noise. We have children in the next floor. Okay, Silviu, sorry for the external noise again. About the Delta, it works with any firmware, no matter what its size. I mean, it is able to, for example, if the GIF is not, if the difference is in the middle or in the end of the binary, it works perfectly, right? No matter.
Yeah, so on our devices, it works on the former images that we currently have. So yeah.
Nice. And is it? I mean, it's complicated to implement from scratch. For example, if we decide to create something similar for NuttX, I mean, what should be the suggestion you could do for people that are have the same issues? For example, they are doing firmware update. For example, now we have, for example, MCU boot. You can do it using MCU boot, but I don't know too much about MCU boot yet. But I think it's not supported on MCU boot. So let's suppose we want to create it from scratch. So how could we do it? I mean, in mostly what you need to look to create it. What are the golden rules you can do for the people that willing to create their own implementation?
Yes, so first of all, they should look at the specific of the images and select a patching algorithm that gives the best performance, whether in terms of patching time or in terms of patch sizes, depending on the requirements. The same thing for the compression or decompression algorithm. Also, depending on the specific of their architecture, they should look. There is always a trade-off between the RAM memory and ROM memory and the performance of the decompression, and we had to trade off some performance for using as little RAM memory as possible.
Yeah, I agree. And I think the Debian distribution has support the .deb package. They have support for Delta update. I don't know if you already read about it or see about it. They have this support, but I don't know if it is used often. I suppose so, because sometimes when a package is updated, they don't need to download all the package. They just send a small diff as well. So it's the Delta update on Debian is there for a long time, but I don't know more details. I remember they support it, but I didn't go on to read more or look their implementation.
Yeah, we haven't looked either at the Delta support from Debian.
Yeah, so they did it in very similar way, right?
So I don't know about Debian, but I know that Google is also using for Android packages the same BSDIF algorithm.
Yeah. In Android, when we receive, for example, the system update, for example, they just send some few megabytes. They don't send all the system all together, right?
Yeah.
Yeah, that's nice. Okay, Silvio, thank you very much. I think now Sara and Maju will do the draw. Sara, are you here?
Yes.
Nice.
Okay, let's make the draw. Can you see my screen?
Yes.
Yes, we can.
So we have number 2 up to number 15. Okay, number 5, Nuno Felício. Let's go for our second winner. Number 8, Carlos Gustavo Merola. Let's go to our third and last winner. Number 2, Nelber Souza. Congratulations, guys.
Sara and Maju, are you going to follow? I will try to put the demo here, but I don't know if I think I don't have it in my computer. I'll try to.
Which demo are you talking about? Tell me the name and I will look for here in the folder.
I sent it yesterday to Maju, but I don't know if she downloaded it. I didn't download it from Wilderness Lab. They talk a little bit about their system and how they. I will download it here because it's small, and we have time to play it, I suppose. Okay.
Yes, if it is 8 minutes, we have time.
Yeah.
And you also can go to have your lunch.
You didn't. Okay. I mean, I already did it during the Silvio presentation because it was a little bit longer, so I was able to launch. Thank you. It is downloaded here. Just a second. It is. I don't know what's the final size and the.
I can try to share my screen if you want to.
Did you download already or not?
No, I am from Google Drive.
Okay, no, I am download this. Don't you worry.
It's okay. So.
Thank you. Okay, it downloaded. Let's play it.
Hey folks, my name is Bryan Costanich, and I am co-founder and CEO of a company called Wilderness Labs. And we make a platform called Meadow. Now, Meadow is pretty awesome. Meadow enables you to build embedded apps using the full .NET platform, and then run them on microcontrollers. And when I say full .NET, I mean it. I mean like modern .NET Standard 2.1, and soon we'll have .NET 6 support. Not micro framework or other legacy technologies. And the thing about our platform is that it has a strong inherent security posture, and we've been building out this offering called Meadow Cloud that enables you to manage those devices at scale out in the field. And it's really a platform that is designed for enterprise IoT development. So our customers are typically building industrial and commercial IoT and are going out to the field at large quantities and need to make sure that their devices are secure, they can update them over the air, and manage them in the field. Now, you know, a lot of you folks, if you're watching this and you know at the NuttX conference here, are probably thinking, well, you know, I mean, first of all, you're probably a skilled embedded C developer, and you're used to like low-level programming, and you understand the voodoo necessary to get make files running and et cetera. And you might be asking yourself, well, why is this interesting to me? And I want to talk a little bit today about how NuttX has really enabled us to build a platform that vastly reduces your time to market and makes embedded development a lot easier. And to understand this, we need to understand that we are in the midst of a quiet revolution. So the last 10 years, we really talked a lot about mobile, and mobile was kind of technology du jour. But now something's changing. The world of technology is spinning, and now we're in this space where embedded computing and IoT development is really the new epoch, right? And in my lifetime, we've gone from this place where back in the 80s, Bill Gates had this vision of putting a computer on every desk and in every home. And now we're at a place where we can literally put a computer in everything, everywhere. And this is really a consequence of the mobile revolution that brought us really fantastic hardware and, you know, commodity cheap 32-bit microcontrollers and sensors of all sorts, and really great battery life, etc. And what's happening now is that IoT and this embedded world is now much larger than mobile by nearly any way that you sort of size it. And in fact, IoT today is already 3 times the size of mobile, and in just a few years, there will be 10 times as many non-mobile connected devices on the planet as human beings. And so this is really driving a major shift in our industry and in our careers and what we're working on. But what's happening is that there's a real shift in the culture of development. So nearly everyone now is tasked with building IoT. I talk to companies all the time that, you know, had never even considered doing hardware before, and now all of a sudden, you know, you've got these teams that are having to build hardware. And what's happening with that is nearly all of these projects are failing. Now, most of them are failing early, which is good, but they're still failing, which is bad. And what's happened is that there's this real like lack of developers, of skilled hardware developers in the industry, because now we have a whole lot of non-embedded developers that actually need to do hardware development. And so we have set out to make hardware development as fast and easy as doing web or mobile apps. And our platform makes it easier to develop on hardware than MicroPython, but as performant as C. And there's no real tool chain set up. You know, when you get a Meadow device, you plug it in, you open up Visual Studio Code or Visual Studio and hit File New, and that's basically it, where you can do, you know, at the terminal .NET New. And this is really all made possible by NuttX. So for us, in our platform, NuttX is really at the very base of it and drives sort of everything up on the device. So I mentioned earlier, this is a full stack platform. And so we've got a device piece and we've got a cloud piece. And on the device piece, we have this thing called MeadowOS. And MeadowOS is a multi-layered thing that at the base of it has NuttX. And NuttX provides our micro real-time operating system. And on top of that, we have the .NET runtime via Mono. And then we have OS services for power and sleep APIs. And then we have Meadow Core, which are all of our hardware APIs. And then on top of that, we have this massive open source library called Meadow Foundation. And Meadow Foundation makes hardware development plug and play. So you grab a sensor or display or whatever off of SparkFun or Adafruit, you plug it in and you just have an API and you run. You don't, you know, you can grab a package off of NuGet and you're just going. And like I said, all of this really is possible through NuttX, and we're really excited to be here. Thank you, Alin, for for inviting us. And we really like NuttX, and we really believe in the open source ecosystem. I come from that. A lot of my team comes from that, and I want to talk a little bit about why NuttX is so awesome for us. And the first thing is that NuttX is really built around standards. So NuttX comes from a place of the APIs and whatnot are all POSIX compatible, which is really nice because for us, we run Mono on top of NuttX, and that's really only possible because of all these Linux APIs, right? The other thing about NuttX is that the kernel is really, really incredible. So NuttX has been around now for I think 19-ish years. And the thing that really, above all, that impresses me about NuttX is just how bulletproof the kernel is. This has been it's a kernel that has been battle tested over this number of years, and is really, really just an incredible piece of technical art. So hats off to Greg Nutt on that. The other thing that enables us to use NuttX and build a commercial offering on top of it, of course, is the permissive license, and that was really fantastic. There's only really a few licenses, major licenses out there that are good for commercial use, and NuttX uses one of them. And I want to say, first I want to say thank you, and I also want to say that we really do believe in NuttX, and we strive to be great community members. We've pushed a number of fixes upstream, and we will continue to do that. And it's really nice to be able to interact with the community that way and add new features. We've got a new big feature coming up here, which is dynamic loading, which some of you I'm sure will be interested in. And we're pushing that up, and just really like interacting with the community and the folks here. So we are definitely looking forward to NuttX 10 and rebasing and getting on that. And just again want to say thank you to Alin for having us here, and although everything that you do, you NuttX community. And if you're interested to find out more, you can go to www.wildernesslabs.co and learn about Meadow and learn about what we're up to. And thanks for watching, and enjoy the rest of the NuttX symposium. I'm sure that you'll learn a lot of cool stuff. It looks like a lot of cool tracks. So enjoy your day, and thanks for having me.
Okay, guys, we are back. So, Sara, could you?
Yes, it's just missing 1 minute for us to start Irina presentation. Irina provided a pre-recorded presentation, so I'm going to prepare here to stream it. I will try the same approach of sharing audio to test it, and if it doesn't work, I will place my microphone to the speaker.
If it doesn't work and you want me to stream from here, it's okay. Today I am connected to the Ethernet cable, so it is working fine here this time.
Okay, so just let's give it a try.
Right.
Alan, it's taking too long to download the Irina video, so can you please provide it in the next
I can
presentation?
do it. Yeah, Sara, are you checking the chat, the YouTube chat? There's a question from Flavio Junior. I think he asked. He has the impression he was the number 2 on the table. I don't know. I didn't follow all the discussion, but
okay, I'm gonna check it.
Yeah, maybe they want to double check who really won. I don't know. I will try to play it here. Just a second.
Okay.
By the way, Irina, are you here? Could you please just talk a little bit and on your camera and present yourself before we start your recording?
Yes. First, sorry for the no light situation. There's a power outage here, so I'm hanging on the laptop's battery.
Okay, no problem.
So my name is Irina Presa. I've been interacting with NuttX for a little bit over a year now, since I first joined Fitbit. And before that, I come from a background of mostly Linux development or other OSs like FreeRTOS or AutoSAR based OSs, because I worked on automotive at NXP, and afterwards took a break of about 3 years from embedded and worked in an antivirus company, and then joined the Fitbit and came back to the embedded and operating systems world.
Nice.
So at Fitbit, I've been working at the NuttX-based operating system, and also regarding the presentation I'll do today, at the SPO2 application that we've launched last year that measures the oxygen saturation of a user. And today I'll be talking about how we can protect individuals' memory from corruption from other tasks in order to increase the accuracy of the result.
Oh, very nice. Because you came from Linux, how do you feel comparing Linux and NuttX? Did you see similarities? Did you feel at home when you start to use NuttX?
Yes, that's exactly what I liked about it, because I was very fond of Linux. And as opposed to other operating systems, the one that real-time operating systems that I worked on, the one that were used in automotive, and they are very strict. I like the NuttX flexibility because it's very similar to Linux.
Yeah, very nice. Okay, I will start your presentation here. Just a second. Thank you very much. I hope the energy return to your home, to your city soon. Okay, just a second.
Hello, my name is Irina Presa, and I'm a software engineer working on Fitbit devices that use a NuttX-based OS. Today, I'll talk about how we can harden applications that compute complex health metrics on NuttX devices. Usually, this type of processing might need to control its deployment in certain geographical areas, as well as memory protection for the running algorithm. As an example, we'll take a look at the Fitbit SpO2 application that measures the user's oxygen saturation. But first, let's understand how the SpO2 application works. Basically, it is an application that runs on the Fitbit devices and is designed to read accelerometer and PPG optical sensor data and use them to estimate the user's blood oxygen saturation, also called SpO2. While the PPG sensor data helps estimating the oxygen saturation, the accelerometer is used to determine the level of movement, since motion can induce errors into the PPG accuracy, and we want to ignore potential bad values. This data is collected and processed while the user is considered to be asleep. Basically, we also have less movement during sleep, and the result is uploaded to a backend service for storage. After a sleep session, a summary of the data consisting of an overnight SpO2 average is displayed on the user's device, and it can also be found in the mobile app SpO2 historical graph. As we can also see in the images on the right, here is the overnight SpO2 average on the user's tracker and the historical graph on the mobile application. So, to introduce what we'll be talking today, we'll start with some basic SpO2 application requirements. Because usually this type of application that calculate and display a complex health metric needs to comply with certain requirements in order to increase the accuracy of the result, like running the actual SpO2 computation isolated and protected from other tasks. In the SpO2 task management part, we'll take a closer look at how this application is executed and integrated in the NuttX OS. While in the second part, we'll talk more about how we protect the task's processing data, and in the end, finalize with some conclusions. So let's check some of the recommended requirements for this type of applications. First, the SpO2 computation needs to be separated from the other code. So, in order to do this, we deploy the application as an independent binary that is not part of the main NuttX image and execute it as a separate NuttX task. Also, other tasks shouldn't be able to corrupt the processing data. To achieve this, we protect the regions from some of the task's memory by using hardware memory protection unit segments, also called MPU, like the ones provided by the ARM architecture. Basically, we aim to protect those memory regions that contain processing data, like stack or data regions. Another thing is that the application should be controlled remotely so it can be removed on request or based on different geolocations or countries. This is needed since some countries might have specific regulations for displaying this type of data. The code separation also makes it easier to turn the application on or off. Also, this feature is also useful because if a user doesn't want SPO2, he can opt out and remove it from his device. Now that we've seen the requirements, let's take a closer look at how we apply them for the SPO2 task management within the NuttX OS. SPO2 is executed as an external background task. We usually deploy these external tasks as ELF position-independent code binaries in order to be able to execute them from anywhere. For instance, even from executing place storage or any other memory regions. The ELF pick is basically an extension of the NuttX ELF binary support. So the SPO2's execution is controlled by initd, a run level and task manager. This usually handles run level changes and tasks that need to run on each run level, both external, that start from external binaries such as SPO2, and built-in ones that are part of the NuttX main image. As we'll see in the next slide, external tasks can be executed only if they are already installed on the device. initd is also responsible to unload the external binaries when they stop. In NuttX, binaries were usually scheduled to auto-unload in the seekchild handler, which is executed when the task exits. But since we want to control the task with the task manager, we added a new mode so that they can also be synchronously unloaded by their own task manager in order to have more control over the task state. As for the communication part, in order to get inputs and transmit results, the task can share data with the OS or other tasks using various IPC OS features such as events, key value store, and so on. This diagram describes how the task is installed, executed, and how it can be uninstalled on request. Basically, the application installation is controlled by the mobile app during the install or update process. You can also find more info about this process in my colleague's Silviu presentation about the firmware updates on Fitbit devices. So, as you can see on the left side of the image, the mobile app sends a start update command via Bluetooth. This command will eventually get to the run level manager that switches to the update run level where the actual installation of the applications occur. After the apps are installed on device, the run level manager will switch back to the base run level where it can start both built-in tasks as well as any external installed tasks such as SPO2. On the other hand, as we can see on the top right side, the removal of external tasks is controlled in a similar manner. An app deletion command comes from the mobile app via Bluetooth. This will eventually send an event to the run level manager that will stop any apps that are marked for deletion. So, we've seen how the task is managed and executed as a task. Now let's continue with the actual memory protection. In the next slides, we'll dive into how we protect the application's processing memory. We'll start with protecting individual memory regions on single-core devices. Afterwards, we'll look into propagating the MPU info in the NuttX structures and how a protected task is executed. And in the end, we'll see how the MPU protection info can be handled during task scheduling. In this image, we can find different memory regions that can be found on operating systems. For instance, different regions for the tasks like stack data and so on, or the actual OS metadata. We've marked with red the protected regions for this example. So, on a single core system, we can protect specific task memory regions, like the ones used to store processing data, such as stack or data regions, by making them read-only while the task is not running and disabling protection while the task is running. How does this work? Basically, let's say a protected task is currently not running, and the running task tries to overwrite its protected regions. This will eventually lead to a reset. Basically, we recover by reset and don't end up with corrupted processing data. On the other hand, we can also have unprotected regions that can be used to share data with the rest of the system. For instance, like the task metadata used by the OS scheduler, or the shared memory used to obtain inputs and return outputs. So, a little bit more information about how does the memory protection unit works on ARM. Basically, we have to configure each of these individual protection regions based on our needs, either disable protection or enable read-only or no access protection. One limitation of this region is that they need power of 2 alignment for both their start address and size, a limitation that could lead to memory waste. For instance, if only 3 kilobytes of data is needed for example, the SPO2 data region, it will end up allocating 4 kilobytes for this region because it needs power to alignment. Using MPU subregions that allow individual configuration of smaller parts in a region could help reduce this limitation. Now, let's see how the MPU information gets propagated from the external binary file to its actual execution. In NuttX, there are 2 data structures that play an important role in an external binary's execution. The first one is binary S, which describes a loaded module, and exists in memory for as long as the binary is loaded. The second one, TCB-S, also known as task control block, describes an actual OS task, and it is used by the OS scheduler. A protected binary will have a custom flag embedded in its executable file. Upon its load, this flag will be propagated to the binary S structure. When the task is activated and ready for execution, the newly created TCB structure will also inherit the MPU info. Furthermore, the TCB will also contain information about each of the task's protected memory regions, like region ID, size, or anything that we might need. Now let's see what actually happens when the protected binary is executed. First, the binary is loaded, and the binary structure is created with the MPU flag set. At this point, the data region is also created based on the existing info in the binary file. Afterwards, the associated TCB structure is created together with the stack region during the exec phase. Now the task is activated and ready to be executed. Both structures are stored in specialized lists as long as the task is alive. And also, the protected regions will have their protection enabled. On the other hand, upon exit, Any protected regions like stack and data will be disabled and freed. And a seek child signal is sent to the parent task. Basically, the parent will be responsible to remove the binary from the global list of loaded modules. There is a special situation here. If exit is called from another task, for instance, if another task calls terminate on a protected task. In this case, we need to disable protection first in order to be able to free the protected regions, as opposed to the situation where the protection is already disabled if the task is currently running and exits by itself. You see that the protection only needs to be enabled when the task is not running, in order to prevent other tasks from writing in those regions. Let's also check what actually happens during context switch. First, any newly created protected task will have their protection enabled, since they are not running yet. Basically, they are in this new state. Also, during context switch, we need to enable protection on the old task's memory and disable it on the new one that will enter the running state in order for it to be able to access his data. There is a special situation if the currently running task is in user context and it needs to do a context switch. In this case, it would be too early to disable the protection here, because its protected regions might still be accessed until the actual switch takes place. So, if this is the case, we need to temporarily save its TCB pointer and only disable the protection when we get in the interrupt context, context requested by the actual context switch syscall. In order to better understand when we need to handle the protection changes, let's take a closer look at what are the possible states, execution states of a task handled by a priority-based scheduler. First, any newly created task is in the new pending state, just before it is activated and ready to be executed. All the tasks in the ready list are waiting for their turn to run. They basically either have lower priority than the running task, or they have the same priority but it's not their turn yet. The running task is the one that actually executes on the CPU right now. There's also the blocked state, where all the tasks that are waiting for an I/O operation to complete, or another specific event or a lock and so on, and become ready when their event actually completes. And also the terminated is the state of the task that just exited and they are about to be destroyed. So, based on these states, let's analyze some common scheduling situations where we need to handle the protection changes that happen during context switch. First, if a new task with a higher priority than the currently running task gets activated, so this state 1 here, it will preempt the running one. So then we need to do a protection change by enabling the protection of the new task, of the old task, and disabling it for the one that gets to run. The same situation will happen if a task with a higher priority than the currently running task is unblocked. It will go through state 4 here and then get to running. Or if the currently running task is blocked. In this case, we'll need to enable its protection and disable it for the next task to run. We also have some special situations where the priority of a ready or running task changes. For instance, like the priority inheritance situation, where a ready task might have a lock that is needed but by a higher priority task. In this case, we'll need to temporarily increase its priority and get it running in order to release that resource. Other examples are when the running task releases the CPU on itself, or if we are in a round-robin scheduling type, if the currently running task's time slice expires and another ready task with the same priority gets to run. For all these states, we can have two situations. We can either already be in an interrupt context, or as if seen in the previous slide, if this context switch request comes when we are in a user space, when the task is in user space, then we have to wait until we get to the actual context switch syscall and to be in interrupt context in order to do the protection changes. So, as for conclusions, we can use MPU regions to protect the specific task data, even if we are in a flat build. External tasks can also be protected. We can use all these features for hardening applications that compute complex health metrics. Thank you. If you have any questions.
Thank you, Irina. I hope the electricity has returned to your home. I think now we can do the next Raffle. Sara, did you put the form link to this event?
Let me see. I think we forgot to place the link for this. So I'm going to place the link for the session now, and you will have up to the moment of the next session to fill it, okay? But before moving on, I would like to clarify a mistake that I made. Let me again share the sheet from our last raffle.
All right. Yeah. Yeah, maybe this is something we can try to improve to the next event. I don't know. Instead of putting the, yeah, it's a little bit difficult because the first line, the first row is used to put the header. So I don't know. Maybe we can have a separate column with the index. What do you think?
I think that this way we're working, but maybe on the next year we can improve. Sorry, guys, we are only 5 people. We're few resources trying to make our best. Let's go. Let me explain here what happened. Here, as you can see, we have the first person on row number 2 and the last person on row number 15. And what I basically did is come to here on the random.org, and I used the number 2 as the minimal number and 15 as the maximum number. So here I'm not following the orders. So if I was following the order, Nelber Souza would be the second person, right? Because we would have Flávio as number 1 and we would have Nelber as number 2, but that's not how we are doing. We are taking here from 2 to 15, and in this case, number 2 was the winner. Okay, but I do expect, Nelber, that you will be the winner on the next raffle. Okay.
Yes.
So,
yes.
I will share the link of the next raffle now on NuttX channel, and you have up to the next session to take part of this next raffle.
Yeah, I suggest, Sara, we just put it there. We let people, for example, 10 minutes because we still have half hour. So people, we decide, for example, we will have 10 minutes to enter the form. I think it's fair because people who watch the presentation is still here. So we just put it there. Irina, Greg Nutt has a question for you in the YouTube chat. He asking if there's something in this oximeter project that you are planning to submit to mainline.
Yes, it was a question about the protection. I'm not sure yet. We didn't discuss this in the team yet.
Sorry, I missed the other one, the other question. The protection. Okay, go ahead. You can talk about the.
Yes, I don't know the answer yet because we should discuss this in the teams. I don't know.
You are talking about the memory protection or about the question about the Greg? Sorry, I didn't.
Yes, the upstreaming of the memory protection changes.
Okay. Yeah, that's fine. And even about the driver, for the sensor driver, maybe it could be a nice contribution, and it will allow people to use oximeter with NuttX, even without having all the advanced feature that Fitbit has internally with advanced algorithm or so on. At least the main driver could give some whole information. I don't know if it's possible. What do you think about it?
Yes, but it has to be discussed. I don't know. I don't take these decisions.
Yes, I completely understand. And now that Fitbit is part of the Google, and I hope the Google help the project. In the past, they used NuttX in the project Ara. It was the modular phone. But I hope they change their mind and start to contributing with our project, because we need more people contributing, and we need more companies come here to help us. Okay, Sara, did you? Okay, you already get it there. Thank you.
Yeah. So let's put a time period for you to be there. What do you think? What do you think we leave the last 5 minutes for the raffle?
We can let people to fill the form, and I think we have only 8 speakers here now, so we don't have many people to talk how they get involved with NuttX and.
By the way, Alan, how do you get involved?
I was afraid of this question.
You were talking about everybody, but you didn't talk about you.
Yeah, you know. You apply the rule, but the rule cannot apply to you. Okay, so let me talk a little bit. Maybe if I start to talk, we have half hour talking about it. And
enjoy the time.
Oh, okay. Okay, Sara, thank you. Well, we have enough time, so I can say all the histories. I hope we don't list it today. Internal joke. You got it right. before starting with NuttX, I started working with embedded Linux, and it was about exactly 20 years ago, 2001. I entered to university. I was just how to say Sopone. I can't remember the name of the, when you are the first year in the university. Sopone. I forgot the name. Maybe you or some participant here can remember. But anyway, and then I started doing scientific initialization. I don't know what if the program name is the same on.
You were participating on a college programming for research and studies.
Yes, it is a program of my university. Many universities here in Brazil have this same program. It's very good to improve your skills and to learn about new technologies. And then I start with working on FPGA, some project related to FPGA. And then my mentor has a friend called Marcelo Barros. Marcelo Barros was in the chat some time ago. I don't know if he stay online. I can see.
He was also one of the winners. The Raffles.
Okay. Yeah. So my mentor, my professor, my teacher, was friend of Marcelo Barros that at the time was an engineer in an industrial company, industrial application company, industrial company developing valves and industrial components. And I talked with my teacher. I was willing not to work with FPGA anymore because I like Linux and I was using Linux in my computer. And I just discovered that was on Linux for microcontroller at that time called Micro C Linux or UC Linux, has how they say it's pronounced UC Linux. And then my mentor, my teacher, told me about Marcelo Barros that was planning to use Linux in their embedded boards. And at that time, they are using some RTOS from Green Hills. I can't remember the name, but I think it was ThreadX. And ThreadX was unpaid RTOS, and now Microsoft bought it, and I think now call it Azure OS or something like that. But then I contact Marcelo Barros, and he invited me to do some trainee in his company, in the company he was working at the time. Some vacation training, when I get the holidays and I get the vacation from the university, I could go there and do some some summer trainee in other countries. And then I did that. I did exactly that. And at the time in 2001, the embedded board was very expensive. We didn't have boards like Arduino or Raspberry Pi we have today. And at that time, the lower cost board that I was able to find in the internet cost $250. So it's more than Raspberry Pi today. So it was very expensive, mainly for me because I was a student and I didn't have too much money to invest on it. And then instead of using on board, I decided to download emulator. At that time, I used an emulator called Armulator. It's an emulator for the ARM microcontroller. And so I got the UC Linux running on this emulator. And when I got it, I got some confidence. And then I told to Marcelo Barros, okay, I am done to go to your company and to try to port UC Linux to your board. And then I did that. I traveled to São Paulo, to Sertãozinho. It's a small city in São Paulo. And I stayed there one month working on this project. And yeah, in the last minute, in the end of the time, I got the UC Linux running on his board. Yeah, yeah, finally. And it was a very special moment because when I did it, Marcelo just, sorry, it's a little emotional to remember.
Yeah. Take your time.
Yeah, but
have a deep breath.
Yeah, basically, he wrote an email to my teacher, to director of the university, and to more 10 other people he know there. And so he congratulated me because at that time I was the first one to have this opportunity to go out and do this program. And then after that, many other people, many other students was able to go to participate of this kind of program. So it was really nice.
So you opened a way, a world of possibility that there wasn't before for the new students.
Yes, yeah. And this also make a friendship that endured for more than 20 years. So I'm still in contact with Marcelo Barros, and we still doing some projects together. And after this project, we wrote some articles to now not existent company, not existent magazine here in Brazil, called Linux Magazine. This Linux Magazine was really nice. There, only the very skilled guys was to write to it, and we create some articles to Linux Magazine, and yeah, and this article was the first one that we wrote. After that, we wrote more 2 articles to other very known magazine here in Brazil called Saber Eletrônica from Newton Sebraga. I think you know this.
I know.
Yeah, this magazine in Newton Sebraga is still alive and still doing great. And yeah, that was how I started with embedded systems, mainly with Linux or UC Linux. But UC Linux has some disadvantage compared to NuttX, because when you use UC Linux, you need to have a microcontroller with more than 2 megabytes of RAM and flash. So it's not for any microcontroller. You cannot buy an STM32 and use UC Linux with it. Yeah, but Anyway, I still working on UC Linux, and I use it in my master degree after I finished the graduation. And because I was involved with UC Linux, I was in contact with people from Freescale, like you did when you are starting developing project and get in contact with Espressif. It was very similar what happened to you, and then the guys from Espressif, sorry, from Freescale, the Fábio Estevam at that time, dropped me an email and told me, "Oh, I see you helping people with Freescale Codefire MCF 5272, 5282, and do you want to do an interview at Freescale to work here with us?" And I say, yes, of course. So at that time, I finished my master degree at the south of Brazil in Porto Alegre, and then Freescale paid me on travel to go to Campinas to do the interview. And so I did. I go to there, did an interview, and it was really nice because Freescale at the time was very big in Campinas. They used to have more than 200 employees there. So after doing this interview, I was approved and I moved to Campinas. And there I started working with Linux in new Freescale chips. They are the IMX 27, IMX 31, 35. And when I was going to work on IMX 51, I got an opportunity to work in another company in Minas Gerais, in my state. So, and I think it's important to say at that time it was 2008, and we have the big crash in the market. So all the companies was firing everybody, and it was a very, very unpleasant moment because in few moments you look around and you don't see anymore the people was at your side all the year. And so I started thinking, I don't want to be the next. Yeah. So I started searching for other companies, and I got opportunity to work on a company in Minas Gerais, in Belo Horizonte. And then I go to there, did the interview, and start working on there. And there I started working on a project that became like a tablet, like an industrial tablet. But the tablet idea didn't exist at the time because it was 2009, and iPad was going to be released.
What was the company?
It was called, I don't want to say, but okay.
Okay.
It was a vehicle tracking company. They are very big, but okay. And then I start to work for them to work in this industrial tablet, and then after 1 year and so on, the iPad was released, and then we changed the name of the project and the idea of the project. So this project became a real tablet. It was to become like a terminal data for the vehicle trackers, for people driving big machines like trackers or trucks or others heavy machines. And then we decide to move for something more like a tablet. And then Google released the Android as well to be used on tablets. And then we decide to drop the Linux port that we did to create a new project with Android. So we also changed the microcontroller. We decide to use now the IMX51 that I didn't have the experience because I left the Freescale at the time when I was going to work on IMX51. But anyway, Freescale did the Android port to IMX51, and then we decided to work on this port to our board. And it was really challenging because this tablet has many interfaces that any other tablet was supposed to do. For example, our tablet used to have Ethernet, CAN bus, serial output, HDMI output, TV and FM radios, so you can watch TV and listen to the radio in the tablet, and many other things like 3G modem or 2D modem, 2G modem, and SD card, and so many interfaces, and even I cannot remember all the interface because there are so many. Even GPIO output, you could just turn on or off a relay, or a lamp or something similar. Also, one wire interface, and all those interface was not didn't exist for Android at the time. So many of this work we did we did it by ourselves, and so it was a really big project, and it was very challenging. But now I can go back and reply your original question, how I discovered NuttX. Well,
and we also have the other question for you in the chat.
Okay, do you prefer I still talking about NuttX, or do you think it's better to respond the question? I didn't see the question yet.
No, please go with your NuttX history, and then we move to the chat.
Okay, so in 2010, Marcelo Barros again just give me a link to article in the Linux Journal. This article in the Linux Journal was very short, but basically they announced about, there is one RTOS that is very similar to Linux with many features that only Linux has, and it runs on microcontroller. So I thought, no, it's another micro C Linux, and I cannot use it probably. And then I start to look at this project, and it surprised me because I could use it in the STM32, in the LPC 17, in many others microcontrollers. So, this is exactly what the micro C Linux or UC Linux was supposed to be. NuttX is the real Linux for the microcontroller. So it was a pleasure for me to discover this project. And then I talked with the CEO of this vehicle tracker company I was working about the NuttX, and he didn't like the idea to use NuttX because he told me at the time, I can trust in RTOS. There is only one guy working on it, because at the time was mostly only Greg Nutt. So he dropped my idea completely. So I was a little bit frustrated because I wanted to see NuttX using at that company at that time. But okay, they didn't use it, but I used it. I started using NuttX. And then I get in contact.
Which year was that? Are we which year?
Yeah, it was end of 2010 when I discovered NuttX.
Okay,
when
still 2010.
2010. So just for reference, NuttX was released in 2007. So it was only 3 years that NuttX will exist. But at the time, Gregor Nutt was not announced. It's not create some announcement about NuttX. Like he never did all the time. He focused on working on the NuttX instead of making publicity about it. And NuttX became popular because its owner users that start to use it and talk about it. So, but I started talking with Greg, and Greg was very helpful to me. He gave me so many suggestions and improvements to do when I was starting. So it was really nice to have Greg around at that time. And but the company was not interested to use NuttX at that time. I think if the time was now, if 10 years ago NuttX was in the Apache Foundation like we are today, maybe they could have used NuttX, and maybe the history could be different. Maybe even other RTOS could never exist, because we could have make all the market to it. But it's history, and we are in the present, and we need to do it now again. So yes, then in 3 years later, in 2013, in 2013, I was fired from this company, and I decided to work by myself, working as consultant. And then I started to use NuttX in many projects. The first project I created was for a small company in Brazil. They are create some, it's a startup. They are create some dog feeder, and I work on this dog feeder. I use NuttX to control the motors, to display the information in the 7 segment displays. It was a really nice project. And after that, I did other projects like a vehicle tracker device. Many of the experience I had before, I used it to create it. So I did all things in the NuttX, but way better than that company used to have, because I created totally modular. So each function is a thread. So each thread use some message queue to send data to the main thread. So it was very flexible, and you can plug and remove like a module on the fly in hot plug way. Yeah.
Great. Alan, I think that we may continue this history on the next session, because we are almost at the time of the next presentation. So I'm going to...
What was the question anyway?
The question, let's move to the question from the chat. Carlos asked if you have some experience with QNX.
Only as user. I used QNX in the past, but only just for reference, I think it's around 2001 when I was starting with UC Linux. QNX released a flop disk image. You put this flop disk in your computer, and it starts your computer with the graphic interface. And you can use even the Ethernet or modem, if I'm not wrong, and you can you can like I don't think you can browse the internet, but you can at least open something like internet. Yeah, it was QNX was really nice, but I don't like QNX because it's not open source anymore. They are trying to open the source code, but when BlackBerry bought the QNX, they withdraw. They not open. It's still open sourcing the things they are doing.
Okay. So now we can do the raffle for this session, for the Irina session, and I also would like to announce that we have talked here in our workshop organizer chat, and we decided to provide Nelson Souza with a prize.
Sara, just a second. We didn't take a print screen from our screen. I will ask the other ones here to turn on the camera so we can hit print screen, and you put this screen on the LinkedIn and other place later. So I don't know if Masayuki is still here because it's too late for him, but if Masayuki is still here, please turn on the camera. Irina, Jari, hello. Oh, you stay 3 in the morning. You stay here, guy. You are
Masayuki is our fair attendee.
Philip, are you here? And Silviu? Irina? Okay. The electricity returned to Irina's homes. Philip, are you around? Okay, let the PC be in our conference. Okay, we need a PC anyway, right? Yeah, although many are using cell phone. Now you got the joke.
I got the joke some minutes ago.
Okay. Okay, guys.
Okay.
Let's do the print and move on. Do you want me to share the presentation, or you can do it?
Let me do the raffle before, okay?
Okay.
So here we have. I'm gonna exclude Norbert Souza because we decided that he will already receive his prize.
Okay, congratulations, Norbert. You deserve it.
That's too frustrating when we think that we received something and we didn't.
Yeah, let's be fair, and I think it was a mistake from our side, so we need to repair it. I like this idea.
Yes, me too. Okay, I can't find where I do this, but no problem. If we have his again, we just raffle again. So we have number 2 up to number 10. First winner is Jan Wattenabel. Next is McKay Ransom.
McKay, I think. No, I was confused. I thought he already won, but it's not him. Yeah.
And the next winner is Adriano Henrique Rezende. Congratulations to the winners. Alan, can you please?
Sara, I suggest you to do another one. Adriano Henrique Rezende already won.
Already won? Okay.
Yeah. Let's give chance for other people.
Number 6, José Inácio Serafini.
Let's see. José Inácio. No, he deserved it. Okay, José Inácio, congratulations.
Okay, let me stop sharing. I will try to stream the next presentation here using the share and audio.
Sara, let's ask, maybe Jari want to do it live, I don't know.
Yes, of course. Jari?
Hi. Yeah, we pre-recorded the presentation. Cis is not available today, and most of the presentation was done by him. So please stream the video, and afterwards I'll be available for questions.
Okay.
Thank you.
Thank you. And Jari, sorry about the about missing your email, right?
Oh no, that's fine.
Yeah, it was really my fault. And at the end of the day, I decided not to put the two speakers in the badge in the material. Only the first speaker. So I hope you understand it, and sorry to this inconvenience.
Oh, that's fine. I understand.
Okay, thank you.
Alan, it's really not working here, the audio sharing functionality. I think we can give up of this option. And so could you please share your screen?
Yeah, just a second. I need to find it here because I was... Just a second. I closed the file explorer and I need to navigate all the folders again. Okay, all the directories. Presentations, finally, and battery. Sara, I not find this presentation here in my local files. If you have it, if you want to stream it, please. Let's try again.
Okay.
Yeah, there.
Can you see my screen shared?
Not yet. Okay, now it's okay.
Okay. Can you hear it?
No.
Unfortunately, no.
Yeah, try to restart.
Can you hear?
It's very faded. It's almost impossible to understand.
Yeah, let me download it here. Yeah.
My speaker volume is too low.
Yeah. Just a second. I try to download it and start from here. Download. Sara, just a little bit, right? Because it is downloaded here. And yeah, so while it is downloading, I can say I can finish the talk. Yes, basically that was it. After I started to use NuttX on personal projects, I decided to create the NuttX channel to let more people to discover about NuttX, and also to learn more, because when you teach someone something, you end up learning more than you are explaining. So it was a good experience. Okay, it's downloaded. Just a second. Let's share it.
Welcome everyone at this presentation. My name is Cis van Mierlo. I'm working at NXP Semiconductors in Eindhoven, the Netherlands, as a System and Applications Engineer. I do that in the CTO Automotive System Innovations Department. And currently, I'm working in a mobile robotics team, together with my colleague over here.
Hi, I'm Jari van Ewijk. I'm a part-time working student, also at NXP in Eindhoven. We're both part of the same small mobile robotics team, and we work together with colleagues from all over the world to enable NXP technology for autonomous drones, rovers, and any other robotic vehicle. We specifically create reference design and development platforms, and some of the systems that we have developed include vehicle management units, CAN nodes, a compact 100-base T1 Ethernet switch, as well as a battery management system, which is the topic of today. Many of the systems that we create also run NuttX because it provides a very nice platform on which we can develop applications that can be reused on different hardware. Last year, Cis and I also presented this battery management system. Then we discussed the hardware and the basic software that mainly Cis developed, as well as the principles behind battery management. The link to last year's presentation is available in the presentation slides, as well as you can scan the QR code on the right. So let's get started with this year's presentation.
Yes.
Let's first have a look at what we are going to discuss today. Cis will start by quickly recapping the basics of battery management. After that, we will start discussing the new features that we implemented on the battery management system over the last year. Cis will first discuss the microcontroller power management. He will also explain why our system has an external watchdog as part of the system basis chip and how that is implemented in NuttX. I will then take over and discuss the I2C slave driver that we created for the S32K1. That's the main microcontroller on the board. And I will also quickly explain some extensions that had to be made to the SPI driver to support larger frame sizes. Cis will then take over again and discuss the NFC features that he has been enabling, and he will conclude the presentation.
Let me first explain some basic battery management things. Why is a battery management system, also known as a BMS, needed? In this big red picture in the middle, we can see the operating window for a lithium-ion cell, with temperature on the y-axis and cell voltage on the x-axis. As you can see, there's only a small operating range in which your battery cell is safe to use. That is the small green square in the middle. The other part is where the cell is not safe. It could catch fire or even explode, and that is what you want to avoid. To keep an eye on this, there's a BMS needed, which can monitor all kinds of things. For example, it can monitor cell and battery voltages, the current that flows through the battery temperature. Some BMSs have ways to keep track of the state of charge. That means that how many charge is left in your battery. Some BMSs have a way to keep track of the state of health. The state of health is the capacity the battery can still hold compared to the factory capacity. And this degrades with time or usage. Some BMSs can even disconnect the power when a dangerous situation occurs, for example with an overcurrent. And some BMSs have a way to communicate to a host, which in our case is the flight management unit. At NXP, we have the RD drone BMS 772, which is the BMS for mobile robotics, like drones and rovers. It has the S32K144, an automotive-grade 80 or 112 MHz microcontroller with an ARM Cortex M4F core. Many of its features have already been enabled in NuttX. It has the MC33772 lithium-ion battery cell controller IDC, designed for automotive applications. This chip has a Coulomb counter, and it does the voltage and temperature measuring and monitoring. Then it has an SBC, which stands for System Basic Chip. And this is a voltage regulator and a CAN transceiver in one chip. In our case, the UGA 1169. To have an NFC interface, there is an NTAC5 chip on this BMS. And with the A1007, the user could do some authentication. But what can it do? This BMS is meant for 3 to 6 cell LiPo batteries. It can monitor voltages, temperatures, the current that is flowing. It has a Coulomb counter to keep track of the state of charge and the state of health. It has a power switch that can handle up to 60 amps continuous DC current, and this will disconnect the power with an over or under voltage, an over or under temperature, or an over current. It can balance the cells and communicate important battery information via the nutshell, via UVCon, which is a protocol on top of CAN, via the smart battery bus, which uses the I2C slave bus, via NFC, or indicates things with the LED. BMS has open source software, which runs NuttX. It uses a lot of tasks to implement the whole BMS functionality. We soon have release 4.0, which includes a lot of new features. For all the new features in the upcoming 4.0 release, the most important changes or additions will be discussed during the next couple slides, starting with the MCU power management. In NuttX, you have a power management driver. We can see a picture of it on the screen. This power
Hey guys, it seems we have an issue with Alan's internet connection. Maju, could you try to share the video from your computer?
I will search for the video here. 1 minute.
Okay.
Unfortunately, I don't have this presentation.
Do you have access to our folder in the Google Drive, right?
Yes.
So go there and access day 1. Then you go to the number 8 presentation.
Alan is back. I can try to share here if Alan is not available.
Yes. I was sorry, guys. I was updating the website, and because I opened the program to open the image to edit the image, the Google Chrome fight with the other program to see who will eat more memory, and they crash the JITS application in the browser. So we need to see where it stopped, and I will start to playing from there.
Okay, do you have the video open to see where it stopped?
Yes, but first we need to, could you please look in the YouTube and see what was the page number? Currently is in the page 9. Here for me it stopped in the page 9, but if there
I
is,
think it stopped at page 7, about 7 minutes into the presentation.
7 minutes?
Yeah.
Wow. Sorry. Yeah, because it's still playing here for me. I was listening and didn't notice it's crashed because nobody warned me it was crashed. So yeah. Okay. I will reshare again. Just a second. Is the YouTube Live working? Let's see. Yeah, I think it's working.
Yes, it's working.
Yeah, I will just share here. Just a second. By the way, Sara, I will send the modified image, and then you upload it because I will not mess too much here. Otherwise, it can crash again. So,
Okay.
just a second.
The last slide that I saw in the presentation was number 5. No. It was number 7.
7. Yeah, I returned for 7 at position 7 minutes. Okay, just to confirm. Yeah, is in slide 7. In position is let's do better. I will move to 6. Yeah, when he starts to talk about power management, so it will be better to edit.
Yes, I agree. I agree.
Yeah.
And changes or additions will be discussed during the next couple slides, starting with the MCU power management. In NuttX, you have a power management driver. We can see a picture of it on the screen. This power management uses governors. So each peripheral needs to register for the power management. When something happens with the peripheral, like some I2C communication, it triggers an activity, so the governor knows it should not be idle or set that peripheral in a low power state. So your governor decides when it should put things in a low power or idle state. This is not what we wanted. We know in the application in which state it should turn off certain peripherals or put the microcontroller in a low power state. So we want the application to be able to control the power management. But that was not yet implemented. There was a board CTL to access some functionalities of the power management, like query state to get a power mode, but it was missing the change state function, which we need to control it from the application. So we added that function and the check state function to the NuttX master repository, and now our application can be in control of the power management. And it's made in such a way that in your menu config, using a PM configuration in the board selection, you can set for each NuttX power state in which power state the MCU should be in and which peripherals need to be enabled, like the SPI buses or which works. For the external watchdog, I will start with explaining what a watchdog is. As illustrated in the top image, if your microcontroller freezes or is stuck somewhere, your watchdog will notice that, and it will make sure that your microcontroller is reset. So your microcontroller will restart and it will be up and running again. To keep track of a microcontroller that froze, the watchdog keeps track of time, or ticks. And the idea is that the watchdog gets a trigger, or in other words, it will be kicked. And then the timer is reset. If the watchdog timer reaches a certain timeout, it knows that it couldn't be triggered in time, and thus the microcontroller froze. Then it will issue a reset. As illustrated in the bottom picture, on the BMS, we implemented the watchdog in an external component, in the system basic chip. This will reset the microcontroller by pulling down the not reset pin of the microcontroller. To kick this watchdog, the microcontroller needs to send a command over SPI. Because the watchdog is a vital component which you do not want to fail, you want to test the not reset line if there is a connection. This is done to first configure the pin as an input pull down during startup. The SBC should pull the pin up, so the pin should be high when there is a connection. This is then read and saved, and then the pin is configured as a not reset pin again. A progress is used to get the outcome of that pin read from the kernel space in the application space. This way, the application knows if there's a good connection between the two components, and the microcontroller can be reset via the watchdog. One of the other self-tests is a check if the power can be cut off, so it will disconnect the power. But what if you are flying and the watchdog reset comes in? You don't want your drone to fall out of the sky because of a watchdog reset. That is why it is important to know the reset cause. The microcontroller has a reset cause register, which is read and saved in kernel space, and this is then put in a progress. So the application can decide to do the self-test or to keep on flying safely based on the reset cause.
I will now take over for just a couple of slides. I will first discuss the I2C slave that we implemented for the S32K1 microcontroller family, and how we use this driver to provide smart battery data over SMBus. NuttX has a generic I2C interface, which is defined for both a bus master as well as for a slave device. Each each architecture that is supported by NuttX then needs to implement this interface, provide a connection between the interface and the actual hardware peripheral. However, looking at the NuttX source code, it seems that there is not yet any micro slave interface in any way. So I now created maybe the first basic I2C slave driver, and specifically for the low power I2C IP block that is found on many NXP microcontrollers, which also includes the S32K1 that we use on this BMS board. This I2C slave driver will first be made available as part of the 4.0 release of the BMS software for our RD Drone BMS 772 board, which this is currently working on. After that has been released, we plan to upstream the implementation to Apache NuttX soon after that as well. It was actually quite easy to implement the I2C slave interface for the low power I2C IP. This IP block has the master and slave logic mostly separated. This can be seen in the block diagram on the right. On the S32K1, for both the master and the slave part of the peripheral, they both have their own set of registers, interrupts, and can even be assigned to their own pins. So that also means that the master and slave could even be on separate buses and operate there at the same time. The interface that is now available is quite nice and simple. Buffers can be assigned to all the data that is to be received and transmitted. You can register a callback function that's called whenever there's an interrupt on the I2C slave, and that will, for instance, happen when new data is received on the bus, and then allows the higher level driver or application that registers this function to read or change the contents of the read and write buffers when an interrupt comes in. So on top of this interface that we implemented, we created a higher level smart battery data wrapper that allows the battery management application that Cis is creating to provide recent battery data, and that may then be requested over I2C, or in this case specifically SMBus, as it is specified by the smart battery system specification. So the data that can be requested includes voltages, currents, even the temperature, and the state of charge of the whole battery. So that's basically all the information that is available in the battery management system. So this also will be released as part of the BMS software 4.0. So that will hopefully happen very soon. Besides the additions to the I2C driver for the S32K1 microcontroller family, our team also made improvements to the SPI driver. The low power SPI IP on the S32K1 allows SPI transfers with large frame sizes, but on the NuttX only up to 16-bit frames were supported. However, the battery cell controller chip uses 40-bit frames, so this requires some changes to be made to allow the S32K1 microcontroller running NuttX to communicate with the battery cell controller over SPI. Our colleagues Han Rijmakers and Pedro van Ewijk made these changes, which allows SPI transfers with frames up to 64 bits. Theoretically, this could even be extended to 4096 bits. Their work has already been upstreamed to Apache NuttX, and the link to the pull request is available on the slides. The 64-bit transfer can be enabled with a configuration option. Have a look at the pull request for more information, or refer to the currently available release of the BMS application that Cis made. Change is currently only implemented for S32K1, but should be easy to port the change to other NXP microcontrollers as well. The S32K1 microcontroller family has been the main focus of our team for the past 2 years. We've improved NuttX support for this part and created many applications with this microcontroller running NuttX. We're now starting to shift focus to some of our other microcontroller families as well, which also includes the S32K3, which is the successor of the S32K1. With that being said, I would like to give the word again to Cis, who still has some new features to discuss.
For NFC, BMS has the NTAG 5 on board, with which you can have NFC communication. The NTAG 5 has other features as well, like energy harvesting, meaning that you could power your circuitry with the field power of NFC. The chip family has other features as well, like GPIOs, PWM, I2C communication, It can have SRAM for faster communication between the NTAG and your NFC device. There are 3 variants of the NTAG 5, which are the switch, which can be seen in the top left picture. This is a PWM GPIO bridge for lighting and gaming. The link, which is similar to the top right picture, but with a larger antenna and no supply voltage needed. This is an I2C bridge for IoT. So you can have a transparent I2C masked channel between an IC and the NFC device. And the boost. This is the one in the top right picture. This variant is on the BMS and it is designed for a small antenna design. And with a small antenna design, you cannot get as much energy out of the NFC field, so you need a supply voltage for this chip. You can see in the middle picture the small 10 by 10 millimeter antenna design, which is on the BMS. This NTAG has 2 different registers, which need to be accessed over I2C, but in a different way. That is why we added this I2C wrapper for the NTAG. And for the BMS, we made example code, which is very easy to use or adjust. In this case, we added the text NDEF bracket. NDEF brackets are the NFC standard, so this could easily be read out with a mobile phone, without the use of an application. If you read it out, it would just pop up. We use it to update the battery information, so this can be read easily with a mobile phone. You see a mobile screenshot in the bottom right picture with the battery information. In the future, we would like to add this NTAG 5 to the contactless driver, including the I2C wrapper. NuttX provides a very capable and flexible foundation for our BMS reference software. NuttX has helped us to quickly develop a modular and future-rich application. We are working towards releasing BMS software release 4.0. There's all these features implemented. We have a couple links for the BMS information, like the NXP website, the kit book with information, or the code repository on GitHub. And you can also scan the QR code to go to the NXP Arbitron BMS 772 website. For future work, we are working on upstreaming all our work to the NuttX master repository. We want to add a display, but implement it in a way that uses less RAM. We would like to add an authentication example with the secure element for a secure battery. We want to improve or standardize communication with the vehicle or flight management unit over CAN. This was our presentation. Are there any questions?
Okay, guys. Can you hear me?
Yes, Alan.
Oh, great. Sorry for the inconvenience to messing with the presentation, because JIX is a little bit sensitive. So during the presentation, when I opened the GIMP to edit the image, and the Google Chrome application crashed, and then when I click to see the presentation in maximized screen here, it also stopped to show the image. So it's a little bit delicate. It's not much resilient as some video streamers, but okay, we have it, and we need to fix and to work with it. Just a question. We have some people here asking, can the BMS be applied on lithium-ion battery type?
Yes, I see the question coming in. Thank you. Yeah, the BMS that we have made is fully configurable. It's a reference design with software that you can change in any way you want. But even in the current state, there are options available through the command line to change the current parameters, so you can make it work for almost any battery type available, especially for any lithium variants. So that yeah, that works.
Oh, that is great. I think that's only one question right there, right? Let's see. Yeah. Okay, I have a question to you, Jared. You comment during the presentation about the I2C slave driver, right?
Exactly.
Do you have plan to mainstream it?
Yep. We're in a bit of a difficult situation when it comes to upstreaming stuff that needs to go through the whole company for legal reasons. So that usually takes a while, but it's always the plan to upstream it. And in this case, we will soon be releasing the software for the BMS, the 4.0 release. And when that is done, it will actually already be available because that will also be open source. And when that is available, we will also try to upstream the features that are included to mainline NuttX as well.
Oh, that is great, because currently we don't have I2C slave support for some platform. We have, if I'm not wrong, we have SPI slave for our chip for ESP32, but I2C slave we don't have.
Yeah, as far as I could see, there is currently no implementation whatsoever for any chip. So that's also what I said during the presentation. This may be the first ever implementation, and I'm sure there will be improvements later. But yeah, I hope it will be useful at least to get started, and perhaps also to get other chips supported. That would be nice.
Yeah, for sure. I think this idea to have the this I2C slave integrated on mainline will open doors for new implementations. And I think even for us in Espressif, it will be useful because we can use it as a reference to create our I2C driver as well. Yeah, for sure that's a great contribution. And so I think this is the second time you participate here, right? Is this your second? Last year you also presented.
Yeah, last year we also presented the same BMS, at least the current state of the board back then. And in fact, even the first year that the workshop was organized in Gouda in the Netherlands, I was already there together with my colleague Ian Galloway to present the hover games back then.
Yeah, I am missing here. He participating today. I try to drop him some email, and if you also can ping him and
I think he is on vacation currently.
Yeah, I think I'll receive some auto reply, and maybe you could help me because we are waiting some help from NXP in some details. I will talk with you. Maybe you can help on it.
Yeah, sure. Yeah, sure. You can send me an email, or yeah, we can work it out. That's okay.
Yeah, and yeah, because it's very nice to have NXP here the second time, and I am very glad because all the companies that was here last year are here again. So we are still strong. It's very nice to see you guys here, and I hope you try to bring more people to participate, more projects to work on NuttX.
Yeah, there will be another presentation tomorrow where we present our work on porting NuttX to the new S32K3. So there's more to come.
Yeah, that's a nice thing to see, the new microcontroller supported from NXP, and it's also a surprise for me because the first NuttX port I worked on was in the NXP Kinetics, the KL 2025, if I'm not wrong, 25L 128, something like that. I can't remember all the details, but yeah, that was the first one I worked on. And yeah, me and Greg guide me all the way to get it working, and yeah, finally we get it. And I think the NXP has nice microcontrollers with many peripherals and many things, and we need to have more better support on mainline, because currently the STM32 has many more peripherals and more features supported. So yeah, we need to get the NXP at the same level, otherwise people will not have other option to use. So yeah. And
yeah, I can add to that the current team within NXP that is working on NuttX is quite small. So we're with 4 or 5 people that at some point have contributed. And if you start looking at how many hours we're actually spending on it, it's probably not even one full-time equivalent. So the work we are doing is not that much. We're slowly trying to at least improve some support. And the S32K1, which we're also using on the BMS, has been the main focus for like the last 2 years. And we're hoping to expand that soon. But also, again, we're a small team, so we're also relying on many people within the community to enable all these NXP chips, because there are many in there. I was always surprised that there's so much support for NXP chips, even though our company is not that actively involved. So that's always nice to see, and we have to thank the community for that.
Yes, that is true. At least for the IMX family, the support is very good, and also for the LPC 17, LPC 43, they are very well supported. But yes, I think NXP have many more nice microcontrollers that need support, and yeah, and it should be very nice to have a better support. And I hope NXP follow the Espressif idea and hire you guys only. These guys are focused to work on NuttX, and we want to see their work integrated on mainline. So as you can see, Espressif is doing a great. I am busy to say it, biased to say it, because I work for Espressif, but I admire the work Espressif is doing this way, and I hope the NXP and others start to follow. As I said in the beginning of this meeting of the event, for example, Linux became what Linux is today because the community, but because also because the companies start to embrace it, start to use, and start to put people to work full time on it, and we need it to NuttX as well. Yeah, it's important to have companies working together on this purpose. So I don't know. Maybe you guys can talk more with Yain and others in the company to to try to improve it. And I don't know if I think you are not here when I said it, but I was talking about this Sega J-Link, the NXP paid to get the NuttX support on it, and I talked with the Sega guy, and they agreed to release the source code, and so our community finally will have it. And yeah, and also we have an alternative that another colleague from our community Dave Marples create a real-time programmer as a tool to do that. So at least now we have options. If you want to buy the J-Link with NuttX support, okay, you can use the system view and so on. But if you don't want to use, want to open source and other low-cost solution, we can use this alternative. Yeah. Okay. Very nice presentation. I am really impressed by the work you guys are doing in the NXP, and I hope to see more. And I hope you guys also keep more in touch with us. I think last year was really great because we saw the socket can integrated on mainline. And it was really good. Hard work to get it working. Many interactions, but they succeed. So yeah, I think I don't remember. I think it was Peter, right?
Yeah, Peter did that indeed. Yeah. So I hope we will also be able to keep extending that and keep working on these nice features. So I'm sure we'll come back next year again with some other nice presentations and perhaps some nice new features.
Oh, that is good. And I don't know if you saw in the mailing list. It was, I don't know, I think this week or by the end of last week they post about it. There are some people interested to use the SL link, the link interface with NuttX. Yeah.
Yeah, I think I need to look it up. I haven't seen that yet.
Yeah, it should be nice because I think many NXP has the link interface, right?
Yeah, I think there's many boards that support it indeed. We don't use it a lot because we're mostly focusing on the mobile robotics ecosystem, and Lin is not really used in that. But yeah, most of the boards we have indeed support it. Most of the microcontrollers. Yeah.
Yeah, no, that's nice. Okay, thank you very much, Jerry.
Thank you for having us.
Okay, thank you. Sara, do you want to do the draw?
I will make the draw. Sara is not available.
Oh, sorry, Maju. I didn't.
No, it's okay. It's okay. I will.
I cannot see your camera.
1 minute.
Mm-hmm.
I'm here.
Yes.
So I will not accept more answers.
Mm-hmm.
And now I will share my screen.
Okay, now we
This
can
is
see.
our spreadsheet.
Mm-hmm.
Now we can random.org. I already put 2 and 7.
Mm-hmm.
2 and 7. Let's see. 4. José Martins de Castro. Congratulations, José. Next
Okay,
one.
let's see. Okay, José Martins is not.
4 again.
He's very
Yeah, let's try again. 6. Okay, 6. Felipe Erazo. Congratulations, Felipe.
I think Felipe was
Felipe,
already he was already contemplated.
Could you check?
Mm-hmm.
Yes.
Felipe, yeah, I just checked Felipe.
Oh, okay. So number 2 again. 3. Let's see. 3. Ken Petit. Congratulations.
Congratulations, Ken. Very nice.
The last one. 5. 5. Oh. Maria Júlia.
You.
Yeah, it's me.
Congratulations.
Congratulations, Maju. Guys, just to explain, this year we allow some people from some hosts to participate, but I myself am not participating. Okay, but yes, people can participate for the draw. No problem. And congratulations, Maju. You deserve.
Thank you. It's random, so.
Yes.
and also, Maju is a computer engineering student. A student needs to have boards because they are expensive.
Yeah.
Next year, it's me presentation here with my new board.
I think we have people listening it. Let's say how many people are listening now. At least 33.
Oh my god.
We will ask you.
Now I have a problem.
Yeah, or a solution. You.
Yeah, for sure.
And congratulations, Ken. Just people know, Ken Petit was the author of the smart file system, Smart FS, used on NuttX. It is very nice to have Ken Petit here. Congratulations, Ken. And so we still have 4 minutes. Maju, you can. It's with you now. You and.
Me and Sara.
Yeah, it's up to you. How do you get started with NuttX?
I am just a beginner. I don't know much things about NuttX, so I'm here just listening and learning with you guys.
Okay. What board are you using with NuttX?
Actually, I just use it ESP32. Like all the time, for not just for NuttX. It's my board for all.
Nice. And are you in the NuttX Brazil in our YouTube channel? Did you watch some videos there?
Yes. You and Sara are doing great work.
No, very nice. Thank you. I did display. Maybe tomorrow I will try to use it. Did you saw the video where I show how to?
Not this one, but for
there is
sure
a video
I will
in the
see
channel.
in the future.
Yeah. That's nice.
By the way, Alan sent me many displays to give to you. I forgot to tell you this.
Yeah, that's true. Now you need to build a display by yourself.
Okay.
Use NuttX.
I will accept the challenge.
And it's very nice because it supports 8 displays, 8 modules, and then you can write phrase with up to 32 characters. So we have many.
Really cool.
Yeah, we have many.
As we say in Portuguese, Alan is giving me mimos. It's like gifts in Portuguese.
Yeah, give small gifts. And
Yes,
now,
Alan is encouraging you to develop with NuttX.
yeah, maybe next year she already has some project to present here. She can use the board with this display, for example, to show information on something from the internet. You can, for example, get some some data from.
I can say something to the beginners.
Okay, go ahead.
Not now in my in my presentation. I can say like how it began and stuff like that. I think.
Okay. Maju, just ask people to turn on the camera again. I don't know if Philip is here this time. By the way, we still need the PC, and so we have the Takayoshi Koyuzumi here as well. Takayoshi, could you please turn on your camera? Great. Roberto, can you please turn on the camera as well? I don't know if Masayuki is still online. Oh no! Crazy!
Wow, he's still here.
4 a.m. in Japan, is the guy still there?
I think that on the next year we should have a special prize for the one who keeps here in the following events, because I remember that on last year Masayuki was also with us.
Me too.
And it happened during all day long here in Brazil, which means that he already spent 2 nights woke up. With NuttX. 2, not 4, because the event is 2 day long.
And Silvio, are you also here? Could you please turn on your camera if you're in the chat? Yeah. Well, I don't have joke to do with the SG. I don't know. So only the PC we need. Okay, but so yeah. Okay, I already took the print screen.
We have a question. Is the S32 fully supported by NuttX Wi-Fi cameras, LoRa?
Good question.
Carlos, you may watch to our previous presentation we had in the very beginning of today's event. It was presented by Ricardo, which is the Espressif manager of third-party platforms team, and he presented the current status of ESP32 support on NuttX. But we can also talk a little more about this since you asked also about cameras and LoRa.
Yeah, good point, Sara. We have many features from supported on ESP32, including Wi-Fi and the basic drivers. But the I2S used by the camera is not supported yet, but it is in our list. So soon we will have the camera support as well. But yes, we can use all the other features, and it's very well supported. And also we have some companies using it in products that I cannot say the name, but they are here in our event as well. And so I suggest you to try the ESP32 with NuttX, and you'll be surprised because it worked very well in the ESP32. It's very well supported and many features. I think Masayuki will show it running in SMP mode, right, Masayuki, tomorrow?
Yes. I will show you a demo video with Spresense as well as ESP. So both are running in SMP mode with Wi-Fi. Yeah.
Yeah, very nice. It's a great demo. Great. Yeah, you guys need to see it. Okay, Maju, go ahead. You can introduce the next special participant, speaker, I mean.
Wait, I am open my whole stuff because I close it.
Alan, do you already have my presentation downloaded, right?
Yeah.
So if Maju has some problem, we move to you.
Okay, I can start it here, Sara. No problem, Maju. Let's start it. Okay, let's go back here.
Hello, everybody. Be welcome to my session. My name is Sara, and today I'm going to talk about signaling task groups on a real-time fashion. So first of all, I would like to talk about my relation with NuttX. I'm currently working at Espressif system as a junior embedded software engineer, and I work on the port of NuttX to Espressif chips, like, for example, S32, S32C3, and more recently, S32S2. So what is this presentation about? This presentation has a goal, and the goal of this presentation is to show you how to signal to multi-thread task groups, and from this signal advertise other children threads that may be waiting for this signal to act, to do to perform some action, okay? And to achieve this purpose, we need to cover some prerequisites, some topics, like, for example, the difference between task versus threads, what is a task group, and why not a process, and also how to achieve a signaling on a deterministic, with a deterministic wake-up time. And why is this important, and why did I decide to talk about this? First of all, this idea came with actually my interest on signaling, on threads, on tasks, and all this stuff. It started when I started to develop the timer driver. And I realized that when we are using the timer driver, we can't register a callback to be called by the ISR of the timer driver. We need to configure a notification. So when the timer expires, it will send a signal through this notification. And then I started to study about this, and also realized that it's kind of a fuzzy content. There are many documentation spread regarding this aspect, and mainly when we are talking about signaling multi-thread task groups. So it's also a kind of overview that I'm bringing here in this presentation. It also may be required in your application if you are using task groups and you are using signals. So how are we going to explore it? What I'm going to do after presenting these topics for you is to present a simple application that uses signaling to multi-thread task groups. So first of all, what is the difference between task and threads? This is a difference in NuttX that may be not present on other operating systems. So tasks, when they are created, they create private resources that other tasks should not access. And when a thread is created, it will share this task resource. So basically, that's the difference. they share the task resource, like, for example, file descriptors, file streams, and so on. Threads, they cost less memory. And when a task is created, also a task group is created along with this. And the task group emulates a POSIX process. So it's not a POSIX process, but it works like a POSIX process. And the threads become part of this so-called multi-thread task group. Okay. This task group is very useful when, for example, we are not using the kernel mode, when we are using flat mode, or when we are using protected mode, because processes in NuttX are not available on both flat and protected mode. So here is a simple draw that can expose the idea of a task group. We have a task, and then we have the children threads here, which become part of this task group and share the resources of the task. Okay? So process. Why not process? A process requires a memory management unit to protect its address space. And NuttX was designed to support not only microcontrollers that support MEMU. It also was designed to support microcontrollers that does not contain a memory management unit. And so when we have a less robust microcontroller that does not contain MEMU, it would not be possible for this microcontroller to have a process. So in this case, we have the task group that emulates a POSIX process. Okay, but if you have, for example, a MCU that contains memory management unit, you can use the kernel mode, and you have a complete process, POSIX process compliant. So let's move on and talk about signaling. Signals are used to notify events between tasks or within a task context, okay, between threads, for example. And there are basically two mechanisms to catch these signals once they are sent. We can use signal handlers, which is a not very recommended solution because it has a long latency. And we can use waiting functions like the one that I'm going to present when we see the code. And these functions is very important if you want to have a deterministic time between when the task sends a signal and the another task or thread gets the signal. But for this, you need to set the task that is waiting for the signal a high priority. So this is suitable for the real-time applications, and this is the part of real-time from this presentation. So when we are signaling to multi-thread task groups, we have to keep some things in mind. The first thing is that the behavior of a multi-thread task group depends on configurations. So you may create a task, you may create threads inside this task, but if you don't enable the required configurations, you are not going to have the expected behavior documented in NuttX, what is expected. Second thing is that the behavior also depends on the signal set, the configuration of the signal set from your main thread and from the children threads. And also one thing that I would like to talk is what if the main thread dies? Okay, so let's dig a little bit into signaling to understand what happens when we have a signal. Well, signals are sent, are initiated through an XSIG-Q, an XSIG-Q, an XSIG notification, and they all will call an XSIG dispatch. And this function will behave different if we have this definition defined, this macro defined, have group members, and it will behave different if we have not this macro defined. So if we don't have this macro defined, it will not follow the roles for signaling multi-thread test group. You're going to read one thing in the documentation, and it will behave in another way. Signal will be dispatched to the specific PID usage. So in the next slides, we're going to see that doesn't matter the pthread ID. When we are signaling to a task group, we're going to use the ID, the PID of the main thread. Okay, so but if we not have this macro defined, we're not going to have this behavior. And so how can we have this behavior, the correct behavior? We can have the correct behavior by enable these two configurations, scad have parent and scad child status. Okay, these two configurations together, they allow a relationship of parent and child between the task that created the threads, and it also allows to retain the exit status of the threads, of the children threads. So regarding the second topic, behavior depends on signal set. When you enable these two configurations, what will happen is that once you send a signal for the task group, the thread that will receive, that will catch that signal is not well defined. It will be any thread that's not blocking that signal. Okay, so here in this draw, what we have is, for example, we sending the signal number 17 to the PID 3, which is the PID of the main thread who created these threads. What will happen is that one of the threads that is not blocking, I mean, for example, here, let's say that thread 3 is blocking signal 17. So this thread will not receive the signal 17. But if thread 1 and thread 2 are not blocking the signal, or both of them are waiting on this signal, we can't define which one is going to receive the signal. So that's why the behavior depends on signal set. The behavior of signaling for multi-thread task group depends on signal set. We have to configure our signal set in such a way that we can define who is going to receive the signal. You may also observe here that I use the PID of our task, because other tasks are not supposed to know pthreads IDs. But if we are in protected or flat mode, that's possible, but that's not supposed. But other tasks are not supposed to know pthreads. So you should not use the pthreads. You should use the task ID. So what is a strategy to ensure that a specific thread will receive that signal? One strategy is that we can take advantage of one thing. Pthreads inherits signal mask of the task that created them. So you can create a task that blocks all signals, and then when in the pthread, in the specific thread that you want to receive the signal, you unblock it. And how you can do this? How can we achieve that? By using, for example, sigproc max, pthread sigmax, which we can define which signals we want to block or which signals we want to unblock. Okay, and the last thing to have in mind when signaling for multi-thread task group is, what if the main thread of the task group exits? What will it happen? What will happen is that all the children also dies. So you need to keep the main thread alive to keep the task group alive. So now that we have covered some of the basic concepts regarding task groups and multi-thread task groups and signaling multi-thread task groups, we can finally work on that, and I will show you how to do it. So what I'm going to present in the following minutes is a simple application. This application is basically composed of one task group, this task group here. This task group has two children threads in the main task, the main thread. This main task, as I said to you before here, it can't die, because if it dies, the threads also die. So we're going to use the pthread join function. So it will be suspended and wait until the children threads finish their work. And here in thread 2 and thread 3, we have the signal blocked. Okay, this symbol means that we have the signal block. And on thread 1, I'm going to unblock one signal, which is the specific signal that I'm going to configure for my timer callback to send through NXSig notification. Okay, the thread 1 is going to be waiting for the signal using this API sigwait-info, which, as I already said before, is it's better than signal handlers because it has a wake-up time deterministic, mainly when this thread is with high priority. And what we're going to do is, every time that a signal is catched here by thread 1, we're going to post on both semaphores, semaphore of thread 2 and semaphore of thread 3. Semaphore of thread 2 and semaphore of thread 3 are same, and they are only waiting for the right moment to perform some action. This right moment is at timer's expiration. Talkship, show me the code, as our friend Linus Torvalds says. So let's going to move to the code. Here we have the main thread of the task group and the pthread that catches the signal, and here we have the other pthreads that are waiting for the signal to take some action. I'm going to move to my code editor to show you in details and also to run this application. So here we have the Okay, let me show you the code. Okay. Here we have the main task, and the main task initializes doing what? It initializes the semaphore, the semaphore that will be used by the thread that receives the signal to unblock the other threads. And here we are going to configure the signal set for this task group. First of all, we're going to initialize the signal set with all signals, and then we are going to call sigprogmask to block all the signals in the set. Since we have used sigfillset, we are blocking all the signals. Then in this snippet, what we basically do is to create first the pthread that I call it pthread man or pthread or thread manager, which is the one who is going to receive the signal. And then we loop creating multiple threads that I call it thread workers. They are simple threads that do the same thing. They will only print like a hello and a hello with their index. And their index I'm passing as a parameter here, as a pthread parameter. So then I call this function, which is the timer setup, where I configure the timer callback to notify the task group through one specific signal and passing the PID of the main thread of this task group. And then we go to a loop where we're going to wait for all threads finish. And when all threads finish, the workers in this case, not all threads, but the workers thread finish, we stop the timer and we exit from this and we finish our task group. So first, let's go into take a look on the manager pthread, the thread that will receive the signal. Here we also initialize a set, but in this case an empty set, not containing no number, no signal number, and we add only the signal number that we configured in the timer for the timer to notify. And we use the sigmask now to unblock the signal on this set, because since this pthread inherits the signal the signal set, the signal behavior from the main thread, what is going to happen is that if we do not do this, this thread will not unblock the signal. So here we go to a loop, and in this beginning, this thread is going to suspend until the signal is unblocked. Until the signal is pending, or until the signal is received. So once the signal is received, it's going to print received signal, and it will loop on this for and post on the thread semaphore to unblock all the threads that are waiting on a semaphore. So here we have finally the thread worker, which is basically a simple thread that will loop in this while 2 times. It will wait on the semaphore to be unblocked by this thread, and once it is unblocked, what it's going to do is print a hi from and its index, its number. It will loop again, so when it's executed 2 times, it will leave, and finally pthread join from the main task is going to return. Okay, so let's take a look on this working, on the execution of this. I have I'm using here my ESP32 chip. I don't know if I can. My cable is very short to show you. So I have already downloaded this application, and what I'm going to do here is to reset my board and then execute my application, which name is test group. Okay, so now I configured the timer like 2 seconds, and we can see here that we received signal 2 times, and we had the 2 worker threads saying hello and showing their index, and we can type here PS, and we can see that we have no more threads or the task who created these threads, so it concluded okay. Now we can move on and back to our presentation. Okay, so here is the end of the presentation. I left here some of the references that I used to this presentation. I hope you can enjoy it, and thank you very much for attending to my session. Bye bye.
Okay, thank you, Sara. Maju?
Thank you, Alan.
Thank you, Sara. It was a great presentation. Now, the next presentation I can share here. Okay, Alan?
No, Maju.
Oi. Hi.
We have the draw, and
the draw, okay.
Yeah, and we need to wait the next time slot to start the presentation, because
Sara will random the numbers for the draw because I do not have the spreadsheet.
Okay.
I will forward to you. Actually, Maju,
yeah.
access the folder Raffle's forms.
Wait a second. Yes, I'm here. Raffle's forms.
So here you're going to find the form and the sheet of that form. You disable accepting new answers in the form, and you use the sheet for the Raffle.
Okay, I'm just searching for the presentation.
The name is Realtime Signaling Task Group.
I found it. So let's begin the Raffle. I will not accept more answers. Okay. We have just 3 answers, and we have 3 numbers to random. Is it right?
Yes, But if you want to, but you want to do the random just for fun, just to see who was the first one to win.
Okay, I can do this.
No, we can't have 3 winners here because one of them is Felipe Erazo again.
So
this one
maybe
is a
we
lucky
can,
man. This one is a lucky man.
yeah, maybe we can. What do you guys suggest? We can open it again to let more people to enter the names, or we just give the prize for the two others and move to the wait to the next draw to do the remaining. What do you think is better?
I would say open it for another 10 minutes since the presentation ended quite fast, and then we close it.
Yeah, I agree.
I will
We can
open again.
Yeah, please, Maju, open again the form and let people to participate again.
Not a problem.
Thank you. I will ask there.
It looks like it's not working.
Let's see.
Wait.
Yeah, it's working now. Let's see.
Now it's working.
Yes, it is working.
Okay, so when Wendy was 45 here, we can close it and try again the
Raffle.
The Raffle, yeah. Let's see.
Actually, how it's the correct pronunciation? Raffle or Raffle?
I think Raffle is the French fries ship. Raffle.
No, wow.
Yeah.
This is a brand,
Alan jokes.
a Brazilian brand. This is a Brazilian brand. Nobody will understand that.
No, Ruffles exist in other countries as well. It's
Really?
from, yeah, Ruffles, yeah. I remember buying it. There's a big, here in Brazil, the bag is small. In the United States, the bag is very, very big. Yeah. Let's try to find it.
Do you mean waffles?
Yeah. I think RFU.
WAFFLE.
Waffles, like
it's from Elma Chips.
You need this kind of prizes.
something like that. Ruffles.
Yeah.
And I think in the next year we can have Ruffles as prize.
Yeah. At least for
Next year we need a coffee break.
Yeah, at least for the hosters to get it in the middle, in between the presentations. It will be nice.
I tried to add a coffee break after the first session, but unfortunately I was not allowed by Alan.
Sorry, guys. Sorry, Ali. I didn't know.
No problem.
By the way, do you remember the coffee break in the first event in Gouda?
Yeah.
It was really nice, right?
I'm looking forward for a live event again so that we can have the chit chat. Now the chit chat happens only here between us, but in Good Eye, it was a chit chat for everybody, and it was really nice.
Yeah.
So hopefully next year we will have a live or maybe even a mixed event. That would be awesome.
Yeah, I agree.
But since we have a little more time and we have Koizumi-san here, I would propose that we ask him also, how did he find NuttX? And what made him use NuttX in products? Koizumi-san, are you around?
Yes.
We cannot see you, by the way. Could you please turn on the camera?
Okay. Just a moment. I was relaxing, so.
Extremely ugly.
Yeah. Yes.
I was asking if you can tell us. So, since the event started, we asked each of the speaker how did they reach NuttX, what was the first contact, and why did they take NuttX as the operating system for their project?
Oh, on a Spresense project. Okay.
Or another project.
Oh. Yeah, the Spresense, NuttX is the when I met NuttX, the NuttX has many things, not only the kind of the scheduler and memory management, including the application side too. So, and also the POSIX interface, POSIX-like interface, and architectures. We were familiar with Linux system, so it's very hard to say feel sympathy to the NuttX, and memory is uses memory is very short, so small. Yeah, I feel very interesting about NuttX. Yeah, that is the main reason to take the NuttX on our project, actually. So
when did you build NuttX for the first time?
What?
When?
Oh, when I met NuttX, the first time it was the drones, PX4. Yeah, I made my own drone, and then the software was using the NuttX based the PX4 Hawk. So then I met it.
Nice.
Yeah.
In which year?
In Wiki?
Which year? When?
Which year? Oh, the 2016. Mm-hmm.
So you're a long time user, 5 years.
Not so much. Maybe the Ishikawa-san is also very old guy to know the NuttX.
Yes, thank you very much.
Yeah.
Yeah, long time already. 5 years working on it. Yeah.
Yeah. I'm still have a fun for using the NuttX. Yeah.
Yeah, it's very fun. It's nice because it seems like you are running Linux in your board. Yeah, it's amazing.
Yeah, I think so.
Yeah.
Yeah, so it's very powerful.
Yeah. So
did you use the default PX4 how to say PixHawk board?
PixHawk, yeah.
Yeah, did you use it at the time?
Yeah, I did.
Nice. And do you know someone using the Expressif board to create drones?
Yeah, actually, my friend to use it as a hobby, yeah, to try to fly by Spresense. Yeah.
Yeah, I think it should be nice because you can have image recognition in the board, and yeah, you can do advanced things with this solution.
You also have the GPS on board.
Yeah, GPS.
Yes, the GPS. By the way, I want to push you guys again. There is some improvement on the GPS front. We are planning to release the firmware, the source code of the firmware, something like that, or not yet? Are you planning to release the source code of the algorithm inside the GPS, or not yet?
No, not yet.
No, not.
No.
Yeah, it's like asking for us in the Espressif. Are you planning to release the source code of the Wi-Fi driver library? Yeah, it's a little bit difficult. I understand the point. Yeah, it's the how to say, is the jewel of the crown, the queen. It's the masterpiece of the company. You cannot release the source code of it.
Yeah. Unfortunately, yeah, it's a kind of the weapon to get the money for our business. So it's a bit difficult to open the GPS algorithm source code.
Yeah, but I think at least maybe we can try to use some open source algorithm on it. I don't know if it's possible, but I remember a guy. He's a teacher in the Portland University. His name is Andrew Greenberg. His master degree dissertation was about creating the GPS algorithm. Maybe could be possible to use. I don't know. Maybe in the future we can think about it. Okay, guys, I think we have enough time. Maju, and thank you.
Thank you, Koizumi-san.
Yeah, thank you.
Thank you. By the way, Maju and Sara, do you have enough participants forms in the form now?
Yes, I can stop receiving answers again. I will share my screen. Wait a second.
Okay, thank you.
Okay. It's right here. 2 from 9. So 2 and 9 generate 8. Victor Miranda. Congratulations, Victor Miranda. Next one. 8 again.
Not that
5.
Yeah.
5, it's Alin. Congratulations, Alin.
Thank you.
Congratulations, Alin.
The last, but not least, 8. Again.
Yeah.
6. Okay, 6. Rodrigo. Congratulations, Rodrigo.
Yeah, congratulations, Rodrigo. Nice to see you.
To all winners.
Yeah. Rodrigo worked on Motorola here in Brazil. He worked with the team that work in the smart covers.
Really cool.
Very nice. Do you have another, or we finished, right? Yeah, Alin,
Yeah.
Vitor Miranda, and Rodrigo Sim. Okay. Perfect. Thank you, Maju. Let's see. Yeah. Just to see how many. Well, we already raffle 28 boards. So yeah, very, very nice.
Many more to go.
Yeah. Okay. We still have 10 minutes. Yeah. So I think we can still talk a little bit more. I don't want to push him because maybe he's a little bit late in Japan, right? Let Kozoyumi relax a little bit and maybe later.
Thank you.
Okay, thank you, Ali. And before working with the NuttX, I think you are already you are already working the open source community, right?
Yes.
What was your previous job before working on NuttX? What was working on?
Before working on NuttX, I've been working on the Xperia line of mobile phones. So we had a project, I described it briefly last year, and we still have that project in which we allow people to replace the operating system on their mobile phone with an open source variant built from code. So basically, you get the AOSP from Google and you build it yourself. And it's nice for repurposing devices. It's nice for learning how an embedded system works. It's nice for innovating on the platform because we are talking about platform level innovation.
Yeah. And was it the cyanogen mod or other?
No, it is pure AOSP, and the project can be reached from our website, developer.sony.com, and the project is called Open Devices.
Nice. Yeah, you talk about it, about the Xperia phones. Some years ago, my phone was an Xperia S. Yeah, and I used to do it. I used to replace the original Android by the Cyanogen and also the free Xperia, and it was really nice. It used to work very, very, very nice. And currently, I'm not doing it anymore with the current phones, but yeah, I like to do it.
You have old mobile phones that probably you want to repurpose. And that is where this project is really handy.
Yeah.
It helps you recycle the old devices.
Yeah, that's a good thing because currently they are doing the programmatic like programmable obsolescence. So after 2 or 3 years, the phone is still new, but you cannot use it because the Android already changed a lot and they didn't update it, so you cannot use it anymore for daily base work, but you can repurpose it to other things, right?
Yeah. Considering that now we have a lot of things that define us on the mobile phone, and now I'm talking from my personal perspective, I would feel extremely unhappy and unsafe to use a mobile phone that has an older operating system because of the privacy and security reasons, but also due to the hardware. You cannot use the latest technologies to secure your mobile device. So I'm not blaming the companies for not providing the latest Android on a 6-year-old device. So it's technically almost impossible.
Yeah, we know. Normally, the companies they have some restrictions. They don't have enough people to work in all the device all the time.
We know it from the Cyanogen. I was part as my free time project of the Cyanogen community, and not always the implementation was spot on. You just wanted the feature to work, and then you cut some corners to make it work. While if you want to make a secure device, you never accept cutting corners. And the same thing happens now with the next Windows, the laptops, Linux, and so on.
Yeah, that's true. And yeah, I still having this phone. By the way, the Xperia S. I think it's some is in some place here in the house. I will try to find it and show it later. But yeah, it was a nice phone. It was slim, small, and at the time, at least, it was very powerful. And after using the Cyanogen mod, it has a feature that I like the most. A guy creates some application called R Voice, like R VOIX, R Voice. These R Voice record all the calls. So every time I receive a call or do a call, I was able to record my conversation. It was really nice, and I missed this feature. Although in my current phone, I have the option to go there and record the call, but it's not automatic. In the Xperia S running this Air Voice, every time I receive a call, automatically it starts to recording the voice. Yeah, it's a very, very nice feature.
Now, if you spend very little time, you can make a nice surveillance camera from that device.
Yeah, and you are talking about privacy. We saw maybe last month about the Pegasus worm, the project from a company from Israel that provide government and people with enough money the option to invite the privacy of anyone. So yeah, it's a big concern. And yes, if you are using a outdated smartphone, the chance you are victim will be very big. Yeah.
I think that the outdated software issue will affect us more and more as we go more and more into the IoT space. And running even some IoT device with a deprecated NuttX will be a problem. So it's always better to be closer to the mainline, as close as possible, because then also the security vulnerabilities will be discovered and documented.
Yeah, I agree.
Yeah.
And so it is important to have the ecosystem in the main line because of it. So when you have, for example, Spresense in the main line, new NuttX version can be updated very easily. So it's important to the company to do what Sony is doing.
Yeah, Koizumi-san, I think will present that journey. tomorrow, and I really hope that we will see more companies doing the same thing, and I hope that they will understand this. So this is my personal view on the whole updating shim, but yeah, we will see where we will end up.
I think also the firmware update should be available on NuttX as well, to make it easy to people to use some features to do firmware over there.
Having an over-the-air mechanism would be really nice if we manage to get it directly in mainline. But there are other issues before we fix the over-the-air update. Well, first we have to fully transition to Apache, and then we can look at other aspects. Because my personal feeling again, we as engineers like to code, and we code various things in the platform, and we add support for whatever we need. But unfortunately, on the other side, we have companies that want to use the operating system, and they need a stable operating system with a stable license base that will not endanger their own IP. And we know which licenses we are talking about. And then by doing that, we encourage companies to come and join, because doing just the over-the-air mechanism now will create just fragmentation. We need a single over-the-air method that will work for everybody if they want to use it.
Yeah, I completely agree. And also, I think the license is very important to be uniform, and also what you did now to separate the license. So when you compile Apache only, you are guaranteed you are not including GPL, not GPL because we don't have GPL, but
we have.
I don't think it's like exactly GPL, because it's other conversation about the GPL. But when they decide to use Apache, it should be Apache only. So BSD or MIT or any others should be removed. So
not really removed, but those components should be treated with care. So basically, ask your legal department as a company if you want or if you are allowed to use those. It's safer for everybody to go with a clear license from the beginning. But we can discuss about this tomorrow because I have a full session on it. It's 10 o'clock. Yes. We should start the next session.
Yeah, the next session, Maju.
Yes. Our next speak is Flávio Alves. He's talking about software architecture for industrial IoT gateway applications. I will share my screen.
Maju, let's introduce Flávio. He's here in the presentation.
He's here?
Hello, Flávio. Yeah.
Hello, Flávio.
Hello, Flávio. Can you hear us? We cannot hear you.
Yes, I can. Can you hear me?
Yeah, I think your camera is turned off. We cannot see you.
Let's see. Let's see.
Oh,
hello.
okay.
I am in my living room here and watching on the TV.
Okay.
I'm not on my desk now.
Okay.
Hello, everybody.
Hello, Flávio. Okay, very nice to have you here with us, and
I thank you for the opportunity.
Okay, thank you. Maju, are you going to present, to stream Flavio presentation, or do you want to do it from here? It's up to you as well.
I can try, but if you want
Okay.
to, I think it's safer if you do it, because my internet connection it's a little bit oscillating.
Okay. Let's do it here.
Hello.
Just a second. Okay.
I will
thank
turn
you.
off my camera here, but I'm here.
Okay, I will start to stream it now. Thank you very much, Flavio.
No.
Okay.
Hello, my name is Flavio, and I will talk a little bit about industrial IoT and NuttX. So I start talking a bit about myself, and then I will talk about a recent design that I've been working on, which is an IoT gateway. I will pass through all the stages of the design, including hardware, NuttX, and application software, and some of the results and the lessons learned from this project. I'll start to tell a little bit about myself. My name is Flavio again. I'm an electronic engineer from Brazil, from Campinas. I had a diploma on the electronics and communication systems from École Centrale de Lyon. It was an interchange program during 1 year in France. And the past 20 years, I have been working on embedded systems design, embedded software development for several different industries, several different technologies. I worked with Linux, embedded Linux, PC Linux, and microcontrollers, STM32, microchip PIC, and some FPGAs. And from the last 13 years, I have been working on Fire Innovations, where I'm the founder of the company, and it is a Brazilian design house company, a company where we are contracted to design hardware and software to be included on other products. So this presentation it intends to tell my experience on designing my product. In fact, it is a project that it was initially supposed to become a product for the company, and that at the end this project became a platform for projects instead of a off-the-shelf product. And I will pass from the designs, from the decisions that we have taken to implement and out of the hardware parts. And the firmware for this product was not initially implemented in NuttX. It was finally implemented in NuttX. So the version 1 was using bare metal, using FreeRTOS, and now our last version of the firmware recently developed was done using NuttX. And I intend to describe a little bit about how NuttX impacted on our development here. Here's the hardware architecture for the software, not for the product, sorry. And as you can see here, it is a hardware. I to use the STM32 microcontroller and and a lot of devices peripherals were connected to this hardware, namely the Ethernet. It has Ethernet support, the RS485 support also, and USB as USB device. It has some LEDs for operation indication. And the hardware has 2 digital inputs protected by optocouplers. It has 2 analog inputs, also for using operation amplifier for signal purpose management. We have an UART for console, and in fact, initially it was designed for logging, to see the behavior of the firmware. Now it is used for nutshell and so on. The hardware has also an RTC, a temperature sensor. Another important component of the software is the data flash, or an external flash interface, where we use it here as a hard drive, similar on a hard drive, and the other communication technologies implemented on this hardware are Wi-Fi and mobile device and mobile communication to the DPRS model with support of two SIM cards. And finally, the hardware has also an SD card, and this SD card is used for, it's not so much used because, but it has the same approach as today we have for the data flash. Initially, the data flash was thought as for parameters and small things, and at the end, it was the real final hard drive of the solution, and we had used this SD card as an expansion. Here's a picture of the board. Here we have the USB, the LEDs, and the Wi-Fi, the GPRS, Ethernet. Here RS485 inputs, power, and below we have the SD card connector and the SIM card connectors too. Like I said, the main microcontroller, the main CPU of the project is the STM32F417, which is a very powerful microcontroller running 168 megahertz and with a fair amount of flash of 512. The Wi-Fi model is the S8266, and the GPRS model is the Sierra Wireless HL6528. And the data flash, it is a flash SPI with 1 MB storage. I would say that these are the main components of the product and of the project, and where we have worked on NuttX too. And how is the purpose of this gateway of this project? The main feature, the main purpose is to become a gateway between devices connected to using which supports Modbus protocol, and deliver the information from these devices to an IoT platform using MQTT protocol. So it has two things. So the gateway connects, for instance, for PLCs or meters, and using the and regarding PLCs, it is configured as a slave, and working as a slave, the PLCs update internal tables from the gateway, and these tables are periodically sent to external servers using MQTT protocol and network connectivity, internet connectivity, and from the other side, from the external services, you can send message to the gateway using MQTT protocol, which will update the internal tables and Modbus tables inside the gateway, and the gateway will make available these informations by the PLCs, which will request this information periodically. This is one use case. Another use case is when the gateway works as a master, when it is responsible to read several different meters and devices which are Modbus slave. So the most common use in our case here is power meters. So if you have a facility running several power meters, you can use the gateway to scan out those meters, collect this data, collect the data, and store it internally, and periodically send out the recorded information to an external server running MQTT. So these are the main features of the product. Initially, we fought for it, and as it has also digital inputs and analog inputs, the same behavior, the same for that we have for meters, we have also for these inputs. So we can define periodically reading for the digital inputs, include real-time reading and also pulse counting, and then these values are stored internally for later being exported and published to MQTT brokers and IoT platforms outside. So that's the main purpose, the main for the design for the product. So how we started? So the firmware was implemented in there. Two firmwares, in fact, inside the board. One firmware is the bootloader, and the second firmware is the application. And we have also to consider the data flash, because here the data flash is really considered as an analogy for a hard drive. So all the configurations and the information and the data of the running software is stored inside the data flash. I used the little FS file system for the project instead of the smart FS, which is the standard for NuttX. The reason for that is that I have already worked with little FS in the past, and also because the bootloader they supported the little FS even before they started the code development in NuttX. So here the logic is that the firmware somehow captured from outside the file and store it on the data flash, and this file is the new firmware. And when the system starts, when the bootloader check if there is a file with a specific name on the data flash. If it exists, then the software is updated, the firmware application is updated. Otherwise, the software is bootloader starts the firmware directly. So to have this feature implemented, I needed to have support for little FS in both applications. So bootloader and firmware, so to have the file system. So and the file system that has the support LibFS, as far as I knew at the moment, to work on that. And it was pretty nice to work even SmartFS or LibFS on the with NuttX, because it was really straightforward. I had nothing to, I didn't need to do anything on the regarding specificities. So I just changed the option and it worked. It just worked for the application. So here now I'm talking a little bit about the NuttX, and in this case I will. Why I choose NuttX to work on the project? I choose NuttX because I would like to have something that was quite complete in the sense of hardware support for my board. So not just a scheduler, just like FreeRTOS, and then I had to mix with the how features provided by ST, but I would like something that alone itself it had everything. So it's just like an operating system itself. So just like the Linux or Windows in our PC, I would like something similar on the firmware because as the base, and on open source way that I could count on and be part of a community to support and to support and have support. And in this case, NuttX appeared to be an excellent option. And when I tried and I could execute it a bit, I realized that it was the best option for my project. And one of the things that I liked a lot is the close similarity to Linux. So I have been using Linux to software develop for so many years, and then and it had the opportunity to work just like that in a firmware was very important for the project and for me, and even for expansion for the software for other targets, things like that. And it was great when I found out NuttX, and then that's why I started to work on that since on. And in our case here, the board was pretty close. The microcontroller is very close to the microcontroller used on the STM32F4 Discovery board, which is a board very used on NuttX for testing and development and documentation. And then I started from there. So in fact, it was not me. I contracted another person, to Oliver, to start this work for me, and he is a very skilled NuttX developer too. To know he is, I'm not sure if I am, but anyway, he is a very skilled NuttX, and he implemented all the initial bring up the board support functionalities for my board for me, and which includes Ethernet setup and SD card support, USB, UART availability, IOs, integrating the data flash, because we know that even if the board is closed, there are a lot of very different configurations and this work must be done. In fact, to have these and now integrated for at the end we have a flawless nutshell boot. Where we can use small, simple commands to access the peripherals, such as USB, such as SD card, Ethernet, and Internet, and also the Wi-Fi and GPS modules. So yeah, and during this process, I followed up with him, and I realized that the board support is not hard to do here. In this case, it is not so much low level. It is a bit low level, but it's not so much low level. It is for a person who is used to work on firmware and ST basic stuff. It is not critical to, and the code has a lot of layers with a very good naming, the NuttX source code, so it is very easy to find yourself there and then to see how to address these board support implementations. And now that this is the first step for NuttX, let's say, the second step is to prepare it to implement my project. NuttX is nice because it has several different approaches that you can do to that, and it is important to choose one. Yeah, I chose it for this project to work on C++, and I chose it to, I would like to have a programming experience similar to an ordinary microcontroller. So I would like to create some kind of mains thing, and then I run this main thing, and it is okay. Let's say it's more close to Linux. So okay, we create a code in Linux. So we start with a main, and we compile and we execute, and we debug. And I would like to have this programming experience in NuttX for the board, initially for myself and later for others. And how I used NuttX to have that. I used C++. In fact, it was not mandatory, but I would like. I've been working with C++ project in the past quite a lot, so that motivated me to work on a firmware on NuttX. And I deployed NuttX as a library. So okay, it seems strange to have the whole operating system is a library in a project, but it's okay regarding firmware development, and that we will have just a single image to be installed on the microcontroller every time that we will execute for testing. It is not something that is there and then you change an application. So every time you have to load everything. So it's not a problem to see NuttX in this way. Running, we can see the difference, but in development, not so much. So that's why I choose that. And another thing is that another important point here is that while compiling, I didn't need to compile NuttX every time, and don't count on changes on that. But it is not so relevant. So on other approaches, it won't impact either. I created a CMake file structure for my project, and I disabled Nutshell because I would like to see, just like an ordinary firmware, I would like to see my software output from the console, not the. And I didn't want to have a prompt to start my application. That's the purpose to have a similar user programming experience as a standard Linux application. And I would like to have tools to ease my development. So I used Visual Studio Code. I used Sager JLink for flashing and debugging. I used the Sager tools here integrated with the Visual Studio and also with the binary generated by my CMake. And it works very well. It was not exactly plug and play. I needed to learn quite some things here, but I have a ST-Link to device to load and debug, and I needed to learn how to set up all of this, but it was fine, and then then I have a complete working environment for my project like that, and it was pretty awesome. And regarding the project itself, now starting to say a little bit about the implementation. I used external libraries. Some libraries came directly from the NuttX configuration. Other libraries I added as CMake components in my build. So I don't remember. By the time I was preparing the presentation, I didn't remember, and I couldn't see which libraries I used from the NuttX. So, but I remember that I used the JSON. So I listed JSON, and the others I remember that it was on the code, which were libmodbus and embed TLS and MQTT-C. These were the first one to provide my Modbus communication, the second one to provide the secure communication over MQTT, and the latest one is the MQTT-C to provide the MQTT-C protocol in NuttX. It was almost directly to. In fact, Modbus didn't have support to CMake, so I need to create the CMake file myself. But the others, the CMake file from the open source project was quite straightforward to connect, to integrate to my project. And now here I have a small, brief overview of my project. So these are the base classes from my project, where the Phi gateway is the main class, is the class that starts everything and launches everything. So yeah, my main.c is just instantiate Phi gateway and run it, and it's called another method called run. And this class is responsible to, inside that we have all these other classes, where status class contains the status information about the real-time operation of the firmware. System data contains all the configuration information used by the gateway. LEDs is just turn on, turn off LEDs and blink. Network interface here, network IF here, it is a, let's say it's almost a virtual object with which has other inheritance, which are the network communications available on the project. So I have a class called Ethernet. I have a class called GPRS, and I have another class called Wi-Fi. And then all of these are specializations of the network interface class, and this class has all the specification of the services that are used by the Phi gateway class and the others to perform network operations. Mostly here in this case is socket management and operation management, detection of failure, things like that. So these are the, let's say on the right side we have these are the support classes, let's call it like that. And then on the below here, the transmission capture and manager have operational classes, where transmission is the class responsible to send data and get information from the send information for the MQTT using MQTT as a support object. The capture, in fact, is responsible for the Modbus communication, and also the IOs. So it is responsible to capture the information there, to the other devices plugged on the gateway. And manager is a class responsible to handle the USB communication. So the USB communication to exchange, it was used as a command. It's for changing and setting parameters on the device. That's the only use of the USB in the project. So so the manager class is responsible for handle this and update the system data, the system data contents. And system data contents is used by every working object here on the project. And here I have a flowchart, a basic flowchart of the main operation of the software. So it is like I call it setup here for the beginning. It is just to be some kind of Arduino analogy for setup of the hardware and the basic software configurations to before view execution, where it is in Arduino is on loop, and here I draw a loop here just after, and in here in my loop here the first thing is to check the network availability, and then the second thing is to check if there are commands are arrived from the USB. If there's data from USB to be evaluated, it will be done here. The next thing is to check if we need to scan data from using a Modbus, and after the scan, we have, and then the transmission, the communication with the MQTT is performed. First, the data is sent, and then it check if they're receiving data to be processed, and that's the loop, and then the status are updated, and then it's coming back again to the start. So of course, that inside of each run here and scan and things like that, there are timers that and checks. For in case of the manager, we check on the file descriptor if there are bytes there arrived from the USB, which is works just like any other serial. We use the USB CDC implementation here. So it's just like a serial communication standard if we program in Linux. In case of capture, the activities here, it executes every time, but the execution inside is based on timers. So we set timers, okay, if we have to wait 30 minutes to perform a scan, so every time the scan is called, but it will be executed itself only after 30 minutes, and the same happens for transmission. And that's the approach. I'm not sure if it is the best one, but it is quite fair, and I would like to have the implementation as simple as possible for understanding from top bottom. And here, what I have from all of this, now I have now it is working. The software it is very solid, working with Ethernet interface. We are testing the GPRS implementations. GPRS here it was implemented using the NuttX PPP strategy. And one thing that I didn't realize at the beginning of the project and caused some issues here on this project is that the Wi-Fi. Because in fact, I checked the Wi-Fi. There is a library for ESP 8266 support on NuttX, but it is not the way that the correct way for NuttX for that, because the NuttX, it implements the networking just like Linux. It has the concept of network driver and the network interfaces. So here we have one network interface for the Ethernet, another one for the GPRS, and I needed another one for the Wi-Fi too. And then I open sockets and then connect or bind and work just like that. And this is not using the library for ESP8266 is not available, which will impact now my architecture. So so to solve this, so in this case I let the Wi-Fi implementation on hold, and I started to talk on the community about how to implement it. There is an approach for in NuttX to implement this. There is I don't remember the name here now, but there is an approach where we have a wrapper. Let's say that it is a network driver wrapper, which is responsible to connect to another driver, where this driver will talk directly with the peripheral to provide the network interface support. And this is the approach that must be done. There is a very nice best presentation describing how to implement that for another Wi-Fi model, and I intend to work on that as soon as possible. And one thing that is important here to mention is the size of the firmware. So the size of the firmware, it took almost all the space available for that, which is compared to my previous implementations, it was quite a lot. But I believe that it was mostly caused by the use of C++, it was not caused by NuttX. It was caused by C++. And I intend to investigate that in the future, but for now that's the only observation that I could do. And what I learned for all of this is that what I would say is that I don't know if I did it well for in case of using to implement as the programming experience similar to an application. Because the code, I started to realize that after the code, I saw the code size. Maybe if I use it, the standard directory structure on NuttX and add my application inside the app and things like that, and split the implementation instead of several objects inside a single project. If I use it, different applications running internally on NuttX structure and using communication technologies between them, or even a database, or if to make the glue between the applications, maybe this could I could have a more simple project. Of course, that I strongly believe that if I implemented this code in C, it would take less space. But I really intended to work on C++. Maybe I need to figure out in C++ how to improve my programming techniques to reduce size. Because one thing that I like most in C++ instead of C is that I'm not a language geek. I don't know a lot of features and details of the language. I don't advocate for language, but in most of my projects in my life, I worked more in C and more in Python for testing, and sometimes now more recently more development in Python. And in the past few years, I started to work on C++, and I started to implement algorithms, things like that. And this implementation using data structures, it's much better to do that in C++ than in C. And then I don't want to lose that. So we use in Python a lot of the structures. We use a lot of in C++. It's possible to use similar to Python, but it's harder to do that in C. And I would like to think more when programming. I like to think more on application and the data organization instead of more details, and that's one of the reasons that I chose to work on C++ in this case. Maybe I'm wrong. This is a question. It is a matter of discussion for hours or years. And finally, the driver. So I need to figure out how to do that during my working plan. And I intend to implement this driver support and add it on the code base of NuttX. So I believe that's it. So I would like to thank you for the opportunity, and I'm available for questions, whatever you want, and I can help you. I intend to have this project open sourced as soon as possible. I don't know how to do that yet. I need to organize almost everything, and I intend to document it too when it started to become open source. And but that's one of the reasons that I'm presenting here. I'm just showing it overly, but later in a couple of months, probably all of these will be available online. Thank you very much, and see you later.
Okay, thank you, guys.
Thank you, Flavio. It was a great presentation. Alan, we have a draw, right?
Okay.
Okay, I will prepare the draw right now, or I'll wait.
Let's see. Maybe we have questions. I didn't look yet. I
realized that Flavio was talking at the YouTube chat.
Yes, but I'm here anyway for audio, if you want.
Someone's calling you.
I didn't listen to Alan.
Someone figured out your secret now.
You are like TV only. Yeah, that's true. Oh my God! Now I will become red. Yes, because at the beginning I was more formal, but now it's almost time to relax because, guys, we are here all the day working on it.
Yes, we are complete almost
11 hours.
Started the day using pajamas. And now
11 hours and 8 minutes and counting. Okay, Flavio, sorry I interrupt you. Please go ahead.
No, it was just a joke.
Okay.
So I think we can move on to the draw, right?
Yeah, please, we can stop the form.
Okay, I am doing right now. Wait a second.
Mm-hmm.
We have 5 answers. I will close the form. It's done. Now I will share my screen.
What, Sara? What was the joke now?
Gregory commented an even better comment. Let's just hope he's wearing pants of some kind.
Yeah, it could be water, right?
Yeah. And Gregory, if you are listening to me, I'd like to say that I love the sentence that you said to Yaoyao regarding the name of the Villa framework. I will save that for my whole life. In fact, I understood that, but I haven't seen that with those words, and that's really it. It was amazing, the sentence. I don't.
Okay, guys. By the way, if no one, okay, Maju, just a second.
Okay.
Just to return to the. Please stop the sharing. Let to do another print screen. I don't know if.
Alan, I can't listen to you if you are talking.
Alan lost his internet connection.
Yeah, does he want to take a picture with the camera or without the camera?
Okay, so Maju, I think we can proceed with the Raffle.
Okay. I will share my screen again. As you see, we have 2 and 6. 3 numbers. Number 5. Number 5.
Abdelatif.
Abdelatif. Congratulations, Abdelatif.
Also known as Os.
Another one. 5 again. 2. Okay, 2. Flavio Alves. Oh, congratulations, Flavio. Our speaker. The last, but not 2 again. 3. Erding. Congratulations, Erding. So, that's done. Congratulations for all the winners. Alan is back.
No, he's still.
Yes, I am here, but Chrome crashed as usual. Yes.
You want to take a picture?
Yes, I was planning to take another picture. Please, guys, if you stay available, please enable the camera again. Let's see. Okay. Flavio, can you hear us? Can you please turn on?
Yes.
Oh, Masayuki, I can't believe it. 6 a.m. and he's still...
Yes.
When I think Masayuki has gone, he's still here.
Kuzumi-san, can you hear us? Can you turn on the camera?
Me?
Oh, yes.
Yeah, everybody. Just to
turn on your camera.
Yeah.
Thank you.
Okay. Okay, let another one. Okay, just a more second. Alin, okay, Roberto. Nice. Okay. Thank you, guys. Sorry, Maju, so we can finish the...
Alan is not only the hoster, but he's also the photographer. Right?
Yes. I need to take pictures. Thank you, guys. Maju, could you please finish follow with the draw, please?
I already done that.
So it's done.
Yeah, Flavio won the prizes.
Oh, congratulations, Flavio.
Thank you.
Alan, I want to see if when we make the NuttX workshop on Japan, if we're going to have Brazilians like Masayuki.
Yeah, no, you can be sure.
They...
Not only Brazilians, of course, American ones, actually.
Yes.
Yeah.
I think they cannot handle during the day. Let's suppose
We are talking on weekend. It is Sunday there.
Yes, it's Sunday.
Sunday.
Yeah, and still one more in few hours for him.
On his Monday to still have event.
Yeah. Okay, guys. Now finally we will have the last presentation for today, and it will be from our friend Dave Merples. Unfortunately, Dave is in vacation, so probably he's using short like I am doing, using some. He's not using pens, and so he will not be available to in the Jitsi, but he will respond. He will answer questions in the YouTube chat. Okay. So
Alan, before you start playing the presentation, we should also announce tomorrow's plan for raffles and the final raffle. Since we have 4 more minutes, I will announce that because we want people to know about the plans. So tomorrow, after each session, we will have another raffle for 3 boards sent by the companies that helped us with this event. And at the end of the day, there will be a big raffle with all the remaining prizes. Really nice boards. Raffle in which you can win even if you already won something in the small raffles. The catch on that raffle is that only developers or people who contributed to NuttX are allowed to participate. So if you did not contribute, then there is no chance for you to win. But we always leave you an opportunity for next year to become a contributor, and then you will win in the big end raffle.
Yes. Thank you, Alin, to remember it. Yes. This is our way to give back to people who are helping us. So it will be important to have more people contributing with our project, and this is a way to say to send this message. And for the other participants, they need to be here. They need to fill the form. But those people who to subscribe and they are contributed, no matter if he or she is here or not. Just to be a contributor and be subscribed to event, they will win. They will receive the prize if they win. Okay.
They will participate to the raffle. There is no guarantee that they will win.
Yeah.
At least that they are qualified for the raffle.
Yeah. At least many of them will win, and this raffle will be only for the final raffle. Will be only for the contributors. So if you are a contributor, your chance to win will be bigger. Okay.
Yeah, but each people that is around us during the whole day tomorrow has the chance to win another prize.
Yes. Tomorrow, like today, we'll have 9 or 10 normal raffles, and the last one will be the contributors raffles. So the contributors will get the chance to win, even if he or she is not watching the presentation tomorrow, okay, or today. They're not. They don't need to do it.
Yes, they were with us, and we worked together in the past year or years, and this is our way of saying thank you.
Yeah. So, okay, we are on time now. I will start the last. Let's see if I have it here. Maju, can you try to do that? I can't. I think only 2 presentations I didn't download. There was this one and the other, because they sent it a little bit late, and let's find it here. Maybe I can download now, just to confirm I didn't download it before.
I have the presentation downloaded here. I just need time to open it.
Yeah, but maybe it will fail again. I don't know if I can download it. Maybe it's better I download it from here.
No, it's okay. I can try. And
yeah, but do you remember the other time you are trying? It's not working on your side. Let's see if yeah.
I don't know if you want me.
Yeah, you can try. Yeah, you can try, by the way.
Okay.
Maju.
Yes.
I already downloaded it here. If you prefer, I can already start it from here.
Okay.
Yeah, maybe it will be a little bit lag, like in the other.
Hi, my name's Dave.
Okay, let's. The sound is a little bit low, but it will be okay. I hope.
Hi, my name is Dave Marples, and today I'm going to talk about using various techniques on ARM CPUs, specifically Cortex family, for real-time trace for embedded development. So at NuttX 2019 in Powder, I reported on using Orbuculum, which was a set of tools which sampled single wire output from ARM CPUs, Cortex family CPUs, for analyzing the behavior of running programs. At that time, I said that we were looking at the development of a FPGA equivalent capability for using the parallel trace for full execution capture as opposed to sampling of execution. And today I'll report on the current status of that effort, where we are, where we've got to, what works, what doesn't, what needs to be done. This is being done, you see there's a little logo in the bottom corner, the org code. Org code is not a formal organization, it's just a convenient label for holding this work. And the previous presentation is available at the link here. You don't have to take notes. I've put all the presentation links on the last slide, which we will get to eventually. So in terms of the structure of what we're going to talk about today, let's start off with a quick recap of the V1 capabilities to explain to people the context of Orbuculum and what it's there for, and then a quick demonstration of V1 using the new debug adapter. Then talk about OrbTrace, which is effectively the hardware for V2, and then a demonstration of some of the capabilities we get with V2 or V2 upcoming, if you like, before we do a wrap up at the end. Because doing a wrap up at the beginning wouldn't make too much sense. So when we started on this, I had a definition of a rationale, which basically said you can write code that's as good as you like, but you need to verify and validate its operation as well. How many times have you written a piece of code and over time discovered that it's not working in the way that you expect it to? You may be getting the correct results or the expected results, but the way in which it's reaching those results is not the way that you thought it would. Maybe it's just me, but that does happen far too often to be comfortable. We don't know, most of us that work on embedded systems do not know exactly how busy that processor is. Is it running flat out and there's no headroom left? Or is it very idle, very relaxed, and actually there's plenty of room for adding more functionality or whatever it happens to be? Visualization and instrumentation, as far as I'm concerned at least, are at least as important for writing good code or achieving good product, if you like, as the compiler and the OS on which it runs. Everything I present today is going to be OS neutral, but I'm going to apply it to the NuttX use case. It doesn't matter if you're running bare metal, if you're running on FreeRTOS, you're running on NuttX, you're running on Zephyr. This stuff is interchangeable and can be used in all of those environments. So we'll start off with a quick recap what Orbuculum version 1 can do, and this is using the SWO output. So what is SWO? SWO is single wire output, and it's available on Cortex M3 and above CPUs, and it's basically this pin here, the trace SWO pin. On an STM32, that would appear on port B3, and the data that comes out of here can be formatted in two ways, in Manchester encoded stream, or rather more conveniently, as UART encoded frames. What this means is that you can just plug a TTL UART onto port B3 and you get trace SWO out at some bit rate or other, which is reasonably programmable. Unfortunately, that stuff is encoded, and so the job of Orbuculum is to decode all of that information and turn it into all that data and turn it into useful information for presentation to the programmer. Where does that information come from? Well, three places, or a couple of places mostly for the purposes of our discussions. The ETM, the Embedded Trace Macro Cell, which is an exhaustive trace of all the steps your program goes through, and the ITM, the Instrumentation Macro Cell, which is much more focused on debug strings and sampling the program counter and things like this. As you can imagine, the amount of data which is generated by the ETM is orders of magnitude more than that which is generated by the ITM. And indeed, for Buckland version 1, and in general, for any probe that's using SWO, they only focus on the ITM flows, or Buckland version 1 only focused on the ITM flows through the system. It did not consider the ETM flows. The ETM flows generally have to use this alternative presentation, which is a parallel presentation with much, much higher bandwidth. In fact, it's parallel and DVR. We'll come on to talk about that later. But for version 1, we did not use the parallel capability. We plugged a UART or some equivalent device onto TraceWO and use the capabilities there. In terms of what the architecture looked like for version 1, then you have your target, which was generating an SWO feed. These are the UART frames coming out of there, and those plugged into the Buckland software itself. Buckland exports a TCP/IP actually port socket to which the various clients can connect for doing different things. OrbCap and OrbFIFO for simple multi-text channel variable output, things of that nature. OrbTop for processing the program counter sampling information, and OrbStat for doing various statistics analyses and things like that. It's worth noting that the control and debug capabilities of the processor, which are generally exercised by GDB or something similar, are independent of the SWO path. So you've got your control path, which is bidirectional here, JTAG or SWD for connection to the target, and the SWO is independent of that and completely separate. And there is a little bit of tension in the distinction between these two things, because sometimes it will be quite useful for the SWO to inform the GDB for various purposes. Let's go on and talk very briefly about what can be done with these kinds of tools. I'm not going to go into this in a lot of detail because the presentation will become over long, and you can go back to the previous presentation for a demonstration of using these tools, or indeed you can go to the Buckland codebase where you will find documentation on how to use these tools and what you can do with them. So OrbCat and OrbFIFO split out the 32, there can actually be more than 32, but for our purposes, 32 debug channels which are independently set over the sent over the ITM link. So you can send strings, you can send ints, you can send characters, whatever it happens to be, with simple primitives, which go over the port and are multiplexed onto that single serial flow that comes out of the SWO pin. And one of the things that Buckland does using OrbCat and OrbFIFO is to allow you to process these, for example, using printf style structures. You can process these things and turn them into rather more sensible strings which make sense to human beings. You can separate things out, so you can have certain information sent to certain debug logs and not to others, and so on and so forth. And then OrbFIFO excuse me, basically gives you an exhaustive catalog via FIFO of the events that are generated by the CPU. So going into an interrupt, coming back out of an interrupt, going back into a thread, and so on. These are not operating system primitives. This is what the processor is doing, going from exception mode, interrupts called exceptions in ARM, into runtime mode, into run mode, and so on, backwards and forward between the two. Those are the kinds of capabilities you get. It's equivalent. Pretty much everybody puts a UART onto their embedded design so they can see what the device is doing when it's executing the program. It's the equivalent of a UART, but it's an output-only device and much higher bandwidth, or the potential to be much higher bandwidth depending on what hardware you're terminating the flow with. Moving on a little, we have OrbTop, and this is the one that generally gets the airtime inside of a Buckland version 1. And what this allows us to do is to generate a top-like trace of where the processor is spending its time. And this is done by sampling the program counter and outputting the program counter on a regular basis, or if the processor is sleeping, special code to say, hey, we're asleep, we're not doing anything. By reconstructing those program counter samples and referencing them against the ELF that makes up the executable, you can turn that back into individual line numbers or files or functions to be able to see what the CPU is doing. And then there's some nice eye candy to be able to plot out graphs and so on and so forth, lots of bits and pieces you can do of that nature. We've also got Obstat, which can do the processing of these raw flows into higher level constructs. So if you instrument the routines for entry and exit to a function and log the fact that you've done entry and exit to a function to the ITM, then you can use that to reconstruct the calling flow of your program. So this is an example of a very simple, this is actually a FreeRTOS thing, as far as I can see from the structure of the primitives. You can actually use this to reconstruct the structure of a program flow, how many times the task switch context called into task out, for example, how many times we responded to an interrupt for either the USB or for the timer. And you can very, very quickly get an idea of exactly where is my program spending its time. And there are multiple views of this. Other people have made some quite nice post-processing visualizations, so we can see things like hot paths through your code. So you can see where your code is spending all of its time. If you've run out of time, this tells you where you need to focus so that you can dig in more detail and fix things up which need some special attention. These are quite static. They're single graph presentations of what's going off in your code with flowdown. If your program becomes moderately complex, that becomes an issue because you end up with a graphic that's way too big and you can't drill down into the particular bits and pieces you want to. This does happen on the PC side as well, and people have built stuff to address this problem, and the most well-known one is KCachegrind. KCachegrind allows you to fly around, effectively around that graph, this graph that I show you here, by clicking on individual boxes, and from there seeing what the relationship of those boxes are to the other boxes inside of the system, and how this corresponds to source code. So I have here the source code for an individual function. This is the relationships between them, and these are the counters in various ways, shapes, and forms for presenting what your program is actually doing. So you can fly around inside of your program and understand where it's spending its time, what instructions it's spending its time on, and on what functions, sorry, not what instructions, and then be able to look to see what you need to optimize. Need to emphasize the fact this is not instruction level instrumentation. This is function level instrumentation, and it requires some instrumentation of your code base in terms of the headers and footers of the functions themselves in order to operate. And the information on how you do that is in the Operculum website. So let's look quite briefly at this thing in operation, and rather than using the UART itself, we're actually going to use the new Optrace hardware, which gives us, remember on the AUP top picture I was showing 4,500 or so samples per second. With the new hardware, which I'm going to talk about after this the demo, we can get much higher flows, and I think in this demonstration you'll see we're doing about 150,000 PC samples per second. So let's do a quick demo of this basic functionality. So what we have here is a box standard STM32F427 chip on a small board, which is called the mule board, connected to the trace device using the extended debug and trace interface. That probe exports a Synthesis app interface, which we can connect to using anything that will talk to Synthesis app, such as PyOCD and OpenOCD. We're going to use OpenOCD today. In fact, just to show you that PyOCD works as well, that will connect perfectly well. There we go, it's connected, it's initialized onto the device. But that's not the one I'm interested in using. Let's use OpenOCD for the purposes of this demonstration. Okay, so it's connected, 10 megahertz connection speed, and we've got hold of the standard device with 6 breakpoints, 4 watch points, all looking good. I already compiled a NuttX image, and I'm going to burn that onto the device now using GDB. So there's a setup script already running, so that, and we will load onto the device itself now. And it takes a few seconds to erase, and then the actual loading process of burning onto the chip. It's done. Now what I'm going to do, because this thing is going to connect under there's a connection under reset, I'm going to cheat slightly and restart OpenOCD, and then restart GDB as well, and then continue. So now, if we look at where we are, we're in STM idle. If I go into mix mode, you can see that most of the time I'm spending in WF idle. So this is all working perfectly well as we would expect it to. What I should be able to do is connect to the USB port. So let's bring another session in here and do a cu-s/dev tty ACM. Don't know which port it's connected to. Let's assume it's 0. Just a bit of a guess. Oh, no. Sorry, -L, not -S. Oh, there we go. We're lucky. Got the right one. Okay, so we've got a nutshell, which is working perfectly well. And we can obviously run OS test and so on. However, what gets more interesting is when we bring Bubble into the mix. So let's bring another window in. And in this window, we are going to run the Bubble server. So that's connected, and it's now issuing 2 network interfaces, which we can use for communication with to observe what the device is doing. So let's bring one more window in. It's getting a little bit crowded, but we'll cope. And in this window, we will run, we'll give it a little bit more room, we will run OrbTop. This is a program something we've seen previously, and OrbTop tells me that the device at the moment is pretty much asleep all the time. It's not doing anything very interesting. So now let's run OS test. What I have done, oops, not sure what happened there, but let's carry on. We don't want to stop that. We'll run OS test and just let it run through its application. So there we go, it's on its way. And as you see in here, we're doing it per second at the moment. We still see the majority of the CPU is sleeping, but the program is running, and we see the activity as it's running, as it runs through. So we start to see effectively a top, which is what we're looking for. I will confess that I have slowed the CPU down by a factor of 4. It's only running at 48 megahertz. And the reason for that is, if you see that we are sleeping for 99% of the time, if I run the CPU at full speed, I actually can't see any of the instructions. There just are too few of them, which gives you some idea of just how busy these devices are capable of being, or how fast they're capable of being. Okay, that's the first step. That shows the use of OrbTrace just as a pretty standard debug interface. If I again come to here and do Control-C, refresh the display, and we can still see we're back in idle mode, and then we can continue. Obviously, everything's frozen here. The sampler is still running, but there's nothing to sample anymore, so it's not going to get too far. But when I continue, then everything carries on as it was, and we still have the nutshell running over here, and we still, you see, we're spending a lot of time in memcopy. Well, a lot of time, 0.35% of our time is being spent in mem copy, and magic is happening over here with all the various activities going on. So that's just showing you using Uptrace as a bog standard debug probe like any other debug probe. Alongside, of course, traditional Ubuculum. Okay, so where we got to in that previous presentation and the end of this recap part of the discussion is Ubuculum working perfectly well over the trace SWI output, and the possibilities and the potential of these trace feeds or these data feeds off the CPU having been demonstrated. So what looks very juicy and enticing is this up to 4-bit port available here, the trace data port. And this stuff the data comes out of here at different clock speeds, but DDR up to 4 bits, so effectively 1 byte per 1 8-bit byte per tick of data falling out of that port. And these data come out so quickly that there aren't any conventional interfaces that will pick this stuff up easily, and so we end up having to use an FPGA. And that's really where we got to the last time around. We said, okay, this is pretty cool as far as it goes, but if we want access to the speed of data that's going to fall out of the ETM source, then we're going to have to go FPGA. So the future at that point promised full profiling of code runs, because access to the ETM allows us to do that. The ability to record things pre-trigger. So I've crashed. What was I doing before I crashed? Non-intrusive, full-speed code path observation, so we can do things like code coverage to understand if our test plan is doing what we expect it to. And of course, we get the other stuff like the full-speed software channel output, the ITM outputs that we were already using, and triggers. So let's go on now and talk about the new stuff, which is Uptrace, Ubuculum, and Uptrace and Ubuculum V2 sort of fit together. So how does this new capability change things? Well, here's Uptrace as a thing, a big orange block just over here on this side, and we add in the parallel trace capability. Now, normally on a Cortex class target, the connector would be a 20-pin 0.05 two-row header, and so on that header, alongside the parallel trace, would also be the JTAG or SWD, and it would be incredibly inconvenient to only take the trace and not to be dealing with the JTAG and the SWD as well. So we included in Uptrace this capability and exported a SimSys DAP driving interface to it, so that your debug stub and GDB can plug straight into here. And typically this debug stub would be OpenOCD or PyOCD or Blackmagic Probe or whatever you wanted, Blackmagic Probe hosted, I should say, or whatever you want to use in order to realize that functionality. So we end up with this Uptrace becomes a single device. You've no longer got multiple cables dangling off of your target in order to realize this functionality. Ubuculum itself plugs into Uptrace and gives us all of the flows we previously had. So we have the debug channels, the PC set channels, we can do the post analysis and so on. But we can do this much faster now because we've got these information flows coming over the 4-bit port rather than over the UART coded port. So we get faster, more data and so on. And as you saw, it was actually 187,000 PC samples per second compared to 4,000, 5,000 PC samples per second when using the UART. But we now have access to the ETM. And the ETM gives us a new flow, which is the full program flow. Now, what we've done here is we've implemented a piece of code called Mortem, which is for post-mortem analysis of programs after they died for some reason. And this is new. This we couldn't do any other way. You couldn't even easily do this with, well, you couldn't do it at all, with something based around interrupts and processing of interrupts, which you can use for realizing some of this functionality. So Orb Mortem is the first thing. That's the, if you like, the flagship product, which is going to show you what Orbuculum can do when used with OrbTrace. But it's not the limit. We can use this full program flow for all sorts of other things that we haven't yet implemented. And one of the beauties of doing all of this stuff open source is that other people can pick some of these things up and scratch their own itches and do things that they want to do. So all of this stuff is open source. You can go to the website, download it freely. It's open under very open licenses, so you can exploit this, extend it. And the only thing we would ask is, if you benefit from this, that you give stuff back when you're able. So you add in functionality to the device or to the code base and make it available for others to use. What does the device look like? Well, this is OrbTrace Mini. The implication being that it will be a maxi or at least a full fat version at some point in the future. We'll worry about that later. But for now, this does everything we want it to be able to do. It has a lattice ECP5 FPGA, which does the heavy lifting from the 20-pin trace plus debug or 10-pin trace only. Debug only port. It does level conversions for talking to targets which are working at different voltages, and we have a number of other pins, various LEDs. We've got 8 megabytes of RAM available, and I think 4 megabytes on the current version of flash for holding the configuration and programs. And this communicates to the outside world over a USB high-speed link. So these, the nominal speed of link is 480 megabits per second. We can get around about 400 megabits per second of real-world data out of that flow. The OrbTrace hardware is a very good example of the benefits of open source and was designed by Ricardo to plug into the Orbuculum overall system. And very shortly, these will be available from his web shop. We are trying very, very hard to keep the price down. The equivalent functionality bought commercially for Trace in the open market is around about $1,500 to $2,000. We've been pushing very, very hard to keep the price of this down, and these will be available for 100 euros, or the equivalent to $120, very slightly less in pounds. But the pricing will be in euros. So we will have these available. We've managed to source enough hardware to build 100 units, even in these chip-constrained times. And what we've also done, because these things are going to be quite valuable, is we've made a case for them, which is a 3D printed case. Now, 3D printed sort of implies maybe not the very best quality and so on. That's not the case here, not the case for the case. This is a SLS printed 3D printed case, and it's properly tough. And the intention is that you can throw this thing into your rucksack or your bag, and it will be protected. So all of the pins will be or appropriately recessed, and you can, to be honest, this thing, you could probably knock nails in with it. It's nice and solid, very high quality case. If you're going to get this hardware, I'm going to finish with the advert soon, but if you do get this hardware, highly recommend you get the case with it in order to keep it safe and protected, because you won't be able to get hold of spares for quite some period of time until the chip shortage eases a little bit. With the case and the board, and it's a project, not a product, so you'll end up assembling the thing yourself. That will be about 130 euros. Because the cases for this quality, the cases are not that cheap to make. Okay, so what can it do? We can power the target, so we can we can set the voltage and measure the current, so we can do that quite quickly, so we can watch what's going off on the target device, what its power consumption looks like. And we have all of the various programming pins for either JTAG or SWD are available on the 10-pin and the 20-pin connector, and also available through individual 0.1-inch headers as well. And you can also use this for programming other devices like FPGAs, and in fact, Uptrace is self-hosting. You can use Uptrace to program Uptrace, and this is the preferred way of working nowadays using an open FPGA loader. You can also monitor the power from the voltage level from the target itself to see how that's behaving, and there are various diagnostics and monitoring going on. Everything should have a general purpose button, so we've got a general purpose button. The 4-bit parallel trace, which appears on the 20-pin connector, plus debug on the 10-pin. Anyone that knows these connectors in reasonable detail will know that the right-hand end of this larger connector is actually a replication of the smaller one. And indeed, with this setup, you can plug your existing favorite debugger into the 10-pin header, and it will pass it through to the 20-pin header, so you can use your existing debugger for debugging and use Uptrace just for the tracing if you want to do that. But if you do want to use it for debugging, we use SimSysDAP, either for SWD or for JTAG. We also have some general purpose I/O, and these will eventually, they're not implemented or they're not operational right now, but they will be used for serial SPI, triggers, things of that nature. These are bidirectional. You can use them for outputs or for inputs. In terms of the architecture inside of the device itself, this is roughly what it looks like. So we're using MyGen and NMyGen for implementation, also Clean Verilog. And we're inside of here within the LiteX environment. We have a VEX. Some of these terms will mean nothing to folk. That doesn't matter too much, just so you can understand the overall structure. We have a VEX RISC-V CPU in there, which we're actually not using at the moment. Everything we're doing at the moment, including the SimSysDAP, is done in gateware. It is not done in software. So this thing is pretty much sat idle, but our expectation is that you'll eventually run NuttX FreeRTOS or something on there for various standalone applications. We have some RAM connected to it, a GPIO. We also have the ability to connect to an LCD, which again we're not using right now. In terms of the Verilog side of the fence, we have the trace interface for taking the data from the device and reformatting it, making it available to the PC. We also have the debug interface, which can do SWD or JTAG for debugging. These are the two physical interfaces here. And then over in MyGen, we have the SimSysDAP capability and Luna, which offers the USB connection. And that all plugs into the bog standard LP to communicate at USB HS rates with the PC. So in terms of the first use of this hardware, we're using it for a program or for a part of the Oberklum suite, which we call Orbmortem. Orbmortem is, as its name implies, all about post-mortem analysis of your program when it's died. So when your program has died or stopped running for some reason, either you've held it specifically, or it's hit a breakpoint, or it's hit an exception or something like that, a hard fault handler, for example. And what it will do is maintain a constant ring buffer of the last amount of execution, by default 32K of execution, but it can be any size you want. And then when a hold occurs, it post-processes that buffer to say this is exactly what was happening when the program stopped. So you get a trace, a post-mortem trace of everything that your program was doing up until the point that it died. Not what you thought it was doing, or what your program listing said it was doing, but what it actually did, the specific instructions in real time that it executed. Now you can imagine how useful that is. If you've ever been stuck in the hard fault handler and wondered how you got there, if you've ever had a line of code executing, you didn't know why it was executing, if you've ever wondered where your CPU is spending all of its time, this is where Orbmortem comes in. So now what I'm going to show you is a quick demonstration of Orbmortem in use, and again as a live demo if you like. Okay, let's this is pretty much where we were at the end of the last episode. We've got org top running, showing us what's going on, which is not very much. The CPU is basically idle, and we've got a nutshell running, talking to the device. If I make the device a little busier, just enter a few enters in there, maybe a little busier, then you start to see some activity appearing in the org top session. What would be really useful is to be able to see the interrupts or the exceptions, as I'll call them, that are going off on that CPU. We can do that inside of org top with a -E option, and that will tell us, hey, this is what's going on with the exceptions. So we've got exception 15, which is occurring 100 times a second. That's hardly surprising. Exception 15 is the systic, and we expect to get a systic every 10 milliseconds. So this is perfectly reasonable. It makes perfect sense. If I start to give the thing a little bit more work, we've now got USB interrupts and all sorts of other bits and pieces, and we can start to see those other interrupts occurring in the table. So again, more work, and you start to see it appear in the org top output. However, it would be really nice to go into more detail than that and see the detail of what was going on with the instructions, and that's where the new tool, Morton, comes in. So, Morton, as it's now started up, Morton, as its name implies, does things after the death of your program. So that death may be due to an exception condition, it may be due to just stopping it using Control-C, maybe due to a breakpoint or whatever. What Morton does continuously in the background is maintain a ring buffer of adjustable size, programmable size, of the most recent instructions that the CPU has been executing. And then when you stop it, it decodes that buffer and tells you what the CPU was doing until the point that it stopped. So initially, let's just put it on hold, hold it there, and you can see those instructions. We can search up through them. Look for the exception entry, because that's more interesting. Okay, so this is an exception entry 15, is a systic interrupt. And we can see before we went into the systic, we did all the various things we have to do, prepared to be in idle mode, and eventually we did a WFI, and then we basically just sat waiting for an interrupt, and at some point later, an interrupt arrived, which was 15, which is the systic. So this is not showing you what you think your program should do or what's written in your text. This is what your program did. This is every instruction. And you can look at this in mix mode, where the files and the source lines and the assembly lines are intermixed. You can look at it just in source form. May not syntactically look right. For example, there can be all sorts of strange coded brackets, because this is the analysis of the source code of the individual instructions that ran. You can look at it in object code. You can look at it as individual instructions that ran or did not run. And you can, most normally, look at it in mix mode. What gets more interesting is when you want to look around inside the code. So, for example, you can put markers on it. So, I'll put a marker for 0.2 there, I'll put a marker for 0.1 here. And you go to the beginning of the buffer and go to 0.1 or 0.2, change modes. And then we can also do things like, for example, if, there's an interesting one, there's a watchdog timer. So we'd like to dive into that and say, in the source code, what does that correspond to? Because although that line is executing, I can't see it in the context of the program. So we just hit the right arrow key, and it will take us directly into that piece of code which it pulls from the disk and delivers it to you, so you can see what's going on. So you can dive in and out of code. That's on the critical section there, so we can look at where that was called. We can dive in and out of code as we see fit, as and when we want to. As we debugging, of course, we know perfectly well that it's quite normal. You don't just want to look at the code, you maybe want to make a small change. So if you hold down the shift key and press right arrow, it will start your favorite editor. And in this case, my least unfavorite editor is Emacs. So that's the one that it starts with. I can go and make a change and come back out and compile or whatever. So the idea of Morton is at any point in time, whatever my program is doing, when it stops, it tells me why it stopped and allows me to dive in and analyze that in more detail. detail. So just for an example, just a simple example, somehow GDP's ended up out of step. Let's just stop in clock timer, which is a routine. Well, we can just do Control C. Control C tells me that's just what it happened to be doing at the point where I hit Control C, which was a WF5, which is what you would expect. Now let's put a delay break on clock timer. Okay, we've got a break in there. Let's unhold it. So it's now waiting because there are no instructions coming in. It doesn't know what to do, so it just sits there waiting for some instructions. And I tell the program to continue. It runs for a very short period of time. And again, it hits the breakpoint. And now what I've got is the history of the instructions until that point in time. So my last instruction should be just the beginning of clock timer. Lots of promising. Dive into there. There you go. What clock timer does is increment the system timer. So yeah, that makes sense. And that's what these are the instructions for the entry. So this all works perfectly well. Now, of course, you can use this just as easily before you can put a breakpoint on the hard fault handler, so you can see exactly how you ended up in the hard fault handler, or how many times have you been coding, landed in a particular location, and thought, I don't know how I got here. I don't know what combination of things happened that allowed me to get to this point. And that's exactly what Autumn allows you to do. So full instruction by instruction analysis of exactly what your program did do, not what you thought it should have done. And that's why it's useful. Okay, so in summary, Trace allows you the ability to trace individual instructions on anything Cortex M3 and above. We've concentrated on M3 and above for now. A lot of the things that can be done with ITM, you can do other ways with interrupts and with program code. You can't do things using the ETM in the same way. It's simply not possible. So org trace, as opposed to just straightforward orbuculum using the ITM, gives you a novel capability you can't really get any other way. We've demonstrated it for post-mortem analysis, but we can do a lot more. The hardware has a lot more capability on it. We aren't using those GPIOs yet. We aren't using the embedded RAM. We aren't using the RISC-V. And on the other side of the board, the bit I didn't show you, there's a 50-pin expansion connector as well. So there's plenty of headroom and expansion for doing more things that we don't do right now. Code coverage, reverse engineering, hot path detection, snapshotting, all sorts of bits and pieces you can do that we haven't done historically because the tools for doing so have not been accessible at a reasonable price point. And we've made all of this open source, so please do come along and help. And it would be greatly appreciated. Help would be greatly appreciated. So I think with that, thanks for listening. There are all the links to orbuculum and OrbTrace. Some people get confused between the two. OrbTrace is the hardware, the device that I showed you, and orbuculum is the software suite, which does both the ITM decode, which can use a device like a UART or a Sega J-Link or whatever it happens to be, but it can also plug directly into OrbTrace for the high-speed decode functionality. That hardware will be available. They've just finished manufacture with the EMS, and they're being shipped to Norway as we speak. And that hardware will be available in the next couple of weeks. There is a limited amount. We only have 150 pieces. Probably going to be a long time before we get any more. So if you are interested in that, there is a hardware waiting list, which is the OrbTrace issue 1. Please add your name to that list if you are interested. If you're intending using OrbTrace, then you need a single unit, probably with a case. If you're intending developing and wanting to work with the FPGA and so on, then we'd recommend you get a pair so that one can be used to reprogram the FPGA of the other. You can reprogram the FPGA over the USB interface, so that's not a fundamental constraint, but just so you're aware. I think that's all we can usefully cover right now. So with that, I'll close out, and thanks very much for listening.
Thank you very much, Dave. That was an amazing presentation. And we are finally coming to the end of our event. So I can see that Dave has already answered the questions on the chat. So we can move to the raffle. Right, Alan?
Yeah, Sara. I was thinking my microphone was muted. Okay. I think we can.
Maju, can you proceed with our last raffle?
Yes, I am just open the spreadsheet and stuff like that.
Hey guys, it were almost, not almost, it's more than 12 hours. I can see here the streaming. It's more than 12 hours. Is Masayuki still with us?
I can't believe it. Oh no.
Here is Masayuki. Masayuki, we are going to let you sleep
Yeah.
in just a few minutes.
Yes, the long-lasting prize.
I am ready.
Okay, Maju,
I will
please
share my screen.
share your screen.
Right now I am stop answers. We have 5 answers. Okay. 2 and 6. Again, 2 and 6. Three numbers.
Maju,
What?
we cannot see your screen.
No.
I'm seeing it, Alan.
I can see the screen.
So it's my internet.
I can stop if you want it. Right?
No, it's fine, Maju. Continue.
Go ahead.
I
No.
try to see from the YouTube. Yeah. In YouTube it's there, but in my JIT it's not.
Okay, again. 2 and 6.
Yeah, now I can see.
2 and 6 again. 3 numbers, right?
Yes.
The first one is 4. 4. Dave Maples.
Dave won't participate. He just sent me a message. So please go to the next one.
Okay, it's okay. Next. 2. André Dantas. So, André Dantas, congratulations. The next one is 6. Jari Kiwon. I think I pronounced like that. The last one, 5. Yoan. Congratulations, Yoan. Now it's done. Congratulations for all the winners.
Yes, just remember, we are going to contact the winners to ask for more information and also to announce the what is the prize. So I think that we can finish the event. I would like to thank you very much for all the attendees to be here with us for all this period. It was a great journey, and I would also like to thank Alin, Alan, Dave Marples, and Maju for supporting this event, for organizing it. It seems to be easy because it's only on the day here streaming to the YouTube, but we had to take care of many details during just a few weeks from the day of the event. So thank you very much, everyone.
Okay.
Thank you, Sara.
Thank you, Sara. Go ahead, Alin.
Thank you, Sara.
Okay, guys. Thank you very much. I know it's not easy to be here during all the day, but you are very strong. You are warriors. It was amazing to have all you guys here, and I am feeling the pain to stay here, sitting all the day, but we need to recover because tomorrow we have more not 12, but at least 10 hours, 10 or 11 hours. 11
1
hours.
hour, 1 hour less.
Yes, 1 hour less, but it will not be easy because today was very, very intense, very, very hard. But this is why NuttX rules, because we are strong. We make our community strong. We believe in this project, and when I believe in something, it will goes on. It will happen. So we need to stay focused. We need to stay together, and let you go far and far with this great project, and let you to more people to know about it, and get more people come together to help us. I really appreciate all the effort, not only we, the hosters and the speakers, but even those who stay here all the day participating in the event. There's not much people there, but at least we have 28 to 30 people still watching all the day. So it's really amazing to see these people here. And tomorrow we hope to get even more people watching. And thank you, guys. We still have 5 minutes if someone has other thing just to close. Okay,
I
Sara.
just have one more information. To be eligible for the raffle in the final of the event tomorrow, you don't need to be only developer. You also need to subscribe to the event, because we are going to use that list, not the GitHub list. So maybe the person is a developer but did not subscribe to the event. I'm just announcing it.
Yeah, that's an important thing. If someone is here watching the YouTube streaming, but he didn't subscribe to that to our email, to our list with the emails and so on, they need to contact us. They need to send a message in the chat to explain it, so we can manually do it or send the link to them to do it, because the winners for the last prize tomorrow will be those from that list.
Did you remove the link from the NuttX event, Alan?
Yeah, yes, it's not there, but we can go back with it.
Yes, I think it's a better idea. It doesn't make it.
Yeah, I remove it because it could be confused, because in the beginning it was just a link to YouTube before you put it as a streaming. And I think we need to think about the idea to put in the stream in the NuttX event, because when the stream is there, people cannot access the chat. So maybe it's better just to put the link and they watch it in the YouTube. So
I updated. I placed it on the link.
Perfect. Thank you, Sara. I think this time is the first time to Roberto and Flávio. So Roberto, thank you very much. If you want to say some words.
Thanks, and you all, because you did a great job.
Thank you very much, and thank you for staying with us all the day. We really appreciate it. You was one of the first one to present your presentation, to do your talk, but you stay here all the time, and you are in all the pictures. And talk about the pictures, let's take the last one. Flávio, Abdelatif, and I don't know if Kusayumi-san will be here, but at least
Kusayumi-san, can you turn your camera on?
Yeah, and let Flávio and Abdelatif also try, and then I take a print screen.
As a summary, Alan, I would say that NuttX is built with passion by passionate developers.
That's true. Yeah, we really love it. So yeah, that's what matters, and maybe our idea, let's take another picture because Abdelatif show here. Okay, thank you, Abdelatif. Maybe we will not be here in the future because everybody died, but
I imagine we'll be here.
Thank you, Sara. I really appreciate it. As you can see, I am already have start to get white hair. So, but okay, we are confident that you and Maju will be able to do a great job. Okay.
I'm not really sure if that is because of your age or because of Sara, but yeah.
I was referring because of my age.
Yeah,
the white hair. The white hair.
Okay, yeah, maybe because of that. Okay, yes. Okay, guys. Thank you very much again. Thank you, Masayuki, for not only stay here during all the event, but you stay all night long with us. So
already also have been contributing too much to mainline.
Yes,
no problem.
Yeah, as we can see tomorrow in the Alin presentation. Yeah, Masayuki is a hero. Thank you for all your great work, Masayuki. And you are not only a hero to contribute to mainline, but you was the first one I am aware that go in the Linux Foundation and the Linux embedded Linux conference and talk about NuttX. It's a very important thing. You open NuttX for many people through that initial presentation in 2007, how was it? 2017, right?
Yeah.
The first one. Yeah, 2017. And 2018, we presenting together in Portland. Yeah. So, thank you, guys. I hope tomorrow we will be here again.
Yeah.
So, and tomorrow I will wear pants. Okay.
Please do so, Al. And tomorrow we're also going to have more stories about people and NuttX.
Yeah, let's see. Maybe tomorrow Abdelatif can talk his history, how he gets in contact with NuttX. and so we have more people to talk their histories. Okay, guys, have a good night. Masayuk has a nice day, but please sleep during the day to stay here tomorrow at night.
I'll see you today. For me too.
Bye-bye, everyone.
Bye-bye, everyone.
Bye.
Bye.
Bye-bye.
Bye bye. See you tomorrow.
Bye-bye, Alin. See you tomorrow.